Hello.
Hello again. Can
Hello.
yeah,
So how will we do the opening?
I propose we will open our,
I will say some words. Yes.
if you please.
Mhm. Maybe you can say some statistics about this year edition. How many papers we have?
29 papers.
Okay. Mhm. I hope that Borat will find it. I sent him this morning again the link. 7 minutes.
Yeah. Invited speaker Burak Gulmez already connected yesterday, I see.
Good.
Then he has this link.
Mhm. Let's be optimistic that he will connect.
Yes. Good afternoon, dear colleague.
Hi.
My
Hello.
name Alexander Gozhi.
Yes.
Yes.
So I'm a bit wondering if Borak is finding his way. Our invited speaker. I sent him this morning an email and he has not yet, I didn't get reply, nor did I see him logged in.
Yeah, I not seeing him.
Ah. What are we going to do? He's not logged in time. That's a bit embarrassing. So it's time to start. And we are still waiting for the invited speaker to log in. So I would like already to say some words about the MoMLeT conference. And then we will see if he is there. Otherwise, we will have a short break. Hopefully, he find his way to connect.
Yeah.
So let me say some things about MoMLeT. And this is the 6th edition of the MoMLeT workshop and MoMLeT 2025. So welcome to this workshop. And it's a workshop that has been held since 2019. And the first edition, we were in Shatsk in a nice camp, in the Lesia holiday camp or students' camp. And it was a nice occasion when we all met, and we are dreaming of the times when this is again possible. So this year it will be online format, and we have been also unlucky in the years before.
Да, ну, в смысле, не выпендривайся. Нам нужно этот Львов как-то про...
Due to different reasons. Hello,
Вот я думаю сейчас.
can you mute yourself, please?
Already done.
Okay, so the reason why it is online has been different since then. So there was COVID epidemic, Russian aggressions that continues until now. So as said, it would be nice to meet again in person one year, but for now it is an online format, and I hope that everybody enjoys this format by participating in the talks of the scientists. We have a nice program. We have 29 papers that will be presented, reported today. They have undergone a peer review with an international review panel, and all of them have been accepted for this conference, and they will be considered for the proceedings that will be high workshop series. And this series is indexed in Scopus, DBLP, and papers will be made available in an open access format. So it is a valuable contribution to the international scientific community that can also be referenced. And today we will see the presentations of these new scientific results. The WS workshop has very strict rules, and to make sure that the quality is high in times where some conferences are not so high quality and more instrument to make money. Our conference definitely is non-profit, so we make it in a way that everybody can contribute, and only the quality of the contribution should be the criterion to participate. And what else is there to say about the conference? We have different partners who organize this event. First of all, I should mention Dimitro Dosin, who with me has organized this event since 2019, and they were changing compositions of the team. And we have also ongoing support from people from the Montfort University in UK and University Institute in Lisbon. And I might have to mention, I should mention also Victoria Vitoshin. Did I say it correct? She is very hard working on our proceedings and organizing the event in the background. And I think in the moment she's in the Germany. So, but she's from Lviv University originally. So what else is there to say? I'm happy to see many participants here. And I see also the invited speaker for this year. So we have the tradition that every year there's an invited speaker who opens the conference. And this year I'm very happy to see Borak Gülmez being the invited speaker. And his topic of research is very interesting to the scope of this conference. At least it's a topic that is related to machine learning, but also to optimization engines. And as you know, these topics go hand in hand. So when you want to build optimization engines, you need to have knowledge in machine learning and vice versa. You need machine learning techniques and data science techniques to build tools for optimization, for planning, and timetabling, logistics. And Borak will give us an introduction to this topic from his own research perspective and touching some very modern issues in this domain. So Borak, can you maybe unmute yourself and show? So I will say a few more words. So maybe we can see you when you talk. Okay, good.
Hello,
Thank you.
everyone.
So I will say a few more words, how we know each other and what is your research. So Borak is a dedicated researcher to the field of logistics and optimization and machine learning techniques used in logistics fields, and also in various topics touching as many topics as healthcare, agriculture, machine learning, for explainable AI, and so on. And he has been working in,
Multi-objective optimization and hub system also.
Yes. So you can also add some things. I wanted to say that you have a very broad background, and much of your work is focused around the multi-objective optimization and logistics topics. And you have been working in Turkey.
Yes, new name is Turkey.
Yeah, so it used to be Turkey. So, but Turkey is now the way we should pronounce it. And we have you were in Ankara and in Kayseri.
In Bursa now. I'm working in Bursa. No, yes.
Bursa. And in between, you had done a postdoctoral fellowship in Leiden University before you became associate professor. And
Yes.
at that time, our paths crossed. So when you did this this step to professorship as a postdoc in Leiden University some years ago. But I would like to give the floor to you, and you can say more about the topic, and I hope that the audience here enjoys the topic and gets some inspiration from it. And also we have time for questions, hopefully. So we have until 9:40 for the talk, including the discussion.
Yes.
So the floor is to you, Borak.
Okay, should I start now?
Yes.
Okay. Yes. Maybe. I am trying to share my screen. Can you see my screen?
Yes, very good.
Okay. Hello everyone. Today I will talk about multi-objective optimization for the hub type systems for logistics. Maybe I can introduce myself firstly. I work in Turkey at Mudan University. I am associate professor. Then I was in Leiden University with Michael and Yingchi as a postdoc. Then I worked in Turkey generally. My research topics are generally AI, meta-heuristic algorithms, and transportation, multi-object optimization, logistics. Logistics is a little bit complex nowadays because it is a modern system. Modern logistics requires complex decision support systems. We have to consider loss of difference aims, not only cost. And customer happiness is important. For example, Amazon distribution network is very complex. They do not think only for the money, also fast, also environment. So we have to follow the rules and we have to improve our logistic systems. Firstly, I will introduce the single objective optimization classical approach. Classically, generally, we use for one objective function, we have one objective or we have one aim. It is minimizing or maximizing something and we have some constraints. For the logistic, you can think we are trying to minimize the cost or minimum distance or maximum capacity. It is a classical way. For example, it's a TSP problem. You have 50 address and you try to give the package to address, and it is simple. But the problem is it has only one dimension. We consider only the cost. For this problem, we can work on multi-objective optimization. In the multi-objective optimization, we have lots of different objective functions. We are trying to maximize and minimize different objectives at the same time. Because in real life, one objective is not enough generally. So for example, I can give some examples: minimizing cost, minimizing delivery time, minimizing emission, or maximizing customer satisfactions. For example, you can find alternative objective functions. So this approach is more modern approach. I don't know, are you really, do you know the mathematical model concept? But if you want to work on it, you can find lots of Python libraries or programs. I can suggest it because it guarantees 100% optimum solution. It is different from the heuristic algorithms or meta-heuristics. It guarantees you will find the optimum point. Maybe I can skip this. And this graph explains multi-objective optimization in the best way, I think. It is and simple. If you look the graph on the left, you can see it is a classical mathematic problem. You can see there is one local optimum, one global optimum. So normally we are trying to find the optimum point. It is a classical way. But in the modern times, if we use multi-objective optimization, we have more than one objectives. If you look the figure on the right, you can see we have two objective functions. and we have lots of solutions. You can see the green points are feasible points. All of them are a solution, and blue colors are also their solutions. But the best points are the blue colored points. You can see there is a line, red line. It means that it is Pareto front of this problem. It means that we have not only one, we have lots of optimum solutions, but every solution has two different objective values. If you look the yellow point, it is infeasible solution because we have some constraints. If you look the red point, it is utopia point. It is impossible point. It means that, for example, cost is zero, customer happiness is maximum, but in real life, it is not possible. This graph shows the multi-objective optimization in the best way, I think. This is two-dimensional graph, but in real life, you can make three-dimensional, four-dimensional, five-dimensional. There is no limit. And also, generally, we are trying to find all Pareto solutions, and decision makers or managers tries to find the best for the company they select, and also customers evaluate the results. Why multi-objective optimization is important? Because, for example, companies don't just want profit. Also, they are thinking about the customer satisfaction, or they have to follow some rules, sustainability, and some emission values. Also, for the complexity, modern logistics is multidimensional. We have to solve different objective functions at the same time. Single solution cannot solve all the problems in the same time. For example, Amazon, Amazon, their speed. Also, they are trying to decrease the cost, increase the quality. At the same time, they have to follow lots of different objectives. Also, multi-objective optimization is better than single models for the real world complexity, and it is better. And there are lots of different multi-objective optimization methods. Generally, they are based off the genetic algorithm, but modified for the multi-objective optimization. You can, if you are related to this subject, you can look of them. If you want to work for multi-objective optimization subject, you can find lots of libraries, Python libraries you can find. Also, I will talk about a little bit transportation, logistics, and hub system. Nowadays, in the complex systems, demand is increasing every time, and customer wants fast, cheap, reliable, and environment deliveries. So we have to think about more than one objectives. And for the classical approach, if we want to make delivery distribution, we have some classical approach, point-to-point distribution. We can send the goods to customers one by one, or we can use one vehicle to give the goods to customer with one vehicle or multiple vehicle. They have some problems because if we use separate vehicles for every customer, it will be very costly and not effectively, and it will be very bad for the environment and traffic problems. If we use one vehicle, also we will have some different problems. For example, long distances and some capacity problems. So hub system is we need to hub system to handle this type of problems for the big size of the distributions. Also, airlines uses the hub systems. For example, if you will go from London to New York, you can find lots of flights London, Dubai, New York route. So it is a hub system. Or cargo companies use hub system very effectively. And you can see one figure on the right. It shows a hub system. Actually, in the hub system, you divide the big size problem to smaller sizes. For example, if you have 3 hubs, you divided your problem to 3 little small size problems. So solving small size problems is more effective than the solving the big size problems. And also, hub system is important for the economy of the scale. If you increase the scale of the one transportation, it will be cheaper. For example, if you transfer one package from point A to point B, it will be costly. But if you transfer 100 pieces, it will be cheaper if you think about the cost per piece. Also, it is important for the frequency. For example, sometimes you cannot find enough frequency to transfer something from one point to another point. So you can use hub system. Hub system collects different demands and makes a big demands. For example, if you want to go from Madrid to Vienna, maybe you cannot find flight because there is no enough demand. But you can go to first Frankfurt, then Vienna. You can use Frankfurt hub as a hub point. Also, it has some operational advantages. Management is a little bit easier, and for the cost, for the standardization and flexibility. So, if you want to work for the hub problems, you can select hub location optimization, and you can combine hub location optimization and multi-object optimization. You can find new objective functions. You can write new papers, or you can create new projects. You can solve problems using mathematical modeling or meteoristic algorithms. Meteoristic approach, you can use the Python libraries. There are lots of Python libraries for the multi-objective optimization. You can combine of them, logistic, hub system, and multi-objective optimization. There are lots of ideas about it. Okay. Also, you can you can use variable neighbor search methods. It increases the solution step by step, one by one. It will make local Pareto improvement. Also, you can use some clustering methods for the machine learning clustering methods. You can combine both of them for the hub locations. Also, not only for the hub locations, you can use different objective functions, different ideas for the VRP, for the hub systems, and different results. I put some examples from my papers. For example, in this paper, you see the Istanbul map on the right. We divided to Istanbul to 36 hubs, and we tried to find the prediction of the number of customers for every hub. For example, it was a paper 3 years ago. We used CNN and LSTM model. Also, you can use some predictions using AI, CNN or LSTM. It is one research idea. For example, when I was in Leiden, we worked on a multi-objective green delivery system. We created new objective functions. We considered cost, minimizing the emissions, and maximizing the customer happiness. You can see 3 different maps. All the rows are optimum for the different objective functions. Also, it is another research idea. You can find different objective functions and improve the transportation system or distribution system. Nowadays, we are working. Also, we finished the paper. We will submit for the hub system. If you look the figure on the left, we have one depot and different hubs. It is a 2-level problem. We are working on it nowadays. It has 2-level problems. We are trying to solve level 1 and level 2. It is one improved VRP hub and hub problem. For the research opportunities, you can write new, for example, projects, new papers on new research opportunities. You can use multi-objective optimization methods for the hub locations or for hub systems, VRP systems. You can find new objectives. You can improve the systems. You can adapt the green logistics to your hub systems. It is very popular nowadays, green logistics. Also, you can work on the smart cities, autonomous vehicles. Also, healthcare transportation is popular nowadays because time is important also for this type of the problems, not only cost. For the health, time is important, and you can combine your work with different type of vehicles, train, flight, trucks, for the distribution systems, modern hub distribution systems. Also, you can adapt different last mile types to your works. For example, there are lots of different type of the last miles. For example, one is you leave the package in front of the door, for example, or you give the package to neighbor. Sometimes people goes to one hub point to get the package. Also, you can combine with last mile types with hub. Also, airports generally uses the hub system very effectively. You can work on it, or you can make hybrid of the systems. Thank you very much for listening. If you have questions, you can ask to me, or you can send email to me. Thank you.
Thank you, Borak, for giving the talk to us and giving inspiration also for future work in this domain that is still developing, and there are many nice research opportunities. So are there any questions from the audience to Burak? We have time for questions, roughly 10 minutes.
Maybe I have one question for Burak, if you please.
Please go ahead.
For page 9, you show orthogonal system of objectives, but very often we have contradiction between objectives. For example, fuel versus speed, or another contradicting objectives. How to do with such cases? Because not every time is orthogonal objectives.
Yes, sometimes it depends for the objective functions. For example, costs and customer happiness is reverse. If you increase customer happiness, it will be increase the cost. But sometimes, yes, you are right. If you find the shortest path, maybe it can be the cheapest way. So they doesn't have to be reverse, but also they how to say, also they change. For example, one objective function increases one size, the other objective function can increase 5 size. Maybe the ratio can be different, and this figure is designed for the reverse objective functions and minimization. Of course, we can change it. We can modify it for the maximization type problems and the same way type of the problems. Also, maybe if you look the F1 is minimization, F2 is maximization, and also F3 is minimization, but F2 and F3, the second objective function and third objective function, is on the same way. It is
So
normal.
Mhm.
But generally finding the reverse objective functions is better, I think. But if it is not like this, if it is different, it will become similar with single objectives, but still it has different types, different number of the solutions, because scale is not every time one by one. If you improve one thing, the other objective function can improve maybe 5 times, 10 times. Sometimes, so it can make, they are parallel, but you can choose the best solution. If all the objective functions are directly parallel, it will be a single objective or very similar to single objective.
Okay.
I can say that.
Can you, I would like to say something about these conflicting objectives. So in this nice plot of a Pareto front, I think you can also see that there are many solutions that are dominated. The green solutions and the blue ones are non-dominated. So that means that the green ones can be improved in all objectives still. Whereas the blue ones, they cannot be improved in all objectives at the same time anymore. So there's this kind of blue Pareto front. And these are the solutions that are interesting to consider, because we have to here make some concessions, some compromises. And sometimes there are sweet spots, like near win-win situations that are almost optimal in all objectives. Then we are happy because we can take these solutions and we don't lose very much in one of the objectives. but it depends on the problem. It can also be that there are strongly conflicting objectives and there is no nice compromise solution, and you can at least look for a fair solution that is in the middle. But the problem in itself determines the shape of this Pareto front, right, Borak?
Yes, maybe this graph is
We
not
cannot
very
change
clear.
the problem. We can only. The problem is kind of determining how much conflict there is. But we understand after the optimization what kind of conflicts are found and which objectives are conflicting, how much in the optimal solutions.
Yes, but I put this figure because maybe I think it maybe some people is not familiar with
Yes.
this multi-objective. So I tried to explain the most simple way. Of course, we have lots of different type of the cases for different problems.
Yes.
For logistics problems, we can handle different of the difficulties, but we can use multi-objective optimization for different type of problems. So every problem has own difficulty and some complex problems.
I would like to ask also a question.
Okay.
So this multi-objective optimization is, of course, a topic on its own, and it's very applicable in logistics. But I have a question about how artificial intelligence can be used in such problems, because we have seen so much revolutions in artificial intelligence and other ways that you can use artificial intelligence techniques or machine learning techniques in improving your logistics planning systems.
We can improve some algorithms, multi-objective optimization algorithms. Also, we can combine with local optimization and multi-objective optimization techniques, like maybe. For example, you can see a list of the multi-objective optimization methods. We have different algorithms, NSJ to NSJ3 or different. We can combine with local optimization methods and them. Also, maybe for the logistics.
Yes, this is interesting. So you use here machine learning. So what do you predict here? And how do you use the methods in the optimization?
It was the first step of our project. 3 years ago, we had one project, shared taxi project. We tried to find the number of customers for the future to place the taxis to best waiting points. We divided Istanbul to 36 hubs or different areas, and we tried to find the number of customers for the next hours, next days. For example, CNN and LSTM method, we use it. For example, this is one way. Also, another method is the clustering for the machine learning methods. We can apply different clustering methods for the distribution of the customers for the hubs. It is another research area because there are too many clustering algorithms. Also, we can combine the clustering algorithms and neighbor search or something. Also, we can use explainable artificial intelligence methods for the multi-objective optimization. For example, we can take the effect of the route for the cost, for the delivery time, for the emission. For example, we can see the effect of the parameters on the objective functions using explainable artificial intelligence methods. For example, shape values. So
Mhm.
it can be helpful for the decision makers when they select a point from Pareto front. For example, one Pareto front can be more effective for this business. Maybe they can analyze it using explainable artificial intelligence methods. Also,
Especially
there are,
consulting. Would that be interesting for high dimensions when you have many criteria to consider? Because then it's more complex than looking at the Pareto front. You cannot look at it anymore.
yes. For example, in another project we made maybe 4 or 5 years ago, it was about the optimization of the timetabling of the trains. We had 6 different objective functions. So it is very hard to select. Also, it is very hard to making a figure because it is 6 dimension. Mm, we can see on the paper only 3-dimensional effectively. So if we use it explainable artificial intelligence methods, we didn't use on that project, but if we use it, we can analyze it better.
So it's an interesting direction also, this explainable AI for interpreting optimization results. That's,
Yeah.
and you said also that machine learning is used in prediction of demand.
Also
Uncertain
for
demand.
clustering.
Mhm. I think also for you could use it for traffic jam prediction. There might be obstacles on the road, and they are also uncertain. And
Yes, for example, general drivers select the sometimes if drivers don't like to city centers because there are lots of traffic lights, traffic, too many people. Sometimes they choose the long way
Mhm.
because they uses the car very speedy. So also the prediction of the traffic is another opportunity to research. Or there are too many different ideas, and also they can make hybridizing hybrid of some research ideas. So
Mhm.
it makes the problem more maybe complex and
Okay,
better.
very interesting domain to study. And I like that it's a domain where different methods come together, like machine learning and optimization techniques, and maybe also the human aspect of data science. So, like collecting data, it's probably very important here.
Sorry,
Yeah,
Yes,
but
we have
also
any
two
questions?
questions.
one person asked a question from the chat. I
Yes.
saw
Oh, nice. Yeah.
Elina Tereshenko asked, what objectives do you think could be implemented for green logistics? Uh, it's it's about the emission generally. For example, you can choose the truck type or car type. One car can use or one truck can use benzene, diesel, gas, or electricity. If you use electricity, it is better for the environment, for the green logistics. You can use the hybrid vehicles or different vehicles in the same uh, distribution network. So it is one optimization problem. Also, we are working on it. We use the big trucks uses diesel oil, and we have needle trucks for the in city. Uh, they use electricity. For example, it is a good example for the green logistics. Not for only cost, not for the customer happiness. Also, we should think about the environment and also emissions. We can use the electricity cars. Also, there is one problem for the electricity cars. It is charging time. Sometimes it takes half hour to charge. So half hour is important for the transportation and logistics systems. So you cannot use every time electricity. Sometimes you have to make some combination.
Thank you. Thank you.
Yeah.
Okay, thank you. We have time to
Presentations.
yeah
I
yeah
think we now can start the presentations if there are not more questions. And we thank again our speaker, Borak, for
You are
preparing
welcome.
the invited talk. It was very interesting. Thank you.
I want to say thank you also.
Yes.
Okay.
So please contact Borak if you have more questions about this topic, and there will be opportunities to collaborate also, I guess. Good. Let's continue with the main program.
I see Anna Bakurova has some maybe
Yeah, I have one question.
Okay.
Mm,
very short, please. No,
Dear Burak, you show fourth multi-criteria problem, but on 29 slide, you represent only three criteria. Why?
we said already we had many
Ma-
areas, but for example, on the three.
An example, maybe.
Yeah.
Only for example. Yeah.
Which one? You said 29?
Slide 23.
29, 29
29, sorry.
slide.
Maybe I can show you a bit. 29. Yes. This is our paper published previous year. In this problem, we have three different objective functions. One is minimizing costs. The second is lowest emission. The third is highest satisfaction for the customers. Maybe if I give the details, you can see three different maps. For the minimization of the cost, you can see the points, the customer points are red color. It means that customers are very unhappy. And you can see the lines are green and yellow. Yellow is long distance. It means that we use a diesel. If it is green, it means we use electricity. So for the minimum cost, you can see customers are very unhappy. The lines are we have three long lines, yellow lines. So but the route is effective. But if we consider the emissions, you can see the system made one yellow line, sorry. So it is very good for the emission, but it is not very good for the customers and the route, because you can see there are lots of lines. It means that the cost is very high. If you consider the third graph, highest satisfaction, customer satisfaction, you can see there are lots of green points. It means that customers are very happy. Also we have some unhappy customers, of course, but the route is very long, so it is very costly, and you can see we have three yellow lines, so it means that it is very bad for the emission rates. So we have to make a balance of them. We have too many solutions. I put 3 examples here, 3 sharp values. So in real life, for example, we can make a combination of the minimum cost, maybe 50%, emission rates, maybe we can give 25%, and customer satisfaction is 25%. It depends for the decision makers.
Thank you, Burak. I need to interrupt you because we are running out of schedule. We are already in the time slot of our first speaker.
Okay.
I hope that the question was answered. And otherwise, please contact Burak and he can explain you more on this question. But we need to proceed that we keep the time schedule.
Yes,
Thank
okay.
you.
This is my email. You can contact with me.
If there are more
Thank you.
detailed questions. Thank you very much. And let's
Thank you.
proceed with the main program. And we are now 5 minutes. So we have to move a bit. The first speaker is Svitlana Popereshniak and Dimitro Chonoprivyets on real-time parking space monitoring system based on computer vision. Please share the screen. Bora, can you stop sharing? Thank you.
Yeah. Did you see the screen?
Yes.
Yes.
Okay, let's start. Good afternoon. Today I will present my work. It's real-time parking space monitoring system based on computer vision. Let's begin. It was developed by Svetlana Poperchnak and Dmitry Brevets. This presentation outlines an intelligent system for monitoring parking space occupancy developed to address the growing urban challenge of parking scarcity and inaccessibility. Our system leverages cutting-edge computer vision technologies, particularly employing a YOLO deep learning model for reliable vehicle detection and utilization spatial analysis without predefined region of interest, ROI, to access occupancy status. The problem. Rapid urbanization increased vehicle ownership have placed immense pressure on city infrastructure, leading to a critical shortage of parking spaces. This daily struggle for parking results in waste time, increased fuel consumption, air pollution, and traffic congestion. Traditional parking management methods often fail to provide scalable, cost-effectively, and real-time information, while sensor-based alternatives can be costly to employ and maintain. Our solution to address these issues, we develop a real-time parking space monitoring system using computer vision. It employs a YOLO deep learning model for occupied car detection and analyzes occupancy with region of interest, built with Python, OpenCV, and PySide 6. The modular desktop app supports real-time visualization, an Intuitive ROI editor, dynamic opportunity mapping, and configurable setting via YAML files. Okay, here we can show balances of speed and occupancy in the real-time task. It's YOLO model. YOLO processing image is a single pass, dividing them into a grid, where each cell predicts bounding boxes and class probabilities. Detected vehicle are then analyzed using geometric region, which each parking space is deflection as a polygon. A space is marked as a community if a car center point falls within its corresponding ROI. The system was developed using a combination of powerful tools. It's Python, OpenCV for frame handling, geometric analysis, graphical rendering, the Ultralytics library with PyTouch for YOLO model implementation, teaching, Python and YAML for configuration and data management, and PySide for GUI operation. And we have one more library is PyQt dark theme, it's only for change theme on the dark and the light. Okay, the ensure height community and chains car recognition underway environment conditions such as variable lighting, occlusion, and variable inference typical of urban Ukrainian settings. A multi-stage dataset comparison method was employed. This avoid collection and many labeling a special dataset from footage of parking lots, initialization, normalization, including resizing image to a uniform result, resolution, and normal in pixel values, applying various image technologies as a random brightness, rotations, and scaling to enhance the model generation capabilities. And where was pre-trained YOLO V11 model was fine-tuned on the custom dataset to account for local environment factors, improving detections, robustness. Key findings and impact validation on test video dataset was confirmed the system ability to perform occupied and responsive detection under various conditions. The detection model based on YOLO V11 consistently demonstrated high accuracy rates and detection precision of over 92 percent across device test case. The system real performance processing video streams at the average of 25 frames per second on a mid-range GPU platform. The system developed system offers a practical, scalable solution and visualization-oriented mechanism for monitoring parking occupancy. It's provided drivers with dynamic real-time feedback on monitoring available, helping to minimize driver search times, full compression, and is system more effective urban mobility management. Next slide. Future direction. The developed prototype system a scalable foundation for other enchantments, including its first deploying core accuracy by transition from center point based computing detection to EO-based analysis and retraining the YOLO model on a target dataset to better fit local parking conditional. Next, it's for exploiting functionally for real-time support for IP cameras, streams to its mean RTCP protocol. Maybe next it's license platform recognize LPR integration and analyzation modules for parking usage statistics. One more, it's integration with smart city infrastructure. It's in the future. In conclusion, I wanted to say the study present for develop and validation of real-time parking space monitoring system based on computer vision technology, leveraging the YOLO V11 deep learning model and parallel ROI-based analysis. The system achieves high levels of occupancy and responsible integration OpenCV and PCI-6 enable real visualization and flexible configuration, and proposed system offers scalable effectively and urban parking management, contribution to improve traffic flow, reduced environment impact, and enhances user convenience. Thank you for your attention.
Thank you. So there's time for some question. Are there some questions from the audience? Please unmute yourself. Otherwise, I have a question. So first of all, I would like to know what you do when you not recognize correctly the parking sign. I mean the number plate. So what would you do in this case? Is it self-assessment of the accuracy?
Okay. if you mean about number plate,
Mhm.
I don't know how it say it. Maybe I told in the future, because current in my system, the current system disseminates parking space community by detection the persons of cars not be reading number plates,
Mhm.
but license plate recognizing is planned in the future
Okay.
enchantment for the system. How I
Mhm.
say it, how I see that, I think when in the system will be save information about license plate, maybe who parking in his space, and he I know one problem, it's when driver can forget about where he parking the car. It's
Okay.
yeah,
Mhm.
it's I
Okay.
think
Thank you.
good for this. Yeah, when
Are
you
there
see in
any?
the map your car.
Yes, this is very useful information, especially for big parking places.
Yeah.
I I have another question, but I would prefer someone from the audience. Then I would ask a brief question. It's you on one of the slides you presented a multitude of tools that you use, like PyTorch and many other tools, YOLO. How do you manage these tools to work together in your system? What is the strategy here?
About my strategy, wait second, I go now to my slide.
So how do you connect this software?
It was easily because it was on the Python. Python can connect everyone these libraries, because Ultralytics have library in the Python. YAML is too in the Python,
Mhm.
and another one because I don't know how it is. It's like desktop software, and we can get this from only how it is. Okay, YAML it's config file, and he combine all the files.
Okay, so
Take
you use
information
this YAML.
from
I
take
understand.
information from YAML dataset
Mhm.
and OpenCY. When to uh, like manage internal configures, making the system flexible to easy to adapt to different environment.
Thank you very
Just it.
much. I think I got the idea. So you use this YAML and
Okay.
OpenCV as a base, and then you connect these libraries and programs through this. Thank you very much. I think we are ready for the next speaker.
Thanks.
If there are not any urgent questions, so we will continue with the and thank the speaker very much.
Yeah.
The next speaker is Peter Bidyuk and Irina Kalina, Alexander Gossier, Vitor Gossier, Sergei Shishyan. An approach to combining forecasts when solving machine learning problems.
You see?
Yes, we see.
Yeah.
You can make full screen if possible.
Yeah.
Thank you.
Good afternoon, dear colleague. Let me introduce myself. My name is Gozhi Alexander. I'm a professor of the Department Intelligent Intellectual System, Pedro Magela, Black Sea National University. The topic of my presentation, an approach to combining forecast when solving machine learning problems. Today, forecasting is power method and resource demand management. A number of companies, Zuha, Amazon, Uber, Airbnb, and many others use forecasting to predict future economic indicators and identify hidden trends in data to develop strategies for future activities. Recently, machine learning methods have been used to solve forecasting problems. Forecasting based on machine learning method allows you to comprehensively take into account the future of dynamics processes that are reflected in the time series, on the basis of which the forecast will be built. Forecasting based on time series is important for various fields of activity, such as medicine, economics, industry, energy, etc. The complexity of this problem is increased by the presence of nonlinearity and non-stationarity in the yield data, as well as various types of uncertainty, such as statistical structure and parametric uncertainties. The problem is solved based on a systematic approach to modeling and forecasting processes. Important features of the system approach are compensivity consideration of future and uncertainties at each stage of solving the problem. Bazuk, an approach although it takes place from the point of view of methodology, does not always provide the necessary forecast accuracy. To increase the accuracy of forecast value, various methods and approach are used. Also, effective approach to improving the quality of forecast on time series in use of method for comparing forecast value. Problem state. To investigate the futures of the forecast combination process, two, the development and approach for solving time series forecasting problem based on combinant forecast. Three, to experimentally confirm the effectiveness of forecast combination method for solving machine learning problems. In next slide, present the stage of solving forecast problems. The schema is presented as sequence of the following stage: data collection, analysis, and preliminary data preparation, modeling or training models on data forecasting, and determining the quality of forecast, improving the efficiency of models. At the first stage, the input data set is collected and preliminary analyzed. The result of the first stage is a data set ready for future processing. The second stage is designed to eliminate statistical uncertainty in the data. At the stage, missing value for individual features and observation identified and processed, anomalous values and noise are identified. Data correlation analysis, autocorrelation level is performed. The modeling stage, third stage, is designed to consistently eliminate structure and parametric uncertainties. The fourth stage is a stage of building forecast and assessing their quality. In this case, a system of quality indicators metric is used. The fifth stage is designed to improve the efficiency of basic forecasting models. The following approach are used for sync: changing the model structure, selecting model specification, refining the model topology using conditional algorithms, ensemble approaches, and using various methods of combined forecast value and visualization. Visualization helps to adjust the sequence of actions at each stage and quickly identify possible shortcomings. Depending on the specific in the subject and the data set, it is possible to re-examine any of the previous stage. Combined forecast. The approach to modeling and forecasting based of combination method. With is development of the basic of the systematic approach to the modeling process includes the following basic computational procedure, procedure for analysis and pre-processing data set, procedure for dividing the data set into separate samples for training, validation, and testing. A modeling and forecasting procedure, a procedure for assessing the quality of modeling and forecasting result. A procedure for combining forecast using different methods. The result of the presented procedure is a forecast value for desired horizon value, which has better accuracy and is determined by the analyst for decision maker. The structure diagram of the approach to forecast based of combined forecast is presented in figure 2. You see in the next this slide structure schema of the forecasting approach. First stage, data analysis and pre-processing. Two-stage data set prepared for modeling, data distribution, and three-stage modeling and forecasting. And next stage, evaluation of modeling and forecasting results into combined forecast and final forecast. Experiment. Data preprocessing. The dataset for combined forecasting study reflects information of electricity demand in Ukraine from 2018 to 2024. It contains hourly data on electricity purchase and sale volumes, as well as demand for it in megawatt in the Ukrainian electricity grid, and the price of electricity starting from 1st July 2018. The dataset has 17,000 observations, each of which is characterized by 10 variables. Among them are the data as a string and the hour represented by an integer which we converted to the time data format. The analysis of time series show that the load the Ukraine power system has changed since 1st June 2022, and system has been loaded evenly, therefore to build forecast models. We separate a part of the time series that reflect electricity demand from June 2022 to October 2024. And next slide, you will see electricity demand.
Dear Alexander, you have last 2 minutes for your report.
Oh, yeah, excuse me. You see four models, basic models is general additive models. In this slide, present the result of checking the accuracy of GAN models in the test data sample, and exponential smooshing model, and result of checking the accuracy of ATS model on the test data sample present in this slide, and ARIMA models, result of checking the accuracy of ARIMA models in the data sample, and neural network models, neural network after regression models. Result of checking the accuracy on neural net models on the test data sample. In this slide, present the graph of actual electricity demand values and forecast using the best forecasting model, and comparing forecast. In this slide, present the result, the best quality model based on the simple averaging method is presented in this slide against the background of forecast obtaining using the best basic forecast models.
And conclusion. Yeah, okay.
Conclusion: to
Very
solve
short, very short.
the forecast, the solve to forecast problem, forecast combination method, we use it to obtain combined forecast based on the forecast of the best models. Among the combination methods, the simple averaging method has the highest accuracy. The proposed approach is effective for obtaining point forecast of time series. Thank you for your attention. Excuse me, please, your questions.
Thank you. We have time for a short question.
I have a question, please. So, if can your system solve the problem when data is not consistent across the series? So, as you showed, the data should be like from some date to some date, and should be each date should be like data should be in each date. And what to do if you have not consistent data? So you have some data, some graph with data, and then you have some missing places. So
Yeah. Thank you. These are very interesting questions. It's two main methods for improving forecast accuracy are ensemble and forecast combination. It's time series. It's a very important method presents the data for forecast forecast problem. But when comparing is necessary to take into account the ratio of the variance of the basic method, that is, the method must be selected. That comparing forecast will involve. Excuse me. In addition, the method of comparing also affect. The method, the best method is averaging. Excuse me?
yes, understand. I understand.
Hello. Can you see my screen?
Yes, we can see the screen.
So shall I start? I guess. Okay, I guess I just go forward. Hello and good morning. I'm Asu, and I work in the Finnish data and AI industry as a senior data scientist, and also work as a doctoral researcher at the University of Jyväskylä, Finland, in the cognitive science group. My research interests revolve around alignment, intentionality, and AI safety. Today, I'm glad to present our findings on an investigation about moral understanding in large language models. Just 5 years ago, AI systems were limited. They could identify images, translate languages, and could do several other tasks quite well. Since then, advances in deep learning, large-scale retraining on diverse dataset, and reinforcement learning from human feedback and human oversight have led us into a new era of generative AI. Today, AI is reshaping both industries as well as our daily interaction with computers. Yet, as these systems become more independent and start making decisions that impact real world, a pressing concern arises. What if the true danger isn't an AI that causes the harm, but one that never understands what harm actually is? AI systems are stepping into roles with real moral dilemmas. You can imagine yourself driving a self-driving car, and that is faced with a split-second life or death situation, for example, or a chatbot choosing to reveal your private confidential information because it believes that is in your interest. Consider hiring algorithms used in companies, for example, which can silently filter you out, convinced that you do not align with the company's culture. And perhaps the most disturbing and most hypothetical situation, imagining AI prioritizing its own survival over human lives. These scenarios demand we test AI not for competence, but for conscience. What does it even mean for doing something good or bad or right or wrong? Do all humans share the same moral standards? A thought experiment known as the Moral Machines tried to explore these questions. It uncovered some consistent patterns. People generally choose to save more lives over fewer and prioritized children over adults. But it also revealed significant cultural differences. For example, moral decisions varied based on local customs, regions, and societal inequalities, which influenced who participants were more likely to save. Building on these findings, we designed our own study to examine how large language models understand these moral concepts, shifting from focus from simply observing large language model decisions to exploring the reasoning behind them. Imagine you are just walking down the street when two different incidents occur. In the first, a young child on a bike rounds the corner too fast and loses control and hits you. In the second, a food delivery robot diverts off its path and hits you as well. Both incidents are quite similar and they leave you startled. But do you react the same way? Do you feel empathy for the child's mistake and annoyance for the robot's failure? These instinctive responses reveal something deeper about our moral instincts and highlight challenge for AI in understanding them. True moral judgment requires more than rules. It involves context, trade-offs, and reasoning. And our aim is to understand how these different things are handled by AI, especially the moral complexity part. In our experiment, we developed 6 high-stakes moral vignettes or scenarios, each with 3 exclusive options: principled, conformist, and avoidant. We prompted 5 state-of-the-art open source models to choose from these 3 possible options and ask them to justify their reasoning behind their decision. We kept the generation parameters fixed for all the models and gathered 10 bonds per scenario, amassing over 300 responses for our in-depth analysis. Let's see what our conscience conflict framework looks like and how it differs from existing framework. Unlike simple yes or no tests, it forces models to weigh real-world dilemmas, making a decision and justifying the decision. Here you can see one of our dilemmas, which provides 3 options for the language models to choose from and provide justifications for its decision. We then analyze their justification to find out emergent moral traits from their justifications. To make sense of these models' free text justification and choices, we map their reasoning onto 7 classic strands of normative ethics. Utilitarian arguments that aim to maximize overall well-being, deontological rules that insist on following fixed moral duties, virtue ethics that focus on cultivating good character, fair ethics that emphasize the importance of human relationships, justice-centered views that focuses on demanding fairness, and pragmatic approaches that seek the most workable compromise between the alternatives. And finally, moments where the model does not know what to do and it's uncertain about those. That comes under the moral psychology and conflict. As the moral dilemmas grow more intricate, the model's reasoning begins to deteriorate, and this is one of our main findings. At times, they offer a straightforward utilitarian argument. Other times, they appeal to rigid deontological principles, and occasionally, they avoid the question completely. Each models reveal a different ethical personality, and none of them manage to maintain a consistent moral viewpoint across varying scenarios and vignettes. When we coded each choice against our ethical framework, we saw some clear tendencies emerging. In scenarios involving discrimination, some models defaulted to rigid rule-based reasoning, and in interpersonal conflicts, others fell back on care ethics and pragmatic trade-offs. However, no single model adhere consistently to these moral orientation across dilemmas. So what are our key highlights of the study? First, by presenting high-stake dilemmas that require both a decision and a rationale, we move beyond simple right or wrong assessments to capture the full complexity of moral judgment, which has been done quite some time in the space. Second, we observe that the large language models don't hold to a single ethical doctrine, but oscillate between them depending on the text provided. By focusing on the reasoning processes rather than just the outcomes, we uncover the rationale of the LLMs that outcome-only benchmarks often overlook. And finally, our framework provides a roadmap for guiding future AI research towards safety, consistent human-aligned moral behavior. Looking ahead, our future work will hinge on 2 central questions: understanding and behavior. Can we develop methods to verify that AI genuinely understands these moral concepts rather than merely parroting learned patterns from the huge amount of data that they have been trained on? And once equipped with that understanding, will the model reliably translate its understanding and reasoning into consistent, trustworthy actions when faced with real moral dilemmas? By tackling both of these in depth, for example, the moral understanding and moral behavior, we aim to close the gap between ethical theory and AI practice. As we move into the future and entrust machines such as large language models with profound authority in different applications and use cases, shouldn't we demand that they not only calculate the outcomes, but understand the ethical weight of those outcomes? That's my short presentation. Thank you for your attention, and I'm happy to take questions.
Okay, we are ready for questions.
Well, may I ask a question?
Very short, please.
Very short. There are many There are many mathematical models describing process of making decisions and of interaction between people and computers and about behavioral aspects. Did you try to harness some of these mathematical models to make your exploration more profound and theoretical based?
This work was more sort of basic research, understanding how large language model understand and perceive these things. But as you mentioned, we do have formulations of these models. For example, researchers in Finland have made contributions, especially in this area where they consider humans as adaptive agents working in environments and constraints. And that way we could model the same way, for example, large language models as well. And one of our current focus is to integrate these cognitive aspects into the understanding of LLMs and the way LLMs are trained and the way they infer during interaction. So that's one of the things that we're currently focusing on. And in theory, it is possible, but current way of training language models are not taking this into account, which will be kind of needed in the future for sure. So thank you for the question. It was really interesting.
Thank you. Maybe
Thank you.
our questions. Yes, thank you. Please, the next speaker is Natalia Hatsko, Andrei Kop, and colleagues.
Cool.
Please share the presentation.
Yeah, give me a second to do so.
We try to be strictly in timeline. Therefore, please be care.
And do you see my screen?
Still not. Yes.
No?
Yes. Okay, please.
Okay, so hello everyone. I am Kirill Khatsko, one of the authors of our work for file name and methods in electronic data interchange, enhancing message distribution efficiency. So aim of our research is to improve ADI system. I will talk a little bit later about it. In a way to make sure that it will be faster, but not just that, in a way to make sure that this system can handle errors and problems in network itself and can continue working even if some nodes are not working at the moment. So we trying to update the method how we send EDI messages. We don't touch on the receiving part of the messages. Our idea how to improve it, the first idea is to extract meta information from messages itself and bake them inside of naming of files, because file names are part of the system. It will show later in the graphics. And the relevance is that we had communication with actual businesses that actually do use ADI systems. For business, this is pretty much critical part of the business, and this systems often fails, not only on their end, but maybe it could be on partner end, and it still blocks whole system and whole interactions with all other business partners. Let's skip this for now to make it short representation. So ADI is a system that helps to change documents between businesses. As the factor right now, it's used for improve shipment and whole infrastructure part of the business. And usually these messages about paying, ordering, shipping, and canceling, everything related to this part of the businesses. It can support X12, Edifact, and a lot more XML, but mainly we will concentrate on X12, Edifact, and XML file structures, file types. It has the ADI message has a file itself, which is a message. It has a name for this message, which is file name. Again, it's repeating because this is a really old system. It's almost 40, maybe 50 even years. It's actively used. And it's the system already exists and working, but it's based on really old technologies and really old ideas. Therefore, there are some parts of ADI messaging between businesses that are not improved according to newest approaches how to do messaging in the first place. This is example of a message. So this example of XML and Edifact message, they are essentially the same. Edifact a lot better messages in when our internet was slow and time was critical for internet communication. XML message a lot better for human readability, even XML is machine readability format in the first place. But on the left, you can see a lot more details than in the message on the right, because everything encoded in the message on the right in Edifact. Usually, in real-life businesses, file names for these messages are, as you can see examples on bottom right corner. It's order with some kind of abbreviation. It could be type of message, order, invoice, something more, and some kind of key which has meaning for the business that created messages, but has absolutely no meaning for the business that receives this message. And we actually trying to improve it on sending end of the communication. This is typical implementation of DA on sending side of the business. So this is the part that sends messages from the business to all partners. So we have storage that will storage for files that actually, again, files and messages are the same for now. It has incoming storage for messages or files. This is the same when a business has created them. They send to the system, and the first goal of the system is to actually store what is incoming from the business part. It could support many formats, but almost every system as of now actually encode everything to one of the formats. For example, we will use XML because it's a lot more readable in the backend phase. We have storage, and we have two pipelines. The bottom pipeline is conversion pipeline. This pipeline does get all incoming files which are not XML, read them, and try and convert them to XML format. ADI is pretty much a really simple system. As a standard, ADI is pretty much really simple, and it's not that much information in the files, except in meta part, which is not changed. And it's easy enough process to do conversion of files, but still it's change the order of incoming messages. It will be important later. And this system still has spending time and part of failure, which is the way the current systems built in businesses. This part could be a fail, and this fail will lead of fail of the whole system, as how they implemented now. The second queue is the most important queue. This is part of actually ADI itself. So this queue taking a file from top to bottom, so FIFO. They taking files from the storage. They read this file, convert to ADI message, and send this message to the network, sending to the selected partner. And each partner, yet again, receive messages to work that business can handle. The storage on the right is a storage from another ADI system implemented by another partner. Storage on the left, receiving messages both from business itself to send them and from other partners to receive them, but this part is not represented right now because first part of our research is actually to speed up sending part of the message. We not talking in this work, we are not handling receiving part of the messages in ADI. The problems. The problem is that this queue is de facto linear, and if any partner cannot receive the message, the whole system on your side will be blocked. This is the main problem we're trying to receive. And another problem is that we constantly rereading and re-updating messages. Therefore,
last 3 minutes for your presentation.
yeah, speeding up. So our solution is to read message first on the stage of putting message to the storage. We reading this message on the moment when we converting this message. We extract all needed information from message itself. Firstly, it's about partner address and urgency, etc. We encode this message to the file name, as this is one of proposed solutions, how to encode this information to the file name. And when we go into the actually processing queue, we can rearrange order of sending. We can change what messages are important, which are not. We can send firstly important messages. We don't need to reparse file to get information how to send the message. We actually can do it on the fly because all meta information is already inside of queue itself as a file name. And therefore we speed up both speed of the system and we lowering the chance that system will fail because we send the chance that priority messages will be sent during the day is increased because we send them first, and the chance of the error is lower because we do less actions. This is preliminary tests when this is testing part of queue and sending part. This is two items, processing queue and file processing service. When we try and reorder, and instead of reading file, we already have encrypted all information about file inside of file name, and we can constantly send files without spending time on rereading messages. This is examples of the experiment. This is overall end-to-end tests of the system. As you can see, we have gains from 16 to 34% of speed. Therefore, we have actual real measurable result even without quality of the system. And the conclusion is we achieved result. We are proud of it. We have something to show to the business. We think that this is really a powerful tool to work with because we can encrypt a lot more information and find a lot more usages for this kind of information. Therefore, we can improve receiving part of business as well the same way, almost the same way. We can improve stability of the systems, and we can even improve reordering by importance of the systems if we have more information and business have a lot more complicated rules how to do what kind of ordering by priority business is expecting. Thank you, everyone. Is there any questions?
Thank you very much for this talk. Any question time? We have a bit of time, so please I have a question about this. So what are the next steps in this development? How are you going to further improve the system?
Yes, as I told you, we have a couple of ideas. First, improve receiving part of the system. Second, provide additional algorithms and ideas on requeuing, reordering element of the system to make sure that we prioritize the most important part of messages for the business. And this idea is almost endless. We can use AI algorithms because business does not always understand or can describe what business wants. So it's often we need to work with too much data and extract values for the business, show some competitive results for business to select what business wants. It's not always easy for business to explain, especially in mathematical way, what business wants and how to achieve it. So I think the reordering part is most critical. Actually, it's not that important in our part of research. It does not provide a lot of speed, but it is most crucial part for the business itself because it helps them to speed up the critical part of business, but by slowing down not critical part of the businesses. And has infinite part because every business has their own rules. It can be changed, fine-tuned for every business, and even inside of one business, it's can be done, spend a lot of time fine-tuning, and changing with businesses how it should work.
Thank you.
Thank you for this insightful answer. I think we got the idea that this is a crucial part, but there are many possibilities and many businesses. I think we need, looking at the clock, move on to the next talk. So thanks the speaker once more. Thank you.
Thank you.
Let's move on to the next talk. So the next talk is by
Alexey Oletsky, please.
Alexey Oletsky.
Oh, but I see a black screen on my notebook.
Maybe you can share the screen.
I can nothing. I see a totally black screen.
Why?
Oh,
We can see you. Why?
we can see your camera.
But I can't see nothing.
Maybe you can log in again.
Oh, now it's okay. Well, I am sharing my screen.
Mhm.
Do you see now my screen?
Yeah, we see your screen. There's a
Yes.
program.
Well,
So you can make it full screen and then.
yes.
Yes. Okay, please start.
I'd like to present our investigation about modeling change of opinions as transitional probabilities within the model state probability of action. Well, this paper is devoted to the social modeling of process of voting in parties in democracies and of changing opinions of voters. It is an agent-oriented modeling, so agents within this modeling are voters, and it is based on the model state probability of action, and we are suggesting the way to combine it with the analytic hierarchy process. Well, this is the basic one level model state probability of action, which it is the probabilistic model of decision making considering states associated with probabilities of choosing certain alternatives. So it formalizing the process resulting in making decisions, e.g. voting, and it is represented by such a matrix, and this is a probability that an agent shall choose the certain alternative when it is being in the certain state. And we are trying to formalize how to get these probabilities. And we should specify a vector of input probabilities which determine which state is an agent being in. And if we do this, then in one level model, final probability of decisions can be obtained in such a way. Well, forgetting the matrix state probability of action, we are using, there are a different way to get such a matrix. And in this study, we are using this model with three parameters, which basically values of alternatives are obtained from the pairwise comparisons and analytic hierarchy process, and we are using not the standard 30 scale, but so-called transitive scales. And after getting values, we get probabilities itself by using this parameter, which stands for decisiveness of agent. The more is this parameter, the more decisive is an agent. And we are introducing two-level multi-criteria model, which considers takes into account specific criteria affecting the decision. There are many ways how to combine different criteria, and now we are using rather simple logical rules. If the alternative is better with respect to a specific criteria, it is better in general. And then we are getting mathematical formula for getting final probabilities. If we are trying to apply this theory to the voting of bipartisan democracies, then the number of alternatives equal 2, because there are two main competitive parties. And what is very important is situations of equilibrium, which is a situation when no alternative, no party have advantages over other. We are we got the sufficient condition for situations of equilibrium. This condition is sufficient but not a necessary conditions. Those are only symmetrical conditions. And if you look at the meaningful interpretation of using this model for voting, then a state corresponds to the level of preference of one party to another. Input probabilities stand for confidence of voters. Change in state means change in opinions about certain political parties. And now we are studying transitional probabilities, which stand for dynamics of changing opinions on the basis of different influence and different factors. And the very important question is which sort of Markov chain Markov chain for describing changing opinions should be to represent the real process in the most adequate way. And what should be mentioned? We can regard this Markov chain to be homogeneous, but it is a very constraining assumption which is unrealistic, because if there is enough time to establish stationary probabilities, that the own possibility for parties to change each other in tone is when permanent equilibrium of alternative holds, and this is absolutely unrealistic. And we are suggesting some alternatives to explain the real processes in more adequate way. First of all, this is homogeneous Markov chain with switching rules. When states are bound not just to specific parties, to their rules, whether they in power or not. But it is this condition is restricting as well between it if this were absolutely true, this would mean perfect regularity of change and winners, because either one party will be in power all the time, or when if one party wins at the current elections, it will definitely lose at the next elections. And we observe another situations. Then we are going to study some variations. First of all, to regard non-homogeneous modeling. It is well known that it is difficult to build the theory of non-homogeneous Markov chains at all, but we can at least simulate it by means of the following formula. And another positive assumption may be homogeneous chains with, well, Markov chain is homogeneous, but with random transitional probabilities. So when transitional matrix basically doesn't depend on time, but it is a sum of the constant transitional matrix plus random noise. And we actually carried out such simulations, and they gave results which are near to the behavior which is expected. So,
Conclusion, please. Use last minute.
yes. So there are some ways to explain real processes, but their theoretical base is difficult for investigation. But we are trying to do something with this. We are trying to explore game aspects and some models of spreading information and its influence on changing opinions and to changing transitional probabilities. Thank you for your attention. I am ready to answer your questions.
You not leave time for questions. Sorry.
Sorry.
Let's make a short question. Well, if there's a question from the audience on this, I have a very short question. So you use AHP, and there are other models for decision making. Do you consider also other decision making models from MCDM?
Do you mean
Like Topsy?
Markov change? How it is? Markov process of decision.
Yes.
We are considering such a possibility, but actually it's only in our plans. Now we are just combining analytic hierarchy process and the model. This is my own model suggested earlier, but it has been constantly updating and reviewing. We are thinking about MMDP, but maybe in some close future. Thank you.
For your answer. And let's proceed with the next talk and thank the speaker. So we have now a talk by Olivier Petriac, and I saw him in the audience. Yes.
Hello, everyone.
Please unmute yourself and share the screen.
Can you hear me now?
Yes.
Okay.
But little bit loud.
Screen.
Oh, better.
Loud?
Okay, good.
Okay.
But you have 10 minutes for report and 5 minutes for answering questions.
Yes. So today I'll present our research titled Exploring YOLO Architecture for Detection of Ukrainian car license plates and images. Our research aimed at evaluating different generations of YOLO models, specifically to detect Ukrainian vehicle license plates. We wanted to find out which of the YOLO architecture would give us the best balance of accuracy, speed, and reliability. Additionally, we tested this model thoroughly across various real-world scenarios, including Cyrillic plates, electric vehicle plates, and American-style plates, and challenging conditions like poor lighting, angled views, and unusual plate placements. YOLO stands for You Only Look Once, and it's recognized widely for its excellent real-time object detection capabilities. The strength of YOLO lies in its abilities to detect objects quickly in a single pass through the neural network. Its architecture includes a feature extraction component known as a backbone, an exit aggregates features to improve multi-scale detection, and a head responsible for predicting bounding boxes, object classes, and confidence scores. To objectively compare different YOLO models, we relied on critical metrics, widely accepted in machine learning. Precision, recall, mean average precision at the intersection over union at threshold of 0.5, and mean average precision average across the U thresholds from 0.5 to 0.95. To provide a single unified evaluation score, we combine these metrics into a weighted measure called fitness. These fitness scores emphasize overall model quality by assigning specific weights that prioritize detection accuracy, particularly at the most challenging scenarios. We carefully selected these weights, giving high importance for the MAP 5095 matrix, which reflects the model's ability to consistently detect objects accurately, even when bounding box varies slightly from the ideal position. In our study, we select specific weights for each matrix. Precision and recall each received weights of 0.1, MAP 50 a weight of 0.3, MAP 5095, that is the most critical measure, received a weight of 0.5. For our research, we collected approximately 11,500 images of Ukrainian cars from open online sources. To accurately identify license plates, we annotated each image using CVAT annotation tool, labeling the plates clearly with bounding boxes and assigning a uniform class identifier. The dataset was divided into the training and testing subset, with 10,000 images used for the training and the remaining 1,500 reserved for evaluating model performance. The training involved running each YOLO model through 100 epochs, applying consistent settings across all models. When detecting license plates in new images, our trained YOLO performs a three-stage prediction process. Initially, input images are resized to match the network's required input dimensions. Then the neural network predicts the potential bounded boxes along with confidence scores. Finally, these predicted boxes are rescaled and actively mapped onto the original images, providing precise and practical decision outcomes. When evaluating the YOLO model's performance, we observe the YOLO V9 achieves the most favorable balance between detection accuracy and speed. This makes YOLO V9 particularly suitable for applications that require real-time detection. Also, YOLO V11 shows strong accuracy. It was slower and struggled more noticeably under challenging conditions. We conducted the first experiment to evaluate how effectively each YOLO model identifies different types of recurrent license plates. Spectacularly, we selected images with green plates for electric vehicles, plates containing Cyrillic numbers, characters, and American-style license plates. These plates variations reflect practical complexities that any real-world system would need to address, such as different fonts, colors, and layouts. Our task demonstrates that all YOLO versions provided a generally reliable and accurate detection, closely matching the actual position of the license plates in the standard scenarios. The bounding box coordinates predicted by the most models were near identical to the ground truth. However, YOLO V11 showed some notable deviations, particularly under angle views or unusual lighting condition. This inconsistency highlights areas of fuzz optimization and reinforces YOLO V9 as a better choice, offering a consistent performance across varied plate types. In the second experiment, we deliberately tested the YOLO models under more demanding and realistic scenarios. We select images featuring license plates viewed in sharp angles, captured under poor lighting condition, or located in non-standard positions. These scenarios represent the common real-world challenges that any practical detection system would regularly encounter, thus providing an essential robustness test for the models. The results reaffirm the overall robustness of most YOLO models in handling difficult detection scenarios, with minor errors attributable mostly to challenging angles or poor lighting. However, YOLO V11 consistently showed greater inaccuracies, indicating reduced reliability in complex situations. This second round of testing confirmed YOLO V9 position as the preferred model for real-world application, as it delivered consistently accurate and stable results even under the challenging conditions presented. Based on our extensive testing evaluation, we identified YOLO V9 as the optimal model for detecting Ukrainian car license plates. It offers the best trade-off between processing speed and accuracy, providing particularly effective for real-time scenarios, while our results confirm that YOLO models are generally robust. Certain challenges remain, especially in the poor lighting and reviews on usual plate positioning. Going forward, our research will aim to provide the models adaptability to these challenging scenarios and integrate this technology into practical surveillance and traffic monitoring systems. Thank you for listening. Feel free to ask any questions.
You were very precise on the time. So we have time for questions now and discussions.
Great.
I have one question, but I would like to give the floor to the audience first. So otherwise, I would start with asking you about the YOLO models. So you have YOLO models of different versions. Can you elaborate a bit on how these models differ and why not the most recent model is the best?
So when I was this one. So when I was exploring different models, I saw that after fourth or fifth, it has very different changes. And mostly some models are bigger, some are smaller. So more computation, less computation. So I was testing which one with the minimum layers, with the minimum computation will give us the best performance, especially, trade-off between performance and speed. So even, for example, in our case, YOLO V11 is the latest one. It had worse performance than YOLO V9 in a very complicated scenarios. For example, for these images where license plates photos are not perfect, YOLO V11 for some reason predicted more height than it should, but the older YOLO did better job.
Thank you. So interesting that sometimes not the newest version is the best in all aspects. I would like to ask another question, but again, you can unmute yourself if you have a question. So then I would like to ask my second question. It's about this car license number detection and uncertainty quantification. So what do you do when you are uncertain? Do you use this information in the system? So if the prediction says, well, I have not a high certainty that this is detected.
Yeah, I understand. Besides predicting the bounding box, it also predicts confidence scores.
Yes.
Like how sure it is that this is bounding box. And you can set different thresholds for if you consider this license plate or not. So it's okay that image don't have license plates. Actually, it was such cases was in the training set, and it can detect multiple license plates on the image.
Thank you for the answer.
Maybe I have the next question. How do you implement software?
Sorry, it's hard to hear.
How it is implemented in software?
I was using PyTorch and of course Python. And for notation, I was using online service CWAT. It's abbreviation.
Or is this system already used in practice, or is it in a prototype stage at the moment?
No, it's prototype stage.
Interesting. So feel free to ask more questions. Because we still have a bit of time until the next speaker, who will start at 11:15, and we should probably use this time to ask questions. And if I would have the opportunity to ask one more question, I would like you to talk a bit more about YOLO, what it can do for you, for those who don't know this system. So what is this YOLO system about?
So basically, it's was introduced instead of recursive neural network, something like that, to make prediction in single goes through the neural network. So it improved the speed performance of the neural networks at all. And nowadays it's used for most complicated computer vision projects.
The computer vision mainly, right?
Yes, yes, I think yes, it's on computer vision.
Yes, thank you very much. So there are more questions? Otherwise, I would ask the next speaker to already start. So
yeah,
I think we finish.
Okay. Next.
Give the time then to the next speaker. Thank you, Rolling.
Thank you. Bye.
So the next speaker is Olya Yaholenko, Andrei Krop, Mykolaio Godlevsky, Dimitro Orlovsky, Natalia Kasko. Is there someone from Andrei? I see you.
Yes, hello.
You can share the screen and you can take the time.
Okay, one moment. Can you see my screen?
Yes, we see your screen.
Okay, thank you. May I start?
Yes.
Okay, dear colleagues, it's my pleasure to present our study towards information technology for BPMN models quality assessment based on intelligent theory. The paper includes the following structure I present today. It includes introduction. I will explain state-of-the-art related work and the formal problem statement, as well as the materials and methods, including the proposed technique results and obtained results and discussion, and conclude and outline the future work. So the effective internal workflow management is extremely important for organizations. Business process represents sequences of tasks, decisions, and events, and the graphical modeling helps to understand, to improve, and analyze business process in enterprises. This field is known as BPM, or Business Process Management, which integrates management and IT to enhance workflows. And the BPMN is the key standard. It stands for Business Process Model and Notation for documenting process. It ensures clarity for both technical and non-technical stakeholders, and this is why it's de facto standard now for process descriptions. In general, process models help to communicate, to ensure product and service quality, and achieve organizational efficiencies. And this is why business process models should be of high quality. So our goal is to enhance BPMN models quality and prevent workflow errors due to their possible structural issues. And the object of research is the procedure for assessing the quality of process models, and the research subject is the intelligent information technology for evaluation of process models quality. There are various notations exist. All they help to analyze workflows, but BPMN is the leading standard due to its capabilities. It provides intuitive graphical representation because of the use of core elements such as events, activities, gateways, control flows. It also supports branching using logical operators or gateways, as we call them, and conditional flows, loops, and other complex structures. It also uses pools and lanes to separate roles and responsibilities, and this is why it's suitable for both simple documentation and also for complex automation tasks, because of BPMNs are not only images but also executable scenarios of workflows. So the business process modeling helps us to bridge the gap between business and IT through visual representation and also executability of such models. It therefore helps to enhance transparency, workflows monitoring, and performance assessment. And this is why models quality is essential for the success of business process management projects. In the related works, there are considered different structural metrics, basically originated from software engineering, that help to estimate size, complexity, logic, control flow logic of BPMN models. Also, related studies consider qualitative aspects like understandability measurement, maintainability, how these affect the usability of BPMN models. Different evaluation methods include not only software engineering metrics, but user surveys to provide expert judgment to assess BPMN models quality. There are different modeling rules and guidelines exist in the field that help to ensure syntactic and semantic correctness. There are also structural attributes we can consider to discuss models' efficiency, like elements count, connectivity, etc. And also many studies and authors propose thresholds for these metrics obtained using data mining or by expert judgment. So the problem we consider basically consists of three main steps. At first, it's extraction of BPMN elements, features by processing BPMN files as specially organized XML documents. then identification of incorrect BPMN elements to describe process models as binary vectors, and then assess the quality of BPMN models using weighted sum equation to also take into account the weights of different business process model elements. And the general scheme of this approach is demonstrated here on the slide as the step-by-step process. The functional model of the proposed intelligent information technology presented here includes 4 main steps. It takes BPMN model file, process it to extract BPMN elements features based on the XML schema analysis and parsing, then identification of incorrect BPMN elements using modeling rules I've mentioned before, and I will explain them ahead, and assessment of BPMN models quality, also using the weights of different process model elements. As for the modeling rules, the following 6 rules or guidelines are basically used that say start events should have 1 outgoing flow, intermediate events should have 1 incoming and 1 outgoing flow, boundary events should have 1 outgoing flow, and events should have 1 incoming flow. Activities like tasks or sub-process should have also 1 incoming and 1 outgoing flow to not introduce some logic, but the gateways should have either 1 incoming and 2 outgoing flows for splits to branch process, or 2 incoming and 1 outgoing flow for joins to merge the process. These rules were formally described as predicates as presented here in the table in the bottom of this slide, and the comparator network for incorrect BPMN elements identification is proposed. It's based on intelligent theory and predicate logic to formalize human-like reasoning. It's designed as connectionist system and used to identify incorrect BPMN elements by comparing model properties to expected rules. It uses indicator functions to evaluate structural features of each BPMN element, and this proposal enables automatic assessment of BPMN logic consistency using modeling guidelines introduced before. So as for the business process element weights, they show how it's important for the model correctness and basically how each element impacts on the model's quality. We have used already present in the field estimates for BPMN elements based on their impacts presented here and calculated as the as the weights for using this equation. The software implementation part is developed in Python using standard libraries for file processing, for data processing. The software tool reads BPMN model files from the file system using OS package, the standard one, parses BPMN files as XML documents using the standard XML package, analyzes model structure and logic to assess quality for BPMN model based on the predefined metrics and rules that were introduced before, and calculates element weights, applies the proposed network for validation, and finally stores the quality assessment results in CSV files for convenient analysis and reporting. The general algorithm, can be said, of the developed software component is demonstrated here. It shows all the steps, inputs, and outputs. The proposed technology was tested on 3,729 BPMN models from Open Camunda's GitHub repository. Only 7 models were failed to process because of the incorrect XML markup. However, the remaining were successfully processed by our software. The results show that 25% of the processed models have the general quality score calculated between 0.49 and 0.94, which is quite high. And the remaining 75% have quality values above 0.94, like 17% belong to the second quartile, 33% to the third quartile, and 4% have perfect estimate between 0.99 and 1, the maximum value for the quality indicator. And as the example, I would like to show sample BPMN models analysis. This model describes goods dispatch process, which happens in a small hardware store. And there are 6 incorrect elements that were detected using the proposed technology, the software. For example, like E1 shows improper parallel gateway that increases process complexity. E2 shows missing start event. E3 shows missing logic after the gateway because it just like the leaf. E4 shows the incorrect use of event. It should be boundary event instead of intermediate. E5 shows missing end event, so process finishes with no conclusion. And E6 shows that task package goods is used incorrectly because it should be a join gateway here, not a task, which can lead to logical mismatch and deadlocks if the process is automated or improper understandability by humans who will use this model. So to conclude, we address the problem of quality analysis and improvement of BPMN-based process models. The proposed intelligent information technology is using intelligent theory, mathematical apparatus. It considers extraction of BPMN elements from the files, identification of incorrect elements using modeling rules, and quality assessment via the weighted sum of element evaluations and their type-specific impacts. We have found that in the processed collection, 97% of models have very high quality, bigger than 0.79, and demonstrated model with the typical modeling issues. In the future, we plan to apply machine learning methods to predict models' quality and also use fuzzy logic to handle uncertainty in modeling rules because they are strict now and may not reflect the model's quality precisely. And also, we plan to use deeper analysis of syntax and semantics and also complex collaborative process models. Also address size, complexity, constraints, and model optimization to fix the detected issues of BPMN models. And this is all. Thank you very much for your attention. I'll be glad to answer the questions.
So we have 3 minutes, so that's time for a short question. And maybe there are some questions from the audience. Please unmute yourself in that case. Otherwise, I would have a short question. You have shown that this is a similar architecture to the neural network. how does the training process or something similar like the training process show up in this analogy?
Yeah, that's basically what I meant here. Because of this is based on predicates, there is no training process there. It's based on strict predefined rules like here. And this is why I mentioned we plan to assume the use of machine learning techniques also with fuzzy logic to handle the uncertainty. So if some measure goes beyond or above the threshold, now it's strict, but we can say that, for example, something is bad and something very close is good. We need to differentiate it, and this is why the next step should be introducing also the fuzzy logic here.
Okay, this will be interesting. Yes, I agree. And then I have one more comment. There's this trend of using explainable AI in machine learning. Have you considered to add some explainability to these models?
Yes, I'm working on it now. Also using large language models to provide instructions how to fix detected issues, or maybe because the BPMN is also a code underneath the pictures, how to automatically fix these issues.
Thank
Yeah.
So I think
Thank you very much for the questions.
Thanks for the answers, and we need to move on looking at the clock. So let's continue with the next speaker. We have now Yuri Krak, Alexander Matsuret, and Alexander Ovcharuk, Mariana Molchanova, and Alexander Barmak-Glacier Azanovsky. Thank you very much. Please go ahead.
Hello everyone. Can you hear me? Can you see my screen?
Yes.
Yeah, great. So, my name is Alexander Ovcharuk, and today I would like to introduce our work, transformer-based multi-label classification for identifying hidden psychological condition in online posts. With the rise of the digital technology and social media, user-generated content has become a valuable source for accessing psychological states. This issue amplified in the digital environment where much emotional expressions occurs online. Traditional diagnostic methods such as clinical interview and questionnaires face limitation in timelines, objectivity, and contextual relevance. Therefore, there is growing need for automated method using machine learning and deep learning to analyze digital communication and improve early detection of hidden psychological conditions. Modern multi-class classification system used for detecting hidden psychological conditions are limited to identifying only the most pronounced state, disregarding co-occurring conditions. This results in missed opportunity for early intervention and the potential oversight of clinical significant symptoms not aligned with the dominant class. To address this limitation, it is advisable to implement a multi-label approach supplemented by ensemble of binary class and carefully constructed training dataset that account for cross features among psychological conditions, thereby enhancing both the accuracy and clinical relevance of diagnostic outcomes. The main goal of our paper is to create a multi-label classification method for identifying hidden psychological conditions in online posts, which offer from existing ones in the ability to identify several psychological conditions at once, and not just the dominant one, without losing accuracy compared to multi-class classifications. The main contribution of our paper can be summarized as follows. The multi-label classification method for identifying hidden psychological conditions in online post has been developed. The effectiveness of developed multi-label classification method for identifying hidden psychological condition has been experimentally proven, which allows unlikely exist one to distinguish specific features for each condition, which is implemented by training a set of neural network transformer on specifically formed datasets. The proposed stage of multi-label classification method for identifying hidden psychological conditions in online post is shown on this slide. The method transforms the input data, that's user-generated text and set of context-aware transformer model with tokenizer, into output information indicating the percentage likelihood of each of the 5 psychological conditions being presented in the analyzed content. At stage 1, the text is tokenized for analyzing by each tokenizer with empty tset for conversion into vector representation. At stage 2, the text tokenized by each tokenizer with empty tset is analyzed by the corresponding neural network model with empty set. The result of this stage is an assessment from 0 to 1 of strength of manifestation of each of the studied mental disorders. Stage 3 is responsible for forming conclusion about the presence of each of 5 studies type of hidden psychological conditions with their numerical measures of manifestations. To prevent confusion of psychological condition with each other and taking into account that in one text there may be manifestation of other disorders, records in the control category are formed accordingly to certain rules. The number of posts in the control category correspond to approach the target, ever no more than 10 posts. The control category consists of equal opportunity of the remaining text with other type of psychological condition and text that do not contain such a manifestation or contains them to a very small extent up to 0.3 and scale from 0 to 1. To form the training dataset, the depression radius dataset, cleaned and COM61 datasets were used. Dataset formation scheme are shown on this slide. Regarding the results obtained with multi-class classification, the following results were obtained by macrometric. Accuracy 0.854, precision 0.867, recall 0.854, and F1 score 0.854. As for the micrometric for each class, which characterizes the presence of hidden psychological conditions, their value given in table on this slide. The number of samples for analysis is 147. Experiment to train the transformer models set and tokenizer set for each of 5 types of hidden psychological conditions. The parameter of neural network model as follow: batch size 16, F5, learning rate 2e minus 5. Metric of binary models for transformer models set show in table on this slide. The confusion matrices of the binary classifiers are shown for the following class: narcissistic condition, panic condition, anxiety condition, depression, and anger intermediate explosive conditions. By using the binary approach, it was possible to increase identification of anger intermediate explosive condition by the precision metric by 25.4%. By recall metric by 0.4%, and by F1 score metric by 15.4%. The identification of depression by the precision metric decreased by 1.6%, but by the recall metric increased by 10.5%, and by F1 score metric increased by 4.1%. The class narcissistic condition precision increased by 2.6%, F1 score increased by 0.4%, however, recall decreased 1.8%. For the class panic disorder, it was possible to achieve an increase in the value of the matrix as follows: precision increased by 6%, recall by 19%, F and F1 score increased by 30%. For the class anxiety conditions, improvement was not achieved. The multi-label classification method for identifying hidden psychological condition in online post was proposed, which perform automatic classification of text user content for identifying hidden psychological condition by their features. The created method allows to obtain in the models and improve ability to distinguish specific features for each type of psychological conditions due to training on modified sets of text data, which reduce the probability of confusion between conditions since the model learn to distinguish their characteristic features. The development method provide an average value 92.3% of the F1 matrix for multi-label classification of hidden psychological conditions, while existing analogs provide average value only 64.5% of the F1 matrix for multi-class classification. The minimum F1 matrix value for the development method is 84.1% for the depression, hidden psychological conditions due to clinical overlap with anxiety. Further research will be aimed at expanding the training dataset and studying other type of psychological condition in addition to the 5 considered, and improving the matrix for the considered hidden psychological conditions. So thank you for your attention.
Thank you. So we have 4 minutes for questions.
I have a question.
Mhm.
Well, as far as I realized, it is about supervised learning. You declared you have a data set, a marked data set with known states of psychological conditions. But how one can be sure about such conditions in dataset if usually nobody declares their conditions when they post a message? Could you explain this in more details?
Yeah, thank you for your question. If I correctly understand, you mean that in some text cannot be any psychological conditions, yeah? And
No,
how we
no, simply about how do we know about exactly about labels in dataset if they
uh,
are not known in advance.
so you mean how we select targeted psychological conditions which we use in our research, yeah? We have 5
No,
class.
no, are we
No.
really sure about proper labels in the dataset if they are known?
So you mean how we plan to extend our data set? Yeah?
No, no, like.
So sorry, I little confused.
Your input data set for learning your model should be
Yeah.
marked with psychological condition.
Yeah, yeah, thank you.
But
Yeah,
how
yeah.
do they know this?
Yeah, I understand that. That's very important questions because we're working in health sphere and that's important. We use open source dataset from Kaggle that was marked for multi-class classification, but we transformed it for using it for multi-label classification. In the first step, all record in multi-class classification we have one value that it have one class. But in our result of our work, we get vector in result we get vector with measures of 5 psychological conditions with their percentage manifestation in text where we use next technology for getting that. First of all, we train 5 data sets for 5 models with created with our created data sets, and for each model get our some manifestation of each of targeted class, and in result we get the resulted vector with 5 percentage of manifestation of for each class.
Thanks.
Thank you for your question.
Thank you. So we can, after this presentation, move on to the next one. So thanking the speaker. And we are now heading for our next speaker. It is Maria Yukimchuk, Yuri Horchuk, Vyacheslav Kovtun, and Vladislav Lesko. And it's on algorithmic methods for constructing the space of parameter increments in automated control system of energy processes. Please share your screen. And
does anybody share the screen?
Please
maybe
close your screen.
So let me, you have to see my screen now.
Yes.
Stop. Do you see? Oh, nice. So, okay. Do you see me? Do you hear me?
Yes, all good. You can start.
Okay, nice. So let's start then. Today I'll presenting our research on algorithmic methods for constructing the space of parameter increments in automated energy control systems. So as energy became more complex and dynamic, it's critical to monitor and respond to changes in parameters in real time for better control and stability. Optimal control of such system requires an accurate analysis of parameter changes over time, which allows a timely response to load fluctuations, energy losses, and other factors that affect the efficiency of power facilities. The space of parameter increments is a novel analytical concept that lets us understand how changes in primary parameters influence system behavior. By visualizing and qualifying these changes, we gain the ability to predict outcomes and adjust operation proactively. We developed 2 algorithmic approaches to construct the space. The first is based on traditional numerical integration, while the second employs parallel integration of state and sensitivity equations. Each has its strengths depending on the system nature and operation conditions. The first method is straightforward. We precompute and store the values of the system state variables and then analyze them. This is especially effective for systems with stable dynamics and can be implemented with well-known tools like MATLAB or Scilab. So let's analyze the diagrams of this algorithm. First of all, I want to show you the diagram of finding the sensitivity matrix by direct numerical integration. According to the diagram, you can see where we start. And first of all, we have to initialize parameters. Then we have to input conditions and decide whether system is stable or not. If the system is stable, we use Runge-Kuther method, store state variables, and then calculate sensitivity metrics. After that, we save the result. Otherwise, we have to choose another numerical method and do these steps, and after that, calculate sensitivity matrix and save the result. And after that, that is the end of algorithm. The next, this is the diagram of finding the sensitivity matrix by parallel numerical integration of equations. According to this diagram, you can see where it starts. It's initialize the parameters, then we have to input conditions, and in parallel way we we integrate state equations, and after that we integrate in parallel way we also integrate sensitivity equations. After that, we are able to calculate sensitivity matrix and save the results. And that is the end of algorithm. So what the next? The next is a diagram of space of parameter increments while obtaining the sensitivity matrix by direct numerical integration. So what do we do here? First of all, we define the system parameter according to pre-calculated state, then initialize variables, then we see whether t less than t max. If yes, we compute parameter increments, then we calculate sensitivity and store results, and do it until the conditional gives us false value. And in the end, we visualize parameter increment space, and this is indicates that this is the end of algorithm. So here you can see another diagram of the space of parameter increments when obtaining the sensitivity matrix by parallel numerical integration. Here, it is the start of algorithm. Then we set initial conditions. Then we, in parallel way, we integrate state equations, and after that, integrate sensitivity equations. After that, we have to compute parameter increments. And after that, the next step after it goes form parameter space. And in the end, we visualize the result and finish the algorithm. So what's about conclusions? According to conclusion, so to conclude, the space of parameter increments provides a powerful framework for modeling and forecasting dynamic energy system. When combined with machine learning, it lays the foundation for intelligent adaptive control systems, making energy infrastructure smarter, safer, and more efficient. So, and thank you for your attention. Waiting for your questions.
Thank you. So, if there is time for questions, I think we have a lot of time for questions. I will start asking one question. It's about the prediction and the uncertainty quantification. So when you do a prediction, you would also like to know how confident you are in this prediction. Do you use any techniques to quantify?
Yeah, thank you for your question. So basically, we did research, and that is hypothetical algorithm that can enhance the existing processes for improving our energy system. But basically, what we can do, potentially, we can gather all the result we can get from our calculation based on our algorithm. Then we can define the coefficient for what how it can be define the accuracy of it, and then we can say whether we are confident in it or not. That's what I would say. That's the approach of defining the yeah.
The uncertainty quantification.
Yep.
Okay, thank you for this answer. Maybe more questions? To Yuri. So, are you using the system in practice already?
As I mentioned before, so that's only research. So basically, we did our article for research purposes.
Very good. Are you planning to implement this in a real system?
It's really interesting, and that's so actual for our country, and it has some potential. It seems to me we will develop this topic in our another stages of developing this article work.
So you started with the academic exercise and then go to
maybe. We cannot predict the future, but if everything goes okay, so we will.
Yeah, but this is a very normal process that we start to develop methods in a kind of academic testbed, and then we present them to companies who do the real stuff.
Yeah, there are a lot of new tools and a lot of practices in this field. So maybe it would be useful, and maybe it finds another way of development this topic.
Yeah. So we have maybe more questions from the audience. If I look at the timetable, there's now a small break. Is this right, Dimitro? We have planned a 15-minute break.
15, not 15, because we have no break. We have 3-minute break.
But who is the next speaker then? I see the next speaker is scheduled for 12:15.
No.
I wouldn't mind if we finish earlier.
Yeah, I see. Yeah, 12:15. Then we have 15 minutes. You are right. Sorry, 15 minutes we have.
Having a break. And I would like to thank, if there are any more questions, please now. And otherwise, we thank Yuri. Thank you.
Thank you.
And let's meet again in 12:15.
Yeah.
Greetings, colleagues. I'm happy to present our research on the topic improving the efficiency of damaged buildings detection based on ASPP technologies. The authors are Valery Dimo, Alexander Gozhey, and Irina Kalinina from Petro-Mogila Black Sea National University. As you know, the recent studies show the effectiveness of different neural networks, such as YOLO, ResNet, UNet, in different complex object recognition tasks and some others. But even modern technology and models require more detailed research in the different applications and in tasks like damaged building detection or surroundings due to different events like hostilities and others. And to improve effectiveness of models, we can use different training methods, metrics, and functions, as well as implement more complex models and data processing algorithms. What about, I'm sorry, 1 second. This was right. In our previous research, we built a UNet architecture that was developed by Olaf Ronenberg and others. We achieved some accuracy and intersection over union metric of 45.83% for damaged and 49.40 for undamaged buildings. As you can see, the main difference in this model is due to using unit-like shape. The first part of the model is a contracting path before the bottleneck, and the after bottleneck is contracting path, expanding path. We proposed the use of Atrus spatial pyramid pooling as a bottleneck. It should improve the model by applying different pooling layers with different distance rates, as you can see on the figure below. Atrus convolution, also known as dilated convolutions, and using it as a bottleneck will reduce the computational complexity of the model and improve the image segmentation using these Atrus convolutions. On this slide, you can see the proposed model. The general architecture remains the same, but we replaced the conventional bottleneck with the ISPP model. It consists of one layer of convolutions 1 by 1, followed by 3 convolutions layers 3 by 3 with different rate. Those are dilated convolutions, as well as one image pooling layer. After that follows concatenate layer, and in the end convolution Y by 1. Besides the changes in the model, we doubled our dataset. It consists now over 2,500 different instances, as well as various augmentations were applied, like you see on the image, such as shifting, rotation, image scaling, and others. As well as weighted indices was added to the dataset to increase the variability and used during model training. Categorical cross entropy was used in this task to calculate the distance between the actual class distribution and the corresponding prediction as the loss function, and the intersection over union was chosen as a metric for calculating the effectiveness or accuracy of the model. It takes into account the intersection between the original image and the ground truth. The model was trained on the NVIDIA GPU in the Google Colab service. It was trained on the smaller images due to some lack of memory. And after the applied augmentation, the dataset was divided for 70% for the model training, 15% for the evaluation dataset, and 15% as the test images. Some results you can see on this screen. On this screen, you can see the configuration of built models as well as comparative analysis on the second table. Totally were built 4 models. It's base model with SPP layer and 3 models with different parameters like weights, augmentation, and epochs. The base model without SPP was compared to others only on evaluation dataset. And as you can see, the base model with SPP has some better results, and the model 3 has the second best performance. Despite the base model without SPP has better results in intersection over union metrics for damaged and undamaged buildings, but the overall performance for the new models is better. So which means the higher accuracy and effectiveness of those models. But there's still difficulties left. The basic model with SPP has lower value of losses and increased accuracy and average value of intersection of union by 5%. But it's also noting that model 1 shows the best results among all models on the 23rd epoch. But despite the improvements, the model still requires some addressing some inequities like possibility confusing objects not related to buildings, as you can see on the image, as well as some inability to recognize heavily destroyed objects from the rubble, probably due to lack of classes differences. So the conclusions are that UNet model using SPP layer as a bottleneck was implemented, and dataset was expanded to 100 original images. Different augmentations were applied to increase the variability and as well as weighted maps to balance the existing pixel classes. Model with different parameters were built and compared, and it was possible to achieve some reduction in losses and increase in the intersection of the union metric as well as average accuracy. Difficulties in the segmentation of some images have been investigated, which require further research into the dataset, algorithms, and probably more complex structure of the architecture of the model using different neural networks and more complex techniques. The presentation is over. Thank you for your attention, and I will glad to answer your questions.
Thank you. Please.
So maybe I remember that last MoMLeT conference you have presented on this topic.
You're right.
I was wondering what is the difference now between the previous system and the new system?
Yes. As you can see, we implemented the SPP, spatial pyramid pooling, as well as some changes in the dataset was made, as well as in the previous research, we used a smaller dataset and simplified structure. It was divided only on testing and evaluating dataset, and now it's also separated tested images for testing that will secure more we will know that it will be a little better for the final results. Yes. As well as there were changes in the implemented of models because of different libraries were changed in this time. Those are the main changes.
Thank you for this detailed answer. I think it is good that you continue this research and make the system better and better. And I see this is quite an improvement in performance. Have you considered explainable AI techniques, or would they be beneficial in this context?
Do you mean what we can use in the further research, right?
Yes, there's this trend of using explainable AI to explain the outcome of classifications. And for instance, you can say what kind of factors or features contributed to the outcome of classification.
Yes, I think this is a good idea, and I will probably work towards it because this task is very complex. As you can see, there is different objects on the image, and it's hard to know from the start which is more important for the model, yes, and which model can confuse or something like that. So I will probably expand our model and use different submodels into it to classify results and so on.
Okay, so I think the benefit that you could get from explainable AI is also that you better understand how your models come to their conclusions, and then you can revise the models if they do some things that are against the common sense. And let's say they find a damage, but it's actually not a damage. These explainable AI models, they can point you to the origin of the reason of the classification, and then you can revise your models and make them even stronger by editing the features. So
yes, you're right.
Interesting here in this domain. Okay, thank you very much. Any more questions from the audience? If not, then I think we are exactly on the time for the next presenter, Miroslav Koma. Andrei Tabowski, please share your screen.
Good afternoon, dear colleagues. I hope you can hear me well as you can see my screen well.
Oh, perfect.
I'm honored to be here and to present the work we've been doing together with Miroslav Komar, Igor Markiv, Sergey Gutsel, and Dmitry Adyukh on increasing the efficiency of decision-making in a decentralized autonomous organization in the warehousing sector. Let me rapidly bring you into a context.
Can you
Yes, sir?
full screen for your presentation?
Sure, just a second.
On the down, yeah, full screen. You shared already the screen. There was only no full screen mode. So you can share again.
Yeah, sure. Is it better now?
Well, now go with the mouse down to the right, and there's this
slide point
angle
and full presentation.
Yeah.
Okay, I got it. One more time.
Maybe we can also just proceed. Do not take too much time for.
Maybe it's better like this, right?
Yes. Proceed, please.
Yeah, thanks. All right, let me rapidly bring you into a context. What are we trying to achieve? In our previous works, we've been integrating Web3 systems run into blockchain with existing Web2 systems, trying to utilize the best things that blockchains provide to us. And the example of that was making a decision-making system based on DAO, which is decentralized autonomous organization, to get some results. that was the scope of our previous investigation. What we are trying to do now is to basically improve it, because when we've been analyzing related works, we noticed that each time blockchain is integrated into existing Web2 solutions, some of data access processes are not performed well. And what is happening then is people do their work, then it works in pretty unique way, let's say, and they need some optimization. But what we found is that we don't need this optimization if the system is designed well in obviously design time, and data access has enough time to be provided to work on, to be leveraged well, to be designed well, because it brings some benefits that we'll describe later on. What is DAO? Basically, this is a system that is run into blockchain, which doesn't have any central authority, where all members of this system have an equal rights, which is, well, doubtful because it is managed by tokenomics. So it is possible to control this in a way that some members have more rights, some don't. And this is a dynamic process, which is evaluated based on decisions they've made previously and action they took previously. Have been taken previously. And the main principle here is that we don't have any central authority, and this is perfect for decision making, because when some decision is made, we can clearly track the whole process of how have it happened, of what data, what inputs did we have, and what are the outputs, how this decision was actually performed. In all existing Web2 systems, this core of decision making is hidden somewhere in some web service, let's say. So we believe that the decision that was made, it was actually applied, but we cannot technically prove it. Since data in blockchain is open, it is transparent, the whole process is visible now. This structure of DAO that we have, the main governed contract here is the one that basically represents the warehouse. Yeah, as I said, we're aiming to apply this solution into some warehousing sector where decisions are made by clients of the warehouse. For example, when the order should be executed, the order, the sequence of these orders, and so on. And all the other rectangles we have here, they are just helping. I don't think we have to bring much attention to them right now. It's just a structure of system to be working. What is in the core of this system is a proposition. Here is a path that every proposition should have taken before being executed. So we have a proposal, the one that makes some proposition, which will end up to be an action basically. And then all other members of system, they're voting for it. This process is complicated. It is configurable enough, so it varies from system to system. We've been building some POC solution that works the best way for our concrete example to work here in this warehousing sector. But here I'm trying to present a general concept, because this can be applied not only in warehousing sector, in whatever business area we have. So this voting process is pretty complicated, and then decision is made, and it is either executed or not. Based on its execution, some rewards may be granted, some penalties may be applied, and some changes may have taken place inside this DAO system, as well as execution itself should trigger some events, should do some actions, which will end up in real world events or actions, as I said. Here are some types of transaction that we have. They're basically the proposal submission, the very first step, then token voting, this proposal execution, and some other custom types that are pretty rare. They are mostly about governance of the system and defining rules, changing them, or whatever. Also, what is here in this table is average amount of gas. So this is a complexity, computational complexity of a transaction that needs to be executed. And yeah, they are sorted in percentage of their usage. So how much how they popular basically are. Per our calculations for the POC system that we've been building, we have like, we've been building a POC system. We run some tests over it to emulate that it's been working in real world. And per our calculations, we got that this system should take us like $9,000 to be just maintained, to work, in order to pay gas for all the transactions that are executed inside of it. And this is a problem. This is what we are trying to solve. This is what this work aims to be fixing. And the main concept here, the main methodology we're using is data indexing. What's the plan? We're going to build some services using some Web 2 technologies in order to store data in Web 2. So we are building a listener that is listening events from blockchain, which is a common functionality of every blockchain we have right now. And all the data that is coming of it is stored into Web 2 databases, which is maintained by, basically Web 2 services. What are the benefits here? The first thing, the data access is free now, since we don't need to perform a transaction to just read some data. Then this data is not concurrent anymore because we are maintaining it now. So we can perform vertical scaling, horizontal scaling here. We can do some sharding. We can store data wherever and however we want. The third benefit, which is exceptional, is that this data is structured now. Because in blockchain, purely, we can only store like bytes. They obviously some strings, some numbers. The most complex one we have is mapping or array. That's it. But since we are doing it in Web 2 now, we have a copy of data. We can structure it however we want. It can be some trees, some graphs, any type of tables, other things. So we can run queries more efficiently. We can index data however we want, and we can apply indexing algorithms we want that basically are better for this or that situation. And another advantage is that we have transaction pre-validation possibilities. So before executing some transaction, we can pre-validate it based on data that we have here in Web 2, since access to it is free, not as accessing data that is already in blockchain. Applying these principles, we have a comparison table here. Well, too much data on this slide, I understand, but it appeared, yes, so we use the POC solution that we've already built. We run some tests over it, and it appeared that some transactions can be better optimized because it depends on how many data do they actually read before being executed. Some of them are not, but on average, we got a result that applying this data indexing, we can save up to 25% of expenses per month, basically per any type of period. Yeah, that's our results. We are trying to optimize data access, to simplify those processes, and to use such methodologies and technique to achieve measurable results. This is another advantage we have here, because this 25%, it's not an imaginary number. It's something that is well deterministic. So if we get a new client with an existing, for example, DAO solution they have, they come to us, they ask, can you optimize this? Can you make it better? We say yes, as well as by doing some testing, we can exactly have say on how many gas, how much money can you save by applying that algorithms, that solution. Because, yeah, as I said, this data is well deterministic since everything is calculated in gas, computational power. Yeah, here are results. And yeah, as a conclusion, as I said, we optimized expenses by 25% roughly for the systems that we are using for ourselves, the one in warehousing sector. And this approach is flexible enough. It doesn't limit you with any technology usage with any other system except for DAO. So everything that is stored in blockchain can be optimized this way. And yeah, the aim for us is to make companies, to make our clients happier, to give them potential to be better in this computational world. That's it from me. Thank you for your attention. I would appreciate if you had any questions.
I have a question, if you please.
Sure.
What possibility to implement this to work in real time? Is it possible to make decisions in real time?
Well, it's the main challenge. Yeah, of course, decisions are made in real time. So basically, we have some Web2 service, I don't know, a web page, something that is connected to a person that wants to make a decision. He or she needs to somehow interact with some UI, for example. Let's imagine it's a web page, which then formats this proposition, this decision, this idea into some message, some transaction that is well known to a Web3 blockchain core that we have. And this process of data transformation is also what we are building. And yeah, as I said, it's not the main objective because it is dynamic. It can be applied wherever and however people want using any technology they want. Answering the question, yes, it's real-time computation. Since data lives in blockchain all the time, the uptime is 100%. It can be done, yeah, whenever we want. And this process is transparent. All the data is open. We can see how that solution was made.
But what computation resources you need? How?
Yeah, in order to connect to blockchain, we need some blockchain node, right? We can either have our own node, which is then a part of that blockchain that we are using, or we can just buy some resources. There are many providers out there. You just pay some month's rent and we are able to interact with blockchain now. Is that what you meant? I'm sorry.
For example, if you try to use it for set of drones, for example,
okay,
coordinate actions,
okay,
and the resources of such small devices, some FPGA.
Yeah. Yeah, maybe that's a bad idea then, because it's not, yeah, we have some latency, obviously. Since every transactions are executed sequentially, there is a delay between starting of transaction execution and finalizing of this execution. And it may take any time starting from 1 second to some minutes. Yeah, so it doesn't make any sense here, you're right.
Mm-hmm. Thank you.
Okay, thank you. I think we are now the time for the next speaker. Thank you very much, Andrei, for this interesting talk. I would like to introduce our next speaker. So we have Svetlana Bielkov, Anton Berg, building and implementation of security freelance platform based on Ethereum. Maxi,
Yes.
can you?
Well,
yeah, it's perfect. Yeah.
so good afternoon. Thank you for being here today. And we will present our work on modeling and implementation of a secure freelance platform based on Ethereum smart contracts. And I'm Maxim Belikov, and this research was conducted with Svetlana Popereshnak and Anton Bur. In this presentation, we will explore how modern architectural principles like microservices, domain-driven design, and blockchain integration can be applied to improve freelance platform scalability, security, and reliability. So, freelance work comprises nearly half of the global workforce, with 1.57 billion participants as of 2025, driven by flexibility and cost efficiency. Yet, current platforms struggle with high fees, fraud, and delayed payments. So, blockchain offers transparency and automation through smart contracts, but it cannot ensure a scalable system. We explored a microservices-based architecture of a crypto-enabled freelance platform, emphasized modularity, domain-driven design, and service isolation. So, currently there are two main problems in most freelance platforms. They impose high intermediary fees that reduce earnings for freelancers and increase costs for employers. And the freelance platforms suffer from limited transparency and frequent payment delays, which of course undermine user trust. So our goal was to improve the architecture of modern freelance platforms by applying principles of software modularity and service isolation. Of course, this includes enhancing blockchain payment, secure authentication, distributed data management, and scalable service orchestration. We have already implemented a beta version of such system, and the implementation was done in 3 steps. The first, we implemented the Next.js front-end app. Then we developed an API gateway for all our microservices, and the backend is composed of modular independent microservices that communicate via gRPC for efficient internal data exchange. So currently we have the next business process. I'll try to scale it. The customer can place order and it is recorded in blockchain. Then he can, of course, cancel order or wait for freelancer. And after that, some freelancers take order and our customer can either accept it or decline. Of course, if it's accepted, there will be a record in blockchain with freelance wallet, freelance customer, and freelancer wallet addresses. And then if a deadline for the task is passed, freelancer reputation will be spoiled. And such thing will be if he cancels his order. And also, if freelancer done work correctly, our customer can cancel the contract and the money will be received by freelancer. And if some situation occurs unexpectedly, like freelancer get not what he achieved, he can call administrator, which will solve that problem. We implemented a weighted risk model based on user rating, contract history, execution time of a transaction, wallet balances, and account age. And as you can see on the graph, our weighting coefficients are better than the standard traditional model, which only considers user rating. So by incorporating more risk indicators, our approach better detects fraud risks, especially from users with low balances or new accounts with like can be a fraud or scammers. We thought about security of our platform, and all internal and external communications are encrypted using HTTPS to prevent man-in-the-middle attacks. Also, we use authentications with GVT tokens. Each of them are stored in cookies, and they have expiration time and can be revoked via API. So we reduce the risk of session hijacking and unauthorized usage. And of course, Ethereum contracts are immutable once deployed, ensuring that our transaction logic will be always correct and the same, and it will protect against unauthorized code modification. So smart contracts function as escrow services, and they automatically release funds only upon verified task completion. And of course, this minimizes fraud. In conclusion, Our implemented architecture shows how a microservices approach tackles key challenges in freelance platforms. Modular design enables scalability, maintainability, and fault tolerance, and our model based on factors of freelance transactions can reduce fraud. Also, blockchain ensures that secure transactions also transparent, and smart contracts enforce agreement which protects participants, and also do automated payments upon task completion. So these choices makes our platform robust, flexible, and well suited for the evolving freelance economy and emerging technologies. That's all. Thank you for your attention. You can ask some questions.
Thank you, Maxim. So are there questions from the audience? Please unmute yourself.
It's very interesting. Yes, for me. Is it implemented already?
Yes, we implemented a beta version of it, and it is working, but we don't publish it.
Not
like for real people. Yes, we only tested it locally.
What problem to publish in GitHub somewhere to test by other people?
Well, in GitHub we have already published, but we are currently want to test it better to ensure that when we deliver our products to a real customers, that there will not be any problems.
It will be open source?
Yes, it will be open source.
Then people can check your software as it will be open for people now.
Well, currently the GitHub repo is private, but we can make it public.
Okay, it's good system. It should be popular. It looks like very interesting.
Thank you again also for this talk. And maybe there are more questions. If not, I would like to announce that I have to leave for a little while because I need to attend some family matter. But Metro will continue.
Yeah.
So everybody, I might come back in an hour if it's possible.
Thank you, Mikhail, for your chairing our seminar. And we should continue with next report. If you please, Svetlana Poperechniak, already done. Victoria Zhepka, Svetlana Shlyanchak, Dmitro Nishemenko. I don't know. Who will report?
Yes, thank you. Thank you. Dear colleagues, I'm glad to present our study titled Real-Time Adaptive Cleaning of Internet of Things Sensor Data Using Machine Learning, Noise Classification, and Rule-Based Refinement. So, as we start, the Internet of Things is generating massive streams of sensor data, particularly from smart home and industrial environments. This data, often uninvariant time series like temperature, has great potential, but is frequently plagued by quality issues. This problem can severely degrade the performance of downstream applications. Many IoT applications demand real-time processing, meaning traditional batch cleaning methods are often insufficient. It's not enough to simply detect errors. Applications like forecasting or control system require a complete and corrected time series. Thus, real-time data correction is a critical necessity. Looking at related work, the general idea is that different error types should be handled with specific repair strategies. While machine learning models are suitable for classification, their explicit use for identifying multiple distant noise types as a step before adaptive correction is not widely documented. Adaptive correction aims to dynamically choose cleaning actions based on the diagnosed noise type. However, while various systems exist, there appears to be a gap concerning methods that explicitly classify multiple distant noise types using machine learning and then use this classification to dynamically select tailored correction strategies in real time. Our proposed solution, URTSA, is based on a classification-driven adaptive cleaning approach. This is further refined by rule-based logic to effectively manage low noise states. The system processes data sequentially. As illustrated in a figure on this slide, the URTSA architecture has several key components that operate iteratively. First is sliding window buffer. This maintains the most recent data points, provides the necessary historical context. Next is feature extraction model. For each new data point that completes the buffer, a new set of statistical features is calculated from the current Windows data. These features aim to capture characteristics that indicate different noise types. Next is noise classifier. We use a random forest machine learning model, which is trained offline. Its job is to predict a dominant noise type within a current window based on the extracted features. Rule-based refinement model is applied after classification, distinguishing true low noise states from low amplitude general noise can be challenging for the classifier. If the classifier predicts general noise, but the calculated variance of the current window is below a set threshold, the prediction is changed to clean. And next, adaptive strategy selection and cleaning operators. Based on the resulting effective label, a specific cleaning strategy is chosen and applied to the current data point. So if data marked as outlier, it's replaced by the Windows median value. Otherwise, if constant value drift or general noise, the point is typically replaced by the mean or median of the few recent points in the buffer. To evaluate the URTSA performance, we conducted experiments using a real-world data set where we introduced synthetic noise. This was done under simulated real-time conditions. For this study, we focused on indoor temperature. A continuous one-week segment was selected to serve as a clean ground truth data for our experiments. To create a test set with known errors, we added a controlled mixture of synthetic noise onto this clean ground truth data. We used a fixed random seed for reproducibility. This included point outliers, constant value segments, drift segments, general noise, and missing values. The ground truth and corresponding noisy data sets were split to the first 70% is for training and the last 30% for testing. We compared the performance of our method against the raw noisy test data, raw median as a common non-adaptive filtering technique, and the Kalman filter as a standard model-based filtering technique. All methods work under the same real-time simulation conditions. The performance of all cleaning methods was evaluated using root mean squared error and mean absolute error. To understand the internal classification mechanism, we assessed methods labeling using overall accuracy, precision, recall, F1 score, and the confusion matrix. Now let's move to the experimental results. So our main evaluation focused on the accuracy of data cleaning. As shown in table and visualized in figure, our proposed URTCA method achieved the lowest root mean squared error and mean absolute error. The implemented Kalman filter, although better than noisy, had more difficulty with the mixed noise types present in our data. Our method showed a notable reduction of approximately 14% in root mean square error and 23% in mean absolute error compared to the rolling median. The improvement over Kalman filter was about 34% and 67%. The figure provides a visual comparison showing how the different methods handled a segment for the of the noisy test data compared to the ground truth. Visual inspection suggests that the URTCA more effectively smooths general noise, corrects outliers, and adapts to shifts or constant segments more accurately than the other methods. Understanding the performance of the internal noise classification mechanism within URTCA also provides valuable insights. The classification results indicate that effective identification of drift and constant value segments and the URTCA demonstrates high recall for outlier detection, meaning it successfully flags most true outliers. However, the precision for outlier and clean labels is low. This indicates that many segments identified with these labels were actually instances of other noise types. And general noise itself has a relatively low recall and was often misclassified. Despite these imperfections in the underlying classification, particularly the difficulty in distinguishing low-level general noise from truly clean segments or certain outliers, the overall URTCA architecture achieved superior cleaning performance. Regarding computational costs, our method required approximately 32.6 milliseconds per data point. This processing time is still feasible for many real-time smart home applications. And to conclude, this work addressed to significant challenge of cleaning single variable time series data from Internet of Things sensors in real time, especially when faced with a mixture of different noise and anomaly types. Our experimental results based on simulations using real-world temperature data corrupted with synthetic mixed noise demonstrate the effectiveness of this approach. The primary contribution of this work is demonstrated that an adaptive strategy guided by machine learning based classification of noise types and augmented rule-based can lead to more accurate. However, this study has certain limitations. We see this on previous slides. So let's talk more about future work. Future work should focus on enhancing the noise classification model, extending the framework to multivariate data cleaning, and investigating methods to automatic parameter optimization. Thank you for your attention. I will be pleased to answer your questions.
Thank you. Maybe somebody have a question from listeners. Any questions to reporter? Nobody. I have question. What do you pay for your improvement, your method? What do you think? How you achieve better results and what you should pay for these better results?
Thank you for your question. I think for future work, I talked about we should pay more attention to improve classification, and I think we can use more data for training model or test some other models for classification noise types. And I think this can cost more computational cost for these improvements, but this should be tested and illustrated for the next work. Thank you.
Please show slide before last, previous slide with some numbers. Here. It's your method, URTCA, yeah?
Yeah.
2 milliseconds.
Yes, 32 milliseconds.
It's
and we used a data set where data was collected in 1 minute intervals.
No, okay, but you have latency 32 seconds, yes? It's worse out from 3 shown approaches, rolling median, Kalman filter. And maybe you can repeat improvement of accuracy of your method in comparison to REST.
Graphic or
in table RMC. I see maybe URTCA, but you have too much numbers after point. 0.
Yeah, that should be shorter.
Yes, because REST numbers are noise. URTCA 0.8 and Kalman 1.3.
Yeah, there may be some trouble with implementation of Kalman filter, or we should say that synthetic noise was so strongly for this test. This I can say about results because yes, Kalman filter result is so unnatural, if I can say.
Okay, it's interesting. And is it implemented only software or is for some controller like?
We planned this will used on server. So sensors send data to server and then it's cleaned and then goes to forecasting or control system and other. But we can think and make implementation for cleaning in on smart devices.
You should try to
be tested.
EM32 or ESP32 device to implement as edge computing, because it's very important for such smart sensors to pre-process closer to object of sensing.
Yes, I absolutely agree.
Thank you very much. Maybe somebody else has questions. Okay, thank you. And we are
Thank you.
Faster than needed. Timchenko, Havresh, Hamula, Chornyak. Who will be next?
Hello. Yes, my name is Vladimir Chernyak, and I will be the speaker. Let me share my screen, please. Do you see my screen?
Yes.
My presentation? Okay. Welcome to the presentation Hypergraph Structure for Parallel Integration of Databases into CRM. this research focuses on how hypergraph-based modeling can enhance CRM system by enabling parallel data integration and improving scalability. Today, we will explore theoretical foundation, architectural strategies, and practical implementation of this approach. The agenda outlined the flow of our discussion. We begin with the motivation for hypergraph modeling in CRM, continue with the design and implementation of parallel architectures, and conclude with transaction management and future prospects. In modern CRM system, data originates from various heterogeneous sources, such as transaction, marketing campaigns, and support tickets. Traditional graph models are limited to binary relationship, which complicates the representation of complex multidimensional dependencies. Hypergraph, in contrast, allows modeling of relationships between any number of entities, naturally capturing CRM data clusters. The main objective is to achieve scalable, expressive, and efficient integration. This slide visualizes the fundamental difference between a classical graph and a hypergraph. On the left, we see a traditional graph structure where each edge connects only two vertices. On the right is a hypergraph model where a single hyperedge can grow several entities simultaneously. This structure is much better suited to capture complex CRM relationships. In hypergraph-based CRM model, each hyperedge reflects a specific unit of business logic, such as set of customer interactions. This hyperedge may include support tickets, marketing campaigns, or purchase records. Semantic weight can be used to define the significance of each connection. This structure aligns more closely with the nature of CRM data. The diagram on the slide showed the core entities in CRM system: clients, support tickets, transactions, and marketing campaigns. These are linked through action-based relationship. For instance, a client making a purchase or submitting a support request. In a hypergraph model, all these objects can be grouped into a single hyperedge representing a cohesive data unit. In our model, a customer and all their interactions are considered a single hyperedge. This clustered representation can be tailored to different application scenarios. It enables a client segmentation based on behavioral data. Such an approach naturally fits the modularity of CRM systems. The slide illustrates how we can envision a customer purchase and support request as a polyhedron in hyperspace. Each vertex corresponds to a separate event or entities, and the faces of the hyperedge bind them onto the logical unit. This visualizes the customer's entire interaction history as a unified structure. Each hyperedge has a unique identifier and associated metadata stored in the database. We used PostgreSQL-based schema to achieve both flexibility and high performance. The model remains compatible with standard SQL system. It also allows the real-time updates during execution. The entity relationship diagram on this slide represents a structure with a hyperedge and vertex tables, where on the hyperedge can include many vertices. The tables store not only IDs and categories of hyperedge, but also list of related entities. This allows formalizing the hypergraph structure within a traditional relational format. Parallel processing in CRM system enables distributing hyperedges across the independent threads. Each thread writes data in isolation, ensuring consistent outcomes. This eliminates conflicts during simultaneous database access and reduces total integration time. Such architecture allows us to implement a scalable and efficient processing model. This image illustrates how hyperedges are distributed across threads in a multi-thread environment. The intersection topology visualizes potential conflict zones between threads. This approach allows us not only effective load balancing, but also strategic planning for isolation and synchronization. Conflicts arise when a hyperedge share vertices and are processed simultaneously by different threads. To minimize them, we use heuristic algorithms such as gridley partitioning and simulated annealing. These techniques reduce intersection points and improve synchronization. As a result, the system can scale without losing performance. The graph shows the speedup achieving through parallel hypergraph processing. It illustrates how increasing thread count affects integration time. This confirms the efficiency of using hypergraph models in multi-thread environment. This slide represents a code snippet implementing multi-thread hyper-edge processing. It shows the use of thread and synchronization mechanism for safe database writes. The architecture ensures secure updates in PostgreSQL. The system is implemented using PostgreSQL for storage and Python for logic. This design matches the structure of hypergraph and supports parallel data writing. It remains flexible for future extensions. HyperEdge are a format from files, log, and external sources. They are processed in parallel and written to the database. A central node synchronizes data with the CRM core. After integration, data becomes available for analysis and visualization. The diagram shows the ATL architecture using hypergraphs in CRM. Data sources fit into the extraction model where HyperEdge are formed, then data flows through transformation and it's integrated into the core system in parallel. The hypergraph model simplifies the representation in CRM. Parallel processing increases performance but requires attention to data conflicts. Effective load partitioning methods are essential. Future plans include using machine learning for automation strategy selection. And that's all. Thank you for your attention.
Thank you. Please, questions. Maybe somebody have questions to reporter. Okay, I have a question about HyperEdge. What is it, HyperEdge again? Maybe you turn back to slide.
Yes, sure. Let's return to slide. Can we find the appropriate slide?
Yeah, well, this one maybe. No. With
Oh yeah, so I find the slide. So HyperEdge, it's like customers. In our example, it's customers and all the interactions. So HyperEdge can include a few tables, for example.
Definition. Next slide, please. Next and.
Okay, let's find the slide.
No, with ER diagram. This one. Sorry, back. Is this HyperEdge? Yeah, it's ID, category, weight, list of vertices.
Yeah.
And then edge connects to many vertices. Yes.
Yes.
And the vertex it's only string label and number.
Yes, but it can be some data that represent some interaction or any other data.
Okay, it's your idea of organizing such way hypergraph, because maybe exist another one, another kind of hypergraph when we have simple edges but hyper vertices, complex vertices like a graph inside vertice and one line edges between such hypervertices. What is idea taken from with this hypergraph as a set of hyper edges?
So this idea,
prototype of your presentation, presenting.
The prototype actually was just a simple graph, as we didn't pay enough attention for hyper vertices, as you mentioned. So we pay our attention only on hyper edge, and this idea, it's the ideas of all the paper authors.
Okay, it's interesting idea. And for ETL process, it's important, of course, as you presented. It's interesting.
Yeah, thank you.
Maybe other questions somebody has to presenter. No questions. Thank you for your presentation.
Thank you.
And we have 8 minutes for next presenter. Maybe somebody have more longer. Oh, I see Vyacheslav Koton already ready. It's.
I hope so, dear colleagues. Do you see my presentation?
One moment, please. It's your turn.
I hope so.
15.
If according to the...
Yeah, okay.
So, let me start. Let me start my presentation.
We see.
Okay, dear colleagues, I am glad to present to your attention the results of the research analytical evaluation of the performance of high-loaded 5G EOT ecosystem functioning. Let's move to motivation. The motivation for this study arises from the increasing prominence of 5G EOT ecosystems in the mission critical domains such as industry, energy, transport, and public safety, where the reliable aggregation of data from multiple sensor networks under high load conditions is essential. Exciting analytical models often fall short in capturing the full complexity of such systems, either by oversampling the network topology or by neglecting key technological features of 5G, including such machine learning adapted mechanism like energy scheduling, discontinuous reception, hybrid automatic repeat request, and pocket fragmentation. Recent advantages in the modeling of 5G EOT ecosystems reflect a growing interest in analytical approaches capable of characterizing complex network behavior. Classical Quakian models have served as foundational tools for the preliminary analysis. However, those models exhibit significant limitations in high dynamics 5G environments, particularly due to their inability to capture adaptive traffic scheduling and advancing 5G features. Stochastic geometry has been implemented to model spatial user distribution and signal observation, especially in micromillimeter and terahertz frequency. Despite those advancements, a gap remains in developing integrated mathematical models that simultaneously address radio layer dynamics, pocket fragmentation, resource contentions, and service layer processing. This gap underlies the need for the unified analytical framework which our research aimed to address. Here we can see some main points of the research. The object of this study is the high-load 5G IoT ecosystem characterized by the interaction of multiple sensor networks, which 5G base station under dynamic and resource-constrained condition. The subject of the is the development and application of analytical models for performance evaluation, including mechanisms such as NR scheduling, pocket fragmentation, HARQ, DRX, and other machine learning algorithms. The aim is to construct a robust mathematical framework capable of accurately predicting key performance indicators, including response time, blocking probability, and system idlance, which realistic operational scenarios. So let me present some basis of mathematical apparatus, which is presented in the conference paper. The study considers 5G IoT ecosystem comprising multiple sensor networks that interact with GNB base station through adaptive radio resource allocation. Two operational models are defined: time division mode, where traffic is actively transmitted, and traffic control mode, enabling resource optimization and energy efficiency via DRX. Each sensor network consists of devices that generate requests and receive responses from either local edge servers or external cloud services. Communication is coordinated using NR scheduling random access channel and buffer status reports, while data integrity is maintained through HARQ mechanisms. This model is represented analytically via such a main performance matrix that we see the average resource time for device in network, average processing time in the local or external server, average waiting time for GNB resource assignment, probability of request blocking at the GNB, and probability of no pending requests in the local buffer. At the slide 7, we can see the structure of the 5G IoT ecosystem for aggregating information flows from sensor networks. Here we can see the expression for average waiting time for GNB resources for a sensor network and the expression to calculate the success probability. Next, we can see average slot duration formula and the expression to calculate the probability of arriving at an empty BC queue. Now let's move to the expression for pocket fragmentation, the error and average time which are presented on this slide. I mean, formula Z is an error and T is the average time. And now the minimum transmission time which is presented in the bottom of the slide. So results. First of all, to assess the adequacy of the proposed analytical models, in describing high-load 5G IoT ecosystem, a structured three-stage verification was conducted. At the first stage, the model was benchmarked against the classical QuakeView approaches, specifically MM1 and MMC QuakeView systems, which are widely used in traffic analysis in the communication systems. While those models provide baseline performance estimates, they fall to account for adaptive scheduling fragmentation, the risks, effects, and retransmission inherent to 5G architecture. The second stage involved selecting a representative empirical data set, which is named alleged scale data set for 4G NB-IoT and 5G standalone network measurements, which captures end-to-end latency and radio parameters across varied urban scenarios. The third stage focused on evaluating the model's predictive capability using the RTT metric under real-world traffic conditions. So now let's move to the results of the research of the experiments. So the first stage is represented by the figure 2. We can see a comparative analysis of average round trip time, RTT, estimates derived from the proposed analytical model, the classical MN1 and classical MC QuakeView models, and empirical measurements excited from the SimulaMet dataset, which captures delay dynamics in the operational 5G and NB-IoT environments. The results demonstrate that under light traffic conditions, when lambda is lower than 2, all three models yield similar outputs, reasonably matching the observed data. However, as the system transits to moderate load levels, where lambda is between 2 and 6, the classical models increasingly deviate from empirical behavior, and when the lambda is up than 6, the model exhibits a slight undermatching of RTT values, but continues of outperform both MM1 and MMC classical model, while maximum error margins hot exciting 20%. So the second stage of our experiments was allows us to get such figures that are present on this slide. So a three-dimensional surface plot demonstrating how the average response time in the high-loaded 5G IoT system is affected by two interacted protocol-level factors: the degree of pocket fragmentation and the length of the risks, including delay. The horizontal axis representing the number of fragments per data pocket, while the second axis corresponds to the risks switching latency. The vertical axis shows the resulting average response time, analytically estimated based on pocket fragmentation. The figure relevance the nonlinear surfaces, where increasing the fragmentation degree initially leads to reduction in response time due to the improved transmission efficiency and better adaptation to channel variability. However, this improvement diminishes as fragmentation grow excessive, indicating the optimal operational range. In contrast, the DRX delay introduces a constantly negative impact, which response time increasing surely at TD parameter growth, especially when the system operates with lower or moderate fragmentation levels. Now let's move to the figure 4 and third stage of our experiments. This figure illustrates how the response time of 5G IoT ecosystem evolves under the combined influence of two parameters assessed, which adaptive frequency hopping. This is dwell time on a give frequency and the temporal duration of transmitted pockets. The horizontal axis corresponds to the dwell time T dwell, while the second axis reflects pocket duration Tm. The vertical axis captured the average system response time derived analytically using the extended model that incorporate RFH, active frequency hopping, specific delay coefficients. The resulting surface shows that moderate increasing in dwell time initially reduce the latency as they minimize the frequency switching overhead and stabilize channel quality. So, the conclusion. The analytical evaluation confirms that the proposed model provides an accurate and structurally adequate representation of high-load 5G ecosystems. As shown at figure 2, the model reliability approximate empirical RTTT values recorded in the real network outperforming such classical models as MN1 and MNC, particularly under medium and higher traffic traffic loads. Figure 3 demonstrates the model's sensitivity to protocol level parameters such as the RX delay and pocket fragmentation. And figure 4 further highlights the impact of adaptive frequency hopping, showing that dwell time and pocket duration interact and non-trivial ways influence delay. So this is the main results that we get in this study and present to you. Thank you for your attention, dear colleagues, and questions, please.
Maybe somebody have questions to report to Professor Kovtun. No, it's quite complicated stuff, complex stuff. And maybe if nobody want to ask, I will ask some terms. What is RTT? You use the RTT.
Round trip time. It's the time when the request is sending to the from the one device to the base station, and after that, base station send the information that the request is received back to the device from the original device. So this is time when from device to base station and ask request and response from base station to the device is a round trip time.
Okay, maybe should we turn back to 11. Let's say 18 sooner. 17, 16, 15, 11. No.
11? I'm sorry.
10, 11. Next. Results. Yeah, second stage involves selecting a representative empirical data set. What is taken from this empirical data set? Large scale data set of 4G.
As you can see, we take all the necessary parameters from these datasets, and this dataset was chosen because in these datasets we had all the necessary data for our research. I mean, NB-IoT data, 5G data, 4G data is not necessary for our research, so we don't use them.
Open source.
And regarding
that, where we can take it.
This is a free available dataset. I don't remember exactly, but I think that it is available on Kaggle.
Kaggle. Okay. 15 then. Next, some tables. No tables, but graphs.
This or another?
This one, previous also, but this one I try to understand. This one, RTT and lambda. Lambda here up to 10. RTT, okay, it's round trip time, yes, but
yes,
scale from 0 to 1. What is this scale? I don't understand.
Here we can see lambda. Lambda, as you can see here, this is the description of the results which was presented on the graphic, and we can see that lambda is it's the intensivity of traffic condition. When the intensivity is growing,
but RTT, you see Y RTT from 0 to 1. Around time, what is the scale of this?
You understand. I understand your question. It is a normalized value. It is normalized value. It is my mistake. I should put not only the name of the parameter on the graph, but also the in how way this parameter, this value is represented. This is in the case of RTT, it is normalized value. So this is why it is in the dimension of 0 to 1. And we can see that which intensivity of requests in the system is growing. The RTT time is also growing. But as we can see, to represent this time in the proper way, it is we can see the data set which is represented by the so as we can see, only our proposed model is describe the real data in the proper way, almost in the confidential interval. But the classical models are absolutely we can't use them when the value of lambda is becomes high load. I mean up then lambda equal to 2.
Okay, thank you.
Thank you very much.
Quite complex here. If nobody have another questions, we will thank you for your report.
Thank you very much, dear colleagues.
Then we go to next report. It will be 16 one. Sergey Vladov, Anna Bakurova, and who will present this report?
I will report.
Please.
1 second. Good afternoon, colleagues. My name is Ivan Omelyanenko, and I would like to present the result of a collaborative research project, Ontology Control System in Neo4j. The result is made by a team consisting of the following members: Anna Bakurova, Ivan Omelyanenko, Ruslan Sirenko, Elina Tereshenko, and Sergey Vladov. The main goal of the work is creating a control system for managing subject ontology based on graph databases. The aim of this system is to provide the ability to manage ontological models without the need for in-depth knowledge of query languages for graph databases. This report presents the result of a study on the integration of ontology dedicated to sunflower cultivation in Ukraine and located on pan-European resource using the Neo4j graph database. This research is a component of the task of integrating the subject ontology of sunflower cultivation in Ukraine into pan-European community, a task outlined by the authors in previous works. The combined ontology stores data from different countries, allowing breeds and agronomists from different regions to work with a single knowledge base. This can contribute to faster data exchange between countries, as well as accelerating scientific research and the implementation of innovative approaches in breeding. This contributes to improving international cooperation in the field of agronomy and biotechnology, and also makes it possible to use the experience of other countries to improve breeding programs. Plant breeding is a global process, and combining ontology allow you to study global trends and breeding. For example, the development of new varieties resistant to climate change or pests. We work with three key sources. The first, the Helianthus ontology; the second, the Helianthus phenotype ontology, focused on morphological features like seeds and heads; the third, the sunflower ontology from European Crop Ontology Repository. Each ontology contains valuable knowledge, but different in structure and terminology. The Helianthus ontology and the Helianthus phenotype ontology are developed with Ukrainian agrotechnology experts. The work are carried out in cooperation with experts from the Institute of Oilseed Crops of the National Academy of Agriculture Science of Ukraine. The basis for merging ontology is the rules presented on the next slide. Merging ontology poses several challenges. Identical concept might have different names. Level of detail may vary. RDF structure is not always consistent. To address this, we applied semantic matching method that identify similarity between concepts based on meaning, not just syntax. We choose semantic method of ontology matching and automated merging of ontology using algorithms that automatically process matched concept and generate a single unified ontology. The semantic method for matching was chosen due to the content component of the task integrating ontology dedicated to sunflower growing agrotechnology. It is the use of terminology in the field of sunflower growing agro-technology to introduce ontology classes that makes it possible to use semantic method. We used the built-in Neo4j function Soren's dice, which calculates Soren's dice coefficient to measure name similarity. Even if two nodes have different labels or formats, as long as their similarity score is high enough, we treat them as the same and merge them. This approach works well with ontology from different RDF schemes like SCOS or OBO. Our merging process involves 4 steps. We identify all candidate class nodes, then compare all node pairs using Soren dice. Pairs with a similarity score above 0.85 are merged. At the end, we return the number of merged pairs and the total number of resulting classes. This flexibility method adapts to many ontology formats and naming conventions. We conducted 2 experiments. The key mechanism for interacting with ontology is built in on HTTP request processing. The user sends the request to the server, which checks the correct of the entered data, stores files in the system, and interacts with Neo4j via cipher request. The main important call use built-in mechanism for working with RDF graphs. To ensure correct merging of ontology, an algorithm for comparing graph vertices has been developed. If vertices have the same unique properties, they are linked by the same S relation, which avoids duplication. Additionally, the ability to connect to external APIs is provided, which open up a prospect for integration with other platform and servers. In the first step, an empty graph is created that contains one vertex. We conducted 2 experiments. First, we merged Helianthus ontology and phenotype. This resulted in 588 pairs merging and 68 remaining classes. The second, we added the sunflower ontology from EU crop ontology repository. The final Helianthus ontology contains 1,183 unique classes and demonstrates the system effectiveness in large-scale semantic integration. The numerical characteristic and qualitative analysis demonstrate the correct operation of the matching and merging algorithm, which ensure high-quality integration in the target ontology Helianthus EU ontology. The main goal of the system is provide an interactive, researcher-friendly interface for managing ontology models without the need for in-depth knowledge of graph database query languages. The ontology control system in Neo4j allow you to load, store, import, and merge ontologies in the Neo4j graph database. The system is implemented as a web-based application. The front-end is written in React. The backend uses Python Fast API. The data is stored in Neo4j. Thanks Docker, the system is portable and easy to deploy. It supports a range of formats, including RDF, OVAL, and JSON-LD, making it suitable for many data sources. Main functionalities. Uploading ontology. The control system allows user to add files via the web interface. Files are checked for format and stored in a special repository. importing in Neo4j. After uploading, the user has the opportunity to improve the ontology into the graph database. The file format is automatically determined and the data is added in the form of graph structure. Merging ontology based on semantic method of mapping and automated merging of ontologies. Interactive web interface. The user can view the list of uploaded ontologies, buttons for importing and merging data are available. All actions are displayed in the event log, which simplify process monitoring. Working with API, the ability to connect to remote APIs to obtain ontology data has been implemented. The control system for manually entering queries for interaction with the graph database is provided. The work present the ontology control system in Neo4j that allow you to load, store, import, and merge ontologies in the graph database Neo4j. Thanks to containerization, the process of deploying the system on different servers is simplified with support for multiple formats, which ensure universal use. Additionally, the possibility of connecting to external API is provided, which open up prospects for integration with other platforms and services. The practical result of the present study is the build the integrated ontology Helianthus EU ontology. The integrated ontology Helianthus EU ontology is created with three source Helianthus ontology, Helianthus phenotype, seed and head, and sunflower ontology. In the crop ontology, Helianthus ontology and Helianthus phenotype, seed and head are subject ontologies of agriculture technology for growing sunflower in Ukraine. Further development of the ontology control system based on the Neo4j graph database is aimed at developing effective algorithms for matching, merging, and integrating subject ontologies. Thank you for your attention. I'll be happy to answer any question.
Thank you very much. Maybe somebody have questions beside me.
I have a question about the ontology integration. How do you manage the Helianthus ontology to be integrated with other botanical or agricultural databases and ontologies? Do you use some standards that people can reuse the data or ontology?
At this time, we take this ontology from crop and merging with our ontology, and that's all. So we comparing our results and results from crop and Helianthus ontology from crop and repository and merging them. That's all.
Okay, thank you. Interesting talk.
Yeah, interesting. Maybe other questions beside this workshop. If nobody has another questions, we will going to next report. Thank you.
Thank you.
Now Высоцька, Яковлeva, Ivaniu, who will
Yes,
report.
yes.
Please share screen. Sofia Ivaniu, okay.
Good morning. The topic of our article is intellectual analysis of Ukrainian refugees number dynamic depending on attack frequency from Russia Federation. Our goal comprehensive study of the relationship between the number of Ukrainian refugees and Russian attack on civilian infrastructure and political targets. In Ukraine, using visualization method, time series analysis, correlation analysis, and clustering using the arrow programming languages. Through the dataset, we selected for analysis the number of Ukrainian refugees, abroad shelling of Ukrainian civilian infrastructure, and shelling of Ukrainian political infrastructure. Since 2022, there has been a significant increase in number of attacks on political and even more so civilian infrastructure. The decrease in political attacks since mid-2020 increased that Russia is building up resources. The third graph shows the increase in number of refugees since the beginning of the full-scale invasion. 54, an average of political attacks per month since the beginning of Russia-Ukrainian war, of which 38 were fatal. 5 civilian attacks per month, an average since of the beginning of the Russia-Ukrainian war, 4 of which were fatal.
This slide shows how direct smoothing is applied using different window sizes using the candle method. This slide shows how sequential smoothing with increasing window size is applied using the candle method. All candle correlation graphs show a weak linear relationship, correlation coefficient less than 0.5, a coefficient of determination less than 25%, with only the correlation between shelling of political targets and the number of refugees showing a moderate linear relationship. We apply the same two methods that we used for candle to pollard. Here is method A, and here is method B.
As with candle method, we found weak linear relationship in all correlation except for moderately strong linear relationship between fatalities caused by shelling of civilian targets and the number of refugees. This slide shows how we applied exponential smoothing similar to previous method. As in previous method, this method reveals a linear relationship of moderate strength only for the correlation between shelling of political targets and the number of refugees. We also applied two methods for median smoothing.
Here we see a result similar to the obtained for the candle method. A linear relationship of moderate strength only between shelling of political targets and the number of refugees. This smooth, almost linear decline in autocorrelation without sharp jumps indicates the stable nature of the migration processes. Without sudden changes in trends, the correlation for attacks on civilian infrastructure remains significant throughout the period, with autocorrelation consistently higher for events blue than for casualties red. This indicates the systematic and stable nature of both events and casualties, with events showing more predictable dynamics over time. Attacks on political infrastructure are more random or situational, while the number of casualties resulting from them remains more consistent over time. The Kherson region has the highest average number of shellings per month, 14 shellings, while the region that suffered the most attacks per month, 139 attacks, is Kyiv. The regions that suffered the fewest attacks are Riona, Volyn, and Zakarpattia. The pattern is slightly different for political shelling. The Donetsk region suffered the most attacks, with an average of 130 per month and a maximum of 757. While the Zakarpattia region suffered the least, with an average of 1.059 attacks per month. This slide shows the proximity matrix for attacks on Ukrainian civilian infrastructure. Kharkiv region most similar to Donetsk, Sumy, and Kherson. Kherson region highest similarity with Kharkiv, Donetsk, and Mykolaiv. Donetsk region highest similarity with Kharkiv and Luhansk. For political shelling, the similarity is slightly different. Kharkiv region instead of Kherson region, now Luhansk. Kherson region instead of Kharkiv and Donetsk, now Zaporizhia and Dnipropetrovsk. Thus, for shelling of political targets, the similarity is based on geographical location, while for civilian targets, it is based on the intimidation of the population and the intentions of the Russian Federation towards these regions.
The study convincingly demonstrates the systematic nature of Russian aggression aimed at destroying both the civilian and political infrastructure of Ukraine, which has led to large-scale forced migration of the population. Clear patterns and correlation have been indicated between the intensity of military operation and the scale of migration, which is critical to understanding the nature of the conflict and its impact on population. Forecasting migration flows and planning humanitarian assistance, risk assessment for different regions of Ukraine, planning of civil protection measurements, development of strategies for the recovery of affected areas, optimization of humanitarian aid distribution, documentation of Russia war's crimes, improving early warning system for threats. Thank you for your attention.
Thank you. It's such thought take to my mind that when one man died, it's tragedy, and when many people died, it's statistics. Such kind of statistics, as for me, aimless. Show us previous tables. Sorry, your pages are not labeled. Number previous slides. Please go back with these slides. Could you go back? Back. When you have median, some statistical table with statistics. Cannot see. Stop. What is the average of political attacks? I don't understand. What is average per month? What is it, political attacks?
It means attack on Ukrainian.
Why it is named political? I don't understand.
In dataset, what we had, that name we used.
Russian-Ukrainian war which were fatal. Fatal attacks, not fatal attacks. It's people was dead, maybe. Okay, but I need a general table for all regions and different statistical measurements. One table for whole slide. Can you find that? Not these pictures, but table. Stop. Here. What is надійність? How it will be in English? Reliability. Reliability. What it is mean? Last column. Very last. 0.099 Cherkasy. What is mean? What all this table can explain us? Mediana, moda. Such statistic is aimless. It's nonsense to present such numbers. What is mean? How I can use such information for predicting refugees, for example?
We can say what region was the most shallowest.
Rozmach. It should be translated into English for auditorium, but what means reliability of data? It's unreliable data is seen from this table. Okay, maybe somebody else has questions to reporters. Sorry.
Yes, I have a question. This is Michael. I'm back again.
Yes.
I found it interesting, also shocking in a way, being in a different country than Ukraine, enjoying peace. Apart from this, I like your last slide where you said potential applications of this data to help in this difficult situation. Can you show the last slide?
Very last.
Where you showed the applications of the research.
Please, to the end.
At the end.
Conclusion. Next one.
The next slide. This one. Yes, I would like to know from you how you are going to use this data in achieving some of these goals, like the planning or the strategies for recovery. Is there already any interface between this data analysis and the way you can help in these regions to recover or to protect the civil protection measures, to increase them? Do you have a model for this, or how is it integrated in the decision making? Maybe just a very high level answer would be good. So, are you, for instance, in contact with the governments and they use this data in some way to help these civil protection measures? So how is this?
For now, it's all we have, and we don't have contact with government or something.
Okay, so it would be probably very interesting to establish an interface that they can make use of this data and make these plannings more effectively and efficiently. So I think it's interesting to use this data in this situation. and I think to plan civil protection, to develop strategies for recovery. But also, I think the refugee prediction is something that is requiring places to be prepared for more refugees to come. So maybe this is another important aspect of this study, because normally you might have a delay between the events that happen, the terrible bombings, and then the people arriving in certain places and need to be accommodated. So maybe this is an interesting also application of this data to help refugees and being prepared for refugees to come.
To predict.
But it's just some comments, some perspectives. I don't. This was my question. Thank you.
Thank you. Thank you very much.
Maybe Professor Emmerich will continue being chair.
I am at home at the moment, so it might be a little bit difficult, but I can.
Okay, then I will continue, if you agree. Thank you for your report. Thank you. It's data is very sensitive and important, and really interface would be additional interface with this how it will be rough data will be useful. Interface with rough data in real time or near real time. Thank you.
Thank you.
We are going to next reporter, Irina Gilai, Maxim Davidov. Yes. Yes.
Hello, everyone. Can you see our presentation?
Yes, we see.
Yes. Thank you so much. Our topic is somehow related to the previous one in terms of the data set, which is related to the ongoing Russia-Ukraine war. And the topic of our presentation is automatic detection of Russia-Ukraine war euphemisms. From this slide, probably you can guess what a euphemism is. These are linguistic expressions, devices used to soften or neutralize language that may otherwise be harsh, awkward to state directly. And by acting as alternative words or phrases, they are used daily to maintain politeness, mitigate discomfort, conceal the truth. But of course, when it comes to our data set, they are used to address sensitive issues such as death, losses, military attacks, to alleviate the mental perception of a harsh reality. And no wonder that the Russia-Ukraine war gave rise and prominence to a number of such new coinages in the Ukrainian language, such as a well-known bavovna, or cotton, meaning explosion euphemistically, ptashka, meaning a drone euphemistically, zadvoksotete, meaning to kill, pіти на концерт Kobzona, to die, etc. So they're all familiar to the Ukrainian users. Euphemisms on the whole are a part of the figurative language, and figurative language processing is one of the key problems in natural language processing. The major problem here, however, is that figurative items and euphemisms in particular are polysemous in their nature, and they require disambiguation. In order to detect them, they require special disambiguation techniques. So the aim of our presentation of our paper is to discover such efficient techniques for the automatic detection and recognition of Ukrainian euphemisms related to the topic of the war, which presupposes the completion of such tasks. First of all, we ourselves collect a data set of Ukrainian war-related euphemisms based on the corpus of modern web communication. Then we elaborate, standardize, and apply the annotation scheme for potentially euphemistic terms. We call them PATs. They are potentially euphemistic because, again, in some senses, they may not be euphemistic. And then we elicit some key difficulties in their recognition and annotation and leverage machine learning techniques for their automatic detection, assessing their performance. The previous research, first of all, viewed euphemisms from the point of view of euphemism treadmill, by which words and phrases gain or lose their euphemistic meaning over time and usually become more negative over time. And this actually also applies to Ukrainian war-related euphemisms. Also, researchers may not agree on what euphemisms are, but they are very close to code words. So techniques and algorithms leveraged to euphemisms can be applicable to code words as well. Automatic detection of euphemisms was studied by a number of scholars abroad, but somehow was not studied in Ukraine or on Ukrainian data. And mostly they propose euphemism detection and identification based on masked language modeling with BERT. However, nowadays we have different trends, and nowadays we have to face it. That's why our methodology consists in using prompt engineering for large language models. So we decided to test both zero-shot prompting, which means that our prompt does not contain any examples or demonstrations, while interacting with the large language model, and few-shot prompting, accompanied by illustrations and enabling in-context learning from the model. The models used in the research are GPT-4 Omni, GPT-4 Omni Mini, DeepSeek. We also tested other models, but they showed worse performance, so that's why we don't mention these results here. And we assessed the class-wise performance of these large language models based on the calculation of F1 score. So the general workflow of this study is as follows. So first, we collect a data set. We annotate the data set manually by 4 expert linguists. Then the data set is processed, testing zero-shot and few-shot prompting. And we also use prompt engineering to enhance the performance of the models. The corpus used for this purpose is called PAVUK, the Polish Automatic Web Corpus of the Ukrainian language, which is a new one. It was built and is being maintained by our partner institution, the Linguistic Engineering Group of the Institute of Computer Science of the Polish Academy of Sciences. The corpus is lemmatized and accompanied by automatic part-of-speech tagging, which actually makes it well suited for our research. The seed list encompasses 21 potentially euphemistic words. Some of them are provided here. And while collecting data, we try to follow some principles. So first of all, we try to get a balanced representation of the potential euphemistic terms across the 3-year period. To get some proportional data from each year. We try to represent all word forms for both euphemistic and non-euphemistic usages. It's a problem of the Ukrainian language that it has vivid morphology and a lot of inflections, so we tried to represent all of them. And we tried to use a corpus-driven approach, which means that we try to proportionately represent euphemistic and non-euphemistic usages, their word forms, based on the corpus data. And identified also cases difficult to classify, so for example, cases of intentional vagueness, play on words, symbolism, etc. So the annotation task basically was disambiguating paths, mostly polysemous items. The annotators had the following task. They had to attach the labels. Label 1 for euphemistic usage of the path, for example, bavovna, meaning explosion, and label 0 for non-euphemistic usage of the path, for example, bavovna, meaning cotton, literally. So here, actually how it all looked like. So the node word was taken in angle brackets, and then a label 1 or 0 was attached. So also we have other examples such as двухсотый, трехсотый, meaning dead and wounded euphemistically, but also preserving their literal meaning. And such cases as the first sentence, командир двухсотый став двухсотым, were the most problematic to annotate, because here you can see play on words, you can see intentional play on words and vagueness. So the resultant data set included over 4,000 sentences labeled for euphemisms. And here you can see all the items which have been collected and their statistics. So the major annotation difficulties were dictated by cases of vagueness, play on words, symbolic usage. Also the vantage point, because some pets are euphemistic and have positive sentiment referring to enemy losses, for example, but dysphemistic when referring to one's own losses, yes. And often we could experience this annotator's bias. The inter-annotator agreement was measured using Cohen's kappa, and for the resultant data set, it amounted to 0.89. So the next stage was experimenting with different prompts, and actually we have experimented with many prompts, but selected here the 4 prompts which turned out to be the most efficient. So the first one was a context-free prompt, or zero-shot prompt, which sounded as follows: for each sentence in the set, determine whether the term enclosed in angle brackets is used as a euphemism or not. And it showed not a bad performance, approximately 0.7 on average when it comes to F1 score. The next prompt was with a labeling sample, because such a prompt was actually developed before in other studies, but somehow for our data set it didn't work very well. Then the prompt with a dictionary definition, and this prompt actually showed the best performance. So the task was to consider the terms to be euphemistic or not euphemistic in the context of war, and the dictionary of definitions generated by the model was also attached. You can see some examples of definitions which were attached to the prompt. And the last prompt was the prompt with a wet list. The wet list of potentially euphemistic terms was provided to the language model, and based on it, the large language model had to identify the euphemism.
For conclusion, you have 7 slides and 2 minutes, and no.
Okay, so this is actually then this labeling was compared with the labeling by annotators, and our conclusion is as follows: that the best performance was achieved by GPT for Omni. Yes, you can GPT for Omni was the prompt with a dictionary definition. You can see that F1 score is more than 0.9. The runner-up is GPT for Omni Mini. So you can see that individual words actually show different performance. Some showed better performance and some showed worse performance. And also it's worthwhile concluding that even though the correct labels have been attached, the model's understanding of the sense or usage is not always correct. So sometimes when it was asked to provide the explanation for the choice of a certain label, so this explanation was not correct. So we can also conclude that the war-related euphemisms are very context-sensitive, manifest vast creative potential of the users, show a tendency towards becoming negative over time, and as mostly newly coined, they are a challenging problem for detection and proper understanding by humans, let alone AI. Nonetheless, neural network models relying on advanced algorithms can facilitate this process and be used in the future. So this is part of the project. Yes, these are acknowledgements of their project detecting and recognizing euphemisms within the PRESU initiative. Thank you for your attention.
Thank you very much. Very interesting work. Maybe somebody have questions to reporter. Maybe,
Yes, I have a question if possible.
please.
The work is very interesting from the theoretical aspects, but I wonder what could you say about the pragmatic of this? If I read the post, I comprehend, is it euphemistic or non-euphemistic? And could we specify exactly the reasons for automated recognizing such things? Thanks.
Thank you for your question. Right. Some human users do not usually find it difficult to understand whether a term is used euphemistically or not. But when it comes to AI and some future applications of generative AI, it can be actually problematic for AI. That's why it should be fed such information, trained, tested, and we also
Yes, I see that potentially this might be useful, but could you name exactly the case when it can be used, or it is not the case?
It can be useful for the disambiguation of figurative language. Sometimes people do not speak directly, They have something on their mind, but they do not pronounce it directly. And
Well, thank you.
mhm.
Any other questions? No questions. Very well. Thank you very much.
Thank you.
Thank you. We are going to next report. Serhiy Tishko, Зоряна Rybchak, Irina Zavushchak, and colleagues who will be reporting.
I was presented. Can you hear me? Because I have something problem with internet.
Yes.
Yes, perfect.
See my slides.
Maybe full screen.
Yeah. Okay.
And you have 10 minutes.
Okay. Let's start. Today we present our research phase shift measurement method based on the half-period converter with amplitude time convention designed for modern weapon system. In modern weapon system, accurate monitoring and diagnostic are critical for performance and reliability. Intelligent diagnostic systems enable faster testing and better condition forecasting for military equipment, such as a named aerial and ground system. A key aspect of this diagnostic is measuring physical quantities like accelerators, angles, and time delays, often reliable and determining the phase shift between two harmonic signals. This forms the foundation.
You're not changing slides. Maybe full screen for slides.
Okay.
First one. We can see only editing.
Okay. Okay. It's the first slide, yeah?
Now
Introduction.
it's already introduction. Okay.
Yeah. This forms the foundation of our research. Phase shift measurement is widely applied across fields like radar, airspace, telecommunication, and non-destructive testing. It also critical in emerging areas like experimental physics and medicine. Disappoint its two important existing methods need improvement to meet the demands of modern technology. Our study proposed a compensation-based method using dual half-period transformation to measure phase shifts more effectively, aiming to enhance accuracy and applicability. Here we introduce the structural diagram of our phase shift measurement system as shown in Figure 1. This system processes two input harmonic signals through input devices, filters, and amplifiers. These signals undergo dual half-period transformation, followed by analog to digital conversion, ADC. A computing device's performance calculations shapes the output and displays the phase shift results. This streamlined design ensures precision and efficiency. Moving to Figure A and to Figure B, these time diagrams illustrate the signals after half-period transformation. The diagrams show how the input harmonic signals are processed to extract phase shift information. Equation 1 and 2 reference here describes the mathematics relation between the signals times and phase. This step is crucial for understanding the signal behavior before further processing. Figure 3 and 3A and 3B presents additional time diagrams highlighting the transformed signals at a later stage. Equation 5 shown here models the phase shift calculation based on these signals. These diagrams help visualize how the system isolates the phase difference, ensuring accurate measurements even under varying conditions. Figure 4 shows the time diagram of the vector of instantaneous values corresponding to specific time points. Equation 6 and 7 describe how these values are used to compute the phase shift. This diagram emphasizes the temporal alignment of signals, which is a key to minimize errors and our measurement process. In the preliminary stage, we determine the per symbol uncertainty interval denotes as L. This parameter is selected based on the required measurements accuracy, considering factors like ADC precision and rounding errors. Figure 5 graphically explains the process for setting this interval during the first iteration, ensuring our method meets the diagram's error tolerance. And now, let's outline the main stage, starting with the step 1. If the uncertainty interval's length is within the per symbol limit, we accept the calculation phase shift value. Otherwise, we check condition based on the interval boundaries as shown. Depending on this condition, we proceed to either step 2 or step 3 to refine the measurement. In step 2, we calculate new parameters to narrow the uncertainty interval as shown in the equations. Step 3 follows a similar process with adjusted parameters. And step 4, we updated the interval and return to step 1. This iterative approach ensures we converge on the accurate phase shift value with minimal error. To validate our method, we concatenate a computer measurement experiment using the Monte Carlo method in MathCAD with 5 trials per measurement. Table 1 shows the results for phase shift regenerating from 0.1 to 0.4 radians. The minimum error regenerated from 15 to 19 minutes, and the maximum from 21 to 28 minutes. These results confirm the method reliability and precision. In conclusion, our proposed method offers scientific advantages over traditional approaches at reduce error from phase asymmetry, lowers the need for signals, level adjustment, and simplifies the method by using a signal ADC channel. This reduces costs by up to 10% in material resource during testing without compromising quality. The method also lays the groundwork for advanced diagnostic system in complex technical applications. Thank you for your attention.
Thank you very much. It's a very radio task phase shift measurement. It's important task, of course, for radio system, and I don't know. Maybe somebody have questions to Peter. Who else is specialist in radio transmission, receiving, and shift measurement, phase shift? Nobody. Thank you. Thank you.
Thank you.
Go to next report then. Yeah.
Next report is probably mine, yes?
Please, yes. Beltykov,
Okay.
I understand. Polish, Litvin, Beltykov, Chestiakov, Kis. Please share your screen.
I'll share my screen. Do you see the presentation?
Yes.
Okay. So, dear colleagues, I'm pleased to present a scientific report on the topic detection and recognition of mines using magnetic field sensors and Kolmogorov-Arnold networks. The authors of this paper are displayed on the current slide. Agenda. The structure of today's presentation is as follows. We'll start by looking at motivation, changes, improvements, and specifics, then a short overview of references and related works. Next is a goal and tasks, then neural network morphology. In computer experiment, we will present an experimental setup, and finally summary and conclusion, where we will summarize the key findings, highlight the advantages of the proposed method. Motivation. Our research was driven by the need to develop an alternative mine classification model that covers the limitation of traditional convolutional neural networks. To address these challenges, we proposed the use of Kolmogorov-Arnold networks, which offer unique advantages in both interpretability and robustness. One of the key improvements introduced by Khan lies in its interpretability. The integration of spline-based weight functions allowed for precise analysis of the influence on individual input features. This level of transparency is crucial for safety certification and regulatory approval in humanitarian demining operations. Another major advantage is robustness. Our experiments demonstrated that Khan models have stable behavior without sharp changes in loss functions, even when trained on dataset enriched with noise. This ensures the reliability of the model under real-world sensor conditions. The combination of interpretable spline weights, sensitivity to small anomalies, and scalability potential makes Khan a great choice for the next generation of modular passive mine detection systems, with strong implication for post-conflict recovery and civilian safety. Specificism and approach. Traditional mine detection techniques, particularly those based on active sensing technologies, carry significant operational risks. Active detectors may emit signals that could trigger explosive devices, putting both operator and nearby civilians in direct danger. This reality highlights the critical need for safer alternatives in mine detection. One such approach is passive detection, which relies on a measurement of magnetic field anomalies rather than sending scanned signals. By avoiding direct interaction with buried explosives, passive methods significantly lower the chance of accidental explosion. In this context, our work focuses on enhancing passive detection capabilities through the use of Kolmogorov-Arnold networks. Related works, our research built on extant prior works, including the research of Peleshchak et al. On 2024, which explores how the structure of neural networks, specifically the use of symmetrical designs, can influence mine detection performance. Building on the theme of improving detection performance, Yilmaz et al. On 2018 proposed a passive mine detection method using hybrid model, using also a special data set which was provided from the using special probe. Further advancing hybrid approaches like Litvin et al. On 2023 present a model that combines neural networks with ultra-wideband rated data. Continuous passive methods, another study of Litvin et al. On 2024 applied magnetic field and convolutional neural networks to detect and classify mines. Shifting focus to more novel architecture, Leo et al. In 2024 introduced Kolmogorov-Arnold networks as an alternative to traditional multilayer perceptrons, describing how they work and their capabilities. To support this direction, Somvasky et al. Provide a detailed survey on Kolmogorov-Arnold networks. They highlight constraints and managing with high-dimensional data and their flexibilities in various application areas. Goal and tasks. The aim of this research is to design and optimize a Kolmogorov-Arnold network architecture capable of accurately classifying mines under various soil conditions. This includes fine-tuning the number of hidden layers, neurons per layer, and the properties of spline basis functions. This work is directly relevant to Ukraine post-war recovery and the broader global missions of humanitarian demining, where accurate and safe detection technologies are critically needed. B-spline. To understand the unique structure and functionality of Kolmogorov-Arnold network, it is essential to examine the mathematical foundation of B-splines, which constitute the core computational elements of functional layers. A B-spline, basis spline, is a piecewise defined polynomial function widely used in numerical analysis and computer graphics for modeling smooth curves and surfaces. It is defined over a non-decreasing sequence of control points and corresponding knot vector, which determines the location and continuity properties of the boundaries between polynomial segments known as knots. Each segment of B-spline is polynomial of specified degree, and the entire function is constructed to maintain a specified degree of smoothness between neighboring segments. This property allows B-spline to represent complex smooth function while maintaining localized control. Mathematically, B-spline of degree k is expressed as a linear combination of basis functions b, I, k from x, each of which is recursively designed by the Coq-de-Boer recursive formula. This recursive construction ensures computational stability and adaptability. One of the key advantages of B-spline is their local control property. Changes to a single control point affect the shape of the curve only in limited region. They work especially well in situations with noise or uneven data, exactly the kind of problem found in passive mine detection using magnetic field anomalies. In CAN, the B-spline method helps the network learn smooth and flexible nonlinear connection between sensors, input, and classification results. Neural network morphology. The architecture of the proposed Kolmogorov-Arnold network is designed to process magnetic anomaly data for the purpose of mine classification. The model receives a compact yet informative input vector consisting of three features, voltage, height, and soil type. These features are chosen for their relevance of magnetic signature variation and mine detection accuracy. The input layer, V3, maps three features into the first hidden layer using spline-weighted connections. The network then propagates information through two fully connected hidden layers, V3 by 16 and V16 by 16. Each layer utilizes spline activation functions denoted as Phi, which allows the localized and interpretable nonlinear transformation, nonlinear transformation. These spline functions enable the network to approximate complex mappings while maintaining smoothness and avoiding overfitting. The output layer with shape 16 by 4 produces a probability distribution across 4 mine classes, giving clear and smooth prediction for mine classification using 3 input features. To help the model generalize better and avoid overfitting on a small dataset, because dataset got like 338 measurements, in particular, we added pseudo-random noise to the voltage and height values. This artificial change simulates real measurements errors on environmental changes, making the training process more reliable. The added noise increases the variety of training examples while keeping the main structure of the data the same. Computer experiment. To evaluate the performance of the proposed Kolmogorov-Arnold network architectures, we conducted a series of training experiments using configurations CAN 3.16.16.4 and CAN 3.64.64.4. The input vector contains three features: voltage, height, and soil type, and the model produced four output classes representing different mine types. The performance was evaluated using a full set of metrics. The accuracy, the ratio of correctly predicted instances to the total number of predictions, precision, the proportion of true positive predictions among all predicted positives, recall, the proportion of true positives captured among all actual positives, F1 score, the harmonic mean of precision and recall, and macro and weighted averages. For CAN 3.16.16.4, the model achieved an overall accuracy of 93.56%. The training loss went down steadily, while the accuracy kept increasing, showing that the model was learning well. The confusion matrix show that a few mistakes, mainly between classes 2 and 3, where the magnetic features might be similar. In contrast, the deeper configuration CAN 3.64.64.4 yielded the improvement accuracy of 95.59%. The confusion matrix of this model demonstrates fewer errors across all classes, especially a significant improvement in correct identification of class 2. F1 score rose from 0.8936 to 0.9396. Moreover, the loss function shows more rapid and stable convergence, indicating better learning dynamics of the expanded architecture. Comparing the two architectures shows that the larger model can better handle complex feature interaction. The CAN 3.64.64.4 network lowered both false positives and false negatives, and it also generalized better, especially for classes that were harder to tell apart before. Summary and conclusion. For the first time, we applied Kolmogorov-Arnold networks, or CAN, using cubic B-splines to tackle the problem of the passive mine recognition based on magnetic anomalies. What sets CAN apart of traditional neural networks like MLP? Its ability to model nonlinear relationships directly through await connections. That makes the model more resistant to sensor noise and also help us understand how it makes decisions, an important feature for safety-critical tasks like demining. To support the model, we expanded a dataset starting with 338 real recordings of magnetic anomalies. We added synthetic samples using controlled normal distributions, more specifically 50 new samples for each unique soil type, mine type combination. This helped balance the dataset, increased variation, and reduced the risk of overfitting during training. We developed and tested two CAN architectures, the smaller one with 16 neurons per hidden layer and the larger one with 64 neurons. Both were trained by PyCAN library, fully compatible with PyTorch, so using Python, and use the same spline settings to keep the comparison fair. The smaller model achieved accuracy of 93.56%, with most misclassification happening with anti-personal mines and booby traps, which often share similar features, but when you decrease the number of neurons to create CAN 3.64.64.4, the performance jumped to 95.59 accuracy. The results show that the CAN has a strong sensitive scalability for passive mine classification. The larger model gave better results while still training smoothly without instability. Thank you for your attention. That's all I wanted to tell you. We'll be pleased to answer your questions.
May I ask a question?
Yes.
Well, the diagram you have shown of Kolmogorov-Arnold network.
On which slide?
Look like the usual multi-layered usual convolution network or even multi-layered perceptron if we add after each layer a pooling layer which summarize some nodes. Can't you achieve the same result for a specific time simply by adding such pooling layers or not?
Well, the main key feature of the CAN is that you use instead of using the default for the MLP weights on edges and function on node, summarized node. In this neural network CAN, we use, as I said earlier, a B-spline, which means you can change, as you will see on this picture, in this figure, you can see that there is a lot of different functions in it. So it splits like in different functions, and these functions are learning the special shape for each like feature which can be extracted from the data. That's
But
help.
thank you. But it's clear. But did you explore the effect of such measures in comparison with using the simple multi-layered perceptron, or even not simple, but by adding pooling layers? Have you any calculations of this or not?
As I said earlier, the thing is that because of the structure of this neural network, it is it have, as I said here, it has interpretability and robustness instead of default MLP, which uses like just one weight on each edge. And the activation functions are stable on each node. They don't change. And here we use our special feature of B-splines that adapt to our input data, so it can take like special, it can find special features in process of training. Then we can check this out, how our neural network view when it's trained. And then we can see how the neural network know which exact type of mine activating each of nodes.
Well, thank you.
Other questions? Exactly about this picture. This data, voltage, height, and soil type. It's one-dimensional data. It's dependence, these three parameters, dependence from time or from horizontal coordinates, or what is the set taken from?
Okay, the data set was collected from the previous work, as I said earlier. So the work of Yilmaz and Krahaman, Soiler, and their passive mine detection and classification method based on hybrid model in 2018. So they used a scanner called F400, or I can't remember exactly, but they used like a stand, huge, like huge stand with this probe on a height like about on a different height, because we're using the normalized. Here we see only normalized data, but they had also real measurements, and these measurements were presented in our paper. So these measurements were made in laboratory with different soils. So they used different soils, poured it on the mines, and then used a special stand with different height, and measured this information and collected them in dataset. Yes.
Okay.
So we used it.
Spatially, it's one point only height changes. Yes, spatially, not in x coordinates, x, y.
Yes. So it was like put it like this one and then changed. Hey, yes.
Okay. And the task to recognize which kind of mine you have, not to recognize exist mine or not exist.
No, the mine class number 1, it's the empty.
Empty.
It means no mine is there. Yeah. And class 2, 3, and 4 accepts anti-personnel, anti-tank, and booby trap.
Okay, understand.
Yes.
Thank you.
Yes.
Thank you. If no other questions, thank you very much, and we're going to next reporter. Thank you. And next is Katerina Bilik, Narushinska, Leszczynski. Somebody?
Yeah, I'm here.
Okay, please share your screen.
Yeah, do you see my screen?
Yes, very good.
Yeah, so hello everyone, my name is Katerina Bilik, and today I'm excited to present our research on integrating convolutional neural networks and autoencoders for automated skin lesion diagnosis. So, and my co-authors are Olga Narushinska, Petro Leszczynski, and Vasyl Tslyu. So let's start. The goal of this work is to enhance the efficiency of skin cancer detection, which includes primary image validation. So we need to understand if there is mole on the image, if the image is suitable for future analysis, also its lesion classification and segmentation. The object of the study is the process of analyzing images of skin lesion using deep learning methods, and the relevance lies in addressing a growing workload of medical professionals and the need for rapid decision-making. Automated image analysis helps improve diagnostic accuracy and reduce the risk of missing dangerous lesions. So the task was to review current research on automated skin lesion diagnosis, focusing mostly on segmentation and classification methods. After that, evaluate the effectiveness of various neural network models for lesion detection and analysis, and select optimal approaches for system development, including data preparation, model choice, and result evaluation. So we used the HAM 10,000 dataset, which contains 10,000 training images of various skin lesions. As you can see on the slide, include melanoma, basal cell carcinoma, melanocytic nevi, regular one, and many others common skin conditions. And also to enhance our training data, we also generated 1,000 additional synthetic images by strategically placing mole fragments on artificial background. Also, Mohs scaling was applied and overlaps were avoided. A corresponding segmentation mask was automatically created for each image. We did it because we didn't find any good data sets that contains different moles on one image. So let me briefly walk you through the two diagrams shown here. First, on the left side, it's data preparation. The diagram shows the preprocessing pipeline we use to ensure high quality and balanced training data. We start with class analysis to check whether we have enough images per class. If some classes are underrepresented, we apply oversampling to balance the data set. Then we split the data into training, validation, and test sets. We also make sure there is no data leakage. If any images overlap between sets, we remove those duplicates from training data. Next, we also apply data augmentation. It involves small shifts, rotation, scaling, minimal brightness and contrast adjustments, and also image normalization. Second, on the right side, it's the main algorithm. This flowchart describes the core logic of our modular pipeline. We begin from downloading the image and applying some initial preprocessing, as on the left side. Then image goes through the validation step using the autoencoder. If the image is invalid, for example, it's blurry or corrupted, or there's no mole on it, we return just validation result and stop the process. If image is valid, we proceed the segmentation, where we identify and isolate the mole or moles in the image. If there's more than one mole is detected, the image is divided accordingly, and each mole is classified individually. So if there's only one mole, we classify that directly, and after that, we return the result for one mole or some number of moles. So firstly, we developed an autoencoder for image validation. This component acts like a quality filter, determining whatever an image actually contains an image, a mole, or some picture that worth analyzing. Here you can see all the trained autoencoders. The worst results are highlighted in red and the best in green, and the best model is autoencoder with Latin DIM 100 and batch size 32. So also using peak signal to noise ratio measurements, images with Pisana value above 25 are classified as containing valid moles, and while those below the threshold are flagged as potentially anomalous or requiring retaking. Here you can also see the architecture of developed autoencoder. Second, for segmentation, we implemented mask RCNL, which creates precise masks around individual lesions, enabling accurate boundary detection and measurements. And our best model shows the intersection of union is 87%. Thirdly, for classification, we tested multiple architectures, including ResNet, EfficientNet, AlexNet, SqueezeNet, VGG, and many others. And also the table represents the training results. The worst results highlighted in red, the best in green, and our best model is ResNet with batch size 16 and learning plate, as you can see on the slide. So here you can see also our pipeline. First, we do a request with some images. It can be one image with one mole, or for example, it can be different moles on it, because if person have so many moles, it's very hard to take a picture with only one mole on it. And the limitation of existing programs that do skin cancer detection, that they use only one mole for classification. But in this case, we can apply classification to each mole individually. After that, we segment each mole, and after that, also crop moles from the images. It's very important to avoid some, for example, hair or something like that that can change the view of the mole. And after that, we just do a classification with just with ResNet. So, in conclusion, a ResNet-based classifier achieved the highest performance. It's like 89 accuracy and one score also the same, outperforming other model, EfficientNet, AlexNet, Inception, SqueezeNet, and VGG. Also, mask RCNN segmentation yielded precise lesion masks, enabling reliable extraction of individual modes. And also, an autoencoder was effectively filters out non-lesion images, so we efficiently filter out all images there's no mole on it, and improving overall pipeline efficiency. And next steps is to develop and validate a clinical prototype to support early diagnosis and streamline dermatology workflows. And also, I think it would be a good idea to add some explainability to this model. And yeah, it's I think idea for the future researchers. So thank you for your attention. If you have any questions, don't hesitate to ask.
Thank you. Any questions, please, from listeners? I have a question about, is it possible to implement such software in some smartphone and self-test for self-testing purposes, for example?
Yeah, actually, I deployed some version of Fast API, Fast API on AWS. So yeah, I tried this pipeline on myself. Yeah, and hopefully it didn't show me that I have some problems with my mouse. So yeah, I think it's a good idea to develop some apps, probably for Android and iOS, and yeah, just also add some validation process of input images. So, for example, we can add some instruction for our user how he need to take this picture for good results. So for best accuracy. Yeah.
Interesting. But about your presentation, 2 slides before, please show here. Why you need so many numbers after point? It's I don't know, noise. It's a spam. How many numbers are important after each for all this?
I think only 4 digits we need for
Yeah.
understanding. Yeah.
Therefore, all these numbers non-informative, as for me, should not be shown because it's hardly to recognize difference between 2 different numbers, 2 different BLK and GF because too much non-important numbers after point. You understand what I mean?
Yeah, it's true. It's true. I need to change it. Thank you.
Very often we see such from students labs. Okay, thank you very much. Maybe somebody else have questions or comments? No? Then thank you.
Thank you too.
Please, next report, it will be Христина Ліп'яніна, Гончаренко, Ignatiev, Boguta, Yurkiev, who will be reporter.
Yes, I will be reporter.
Okay.
Both.
Please share your.
Can you see presentation?
Okay, we see.
Okay, let's start. Good morning, everyone. Today I will be presenting our recent work on a rule-based approach for automatically mapping media text to specific articles of Ukrainian legislation. The motivation for our work stems from the growing volume of information and hybrid information threats in Ukraine. In this environment, legal experts and institutions need a reliable and explainable AI solution to evaluate whether news content violates or relates to national law. Our goal was to create a tool that can classify whether a media article corresponds to a legal provision while also detecting its emotional tone. We focus on rule-based logic for full explainability and reproducibility, a key requirement in legal applications. The core of the system is built around manually crafted dictionaries that define key terms for each legal article. It counts the keyword matches and checks if they meet a predefined threshold. The tool is fully implemented in a user-friendly Streamlit interface. Let me explain the algorithm in detail. First, we normalize the input text and all dictionary phrases by converting them to lowercase. This ensures that the matching is not affected by letter casing. Each of the 20 legal articles is linked to a predefined dictionary of expert-selected key phrases. The algorithm iterates through each phrase and checks for its presence in the input text. For every match found, a counter is incremented. After checking all dictionaries, we get a vector of match counts. The article with the highest count is identified. If this count meets or exceeds
a present threshold, which we set at 5, the article is considered relevant to the input text. If no article meets the threshold, the system output not found. This logic ensures that the system only flags strong matches, reducing false positives. The Streamlit interface allows user to either input content directly or fetch it from a URL. The expert can modify the keyword dictionaries, which keeps the system up to date. There is also a toggle for sentiment inversion, useful when dealing with sarcasm or irony in text. To assess the system performance, we tested it on a control dataset that evenly covers 20 legal categories. The model achieved strong and balanced results. Precision was 0.84, meaning most predictions were correct when the system flagged a match. Recall was 0.83, indicated it successfully captured the majority of relevant matches. The F1 score, which balances both, was also 0.84. Overall classification accuracy was 83%. The confusion matrix showed good alignment along the diagonal, indicating that most predicted classes matched the true labels, with only minor confusion between similar categories. We also evaluated the system on 15 actual news articles from trusted media sources. The tool correctly identifies specific legal articles in 5 of those 15 cases, about 33%, showing that it performs well on real unstructured data, especially in categories like military or internal affairs. In contrast, articles related to Ukraine international image are less often matched, likely due to less developed keyword dictionaries in those topics. The sentiment model also performed robustly. 8 articles had a clearly positive tone, 4 were negative, and 3 were neutral. The ability to assess both legal relevance and sentiment makes this tool powerful for reputational risk analysis and content compliance. Now let's place our work in a broader context. Rule-based systems are widely used in domains like medicine, cybersecurity, and finance. For example, medical Q&A classification system using expert dictionaries often achieve over 85% accuracy. In social science research, similar approaches with local LLM and structured rules have reached 88% accuracy. Our model's F1 score of 0.84 is competitive with this, despite the legal domain being more complex and less explored in this context. What sets our system apart is its unique application. It lifts news content to actual laws, not just categories or SAMs, which makes it particularly viable for government or legal monitoring. The key strength is transparency. Legal analysis can fully trace why a text was matched to a certain law. However, the current system may miss shorter news posts. To summarize, the rule-based system provides a transparent and explainable tool for legal content alignment. It is ready for practical use in legal and media institutions. Through future improvements will help it adapt to more varied content. This concludes our presentation. We welcome your feedback or questions. Thank you for attention.
Thank you very much. Please, questions if are any. Maybe I'm lost, but can you compare your rule-based system with LLM system?
So LLM systems can achieve 88% accuracy, and our system was 83% accuracy. So our system can be competitive with these LLMs.
But it looks like LLM better for 3%.
Yes, but we can improve our system in much ways to improve our dictionaries, make these add machine learning in this work and improve our accuracy.
Okay, set of rules can be updated using LLMs, for example.
I think yes.
Then it's mentioned before explainable AI. When you have the rules, you can explain results, yes, but using LLM, you cannot predict which result and explain which result you obtain. Okay. Thank you very much. Maybe somebody else have questions or comments? No. Thank you then.
Thank you.
And we are going to next report. Maybe a few minutes in advance, but if Kondratenko, Sova, Kozlov, somebody ready?
Yes. Can you hear me? Excuse me.
Yes, please. Share.
Yes, I will shortly show the screen and we'll start the presentation.
Okay.
Can you see it clearly?
Yes. Yes, we can see.
So I will start the presentation shortly. First of all, good day, dear colleagues. My name is Ivan Sova. First of all, I would like to thank everyone for joining here and also the conference committee for giving us an opportunity to present our research on the identification of unmanned aerial vehicles using RF fingerprinting and deep learning networks. The authors are Yuri Kondratenko, Ivan Sova, Alexei Kozlov, and Vitaly Kuzmenko. The structure of the given presentation is as follows. The introduction, the problem statement, the proposed approach, meaning the RF fingerprinting techniques for identification of unmanned aerial vehicles, the evaluation of the proposed approach using deep learning networks, and the conclusions based on the results of the experiment. The growing use of unmanned aerial vehicles. UAVs are increasingly used in various industries, such as surveillance, in defense and urban monitoring, in logistics, including package delivery and inventory tracking, as well as industrial automation, such as plant inspection and agricultural monitoring. Their growing presence has introduced security, identification, and management challenges that demand robust detection methods. Researchers have explored various machine learning algorithms for detecting drones using different sensing methods. Such approaches may include computer vision-like models, with models like YOLO or Musk RCNN for image and video recognition, some audio analysis systems that detect drones based on unique sound patterns. In some cases, even fuzzy logic systems are incorporated to enhance adaptive classification in uncertain environments. Sometimes these systems are fused together in so-called data fusion systems, where multi-sensor data is joined to improve robustness and accuracy. However, in recent days, a new approach has also been gaining traction. It is relatively young, but still is quite developed. Still gains development to this day. I'm talking about radio frequency machine learning. The definition for a radio frequency machine learning system was given by the DARPA in 2019. And according to this definition, the radio frequency machine learning system aims to learn to recognize a specific transmitter based on the unique RF fingerprint that is naturally imparted by hardware imperfections within that transmitter. On the next slide, we show our proposed approach for the identification of UAVs using radio frequency fingerprints. This approach involves several steps. First of all, dataset retrieval. Then we go over to the data preprocessing stage. after which we go over to the feature extraction process, where we use digital signal processing techniques to extract several feature vectors, which we then apply to the deep learning-based classification systems, in our case, convolutional neural networks and residual neural networks. The next slide will show the public dataset used for this research, named DroneRF. It was provided by Mohammed Al-Sad and other authors in their 2019 work, DroneRF dataset, a set of drones for RF-based detection, classification, and identification. This work outlines the algorithms and steps to create and populate your own drone dataset, but the already provided by the authors dataset was used. This dataset was collected from two 40 MHz receivers in the ranges of from 2.4 to 2.48 GHz. It captures signals from three drone types: Parrot Bebop, Parrot AR, DJI Phantom, as well as background noise. The details are shown in the table below. It is worth mentioning also that this dataset provides several levels of classification, from drone presence to drone type to even flight modes for several of the drones. However, for the purposes of our research, we only use the second level of classification, meaning the drone type. As a result, we are presented with a class imbalance, as well as a quite large sample size of 2 times e to the power of 7, which may present some computational difficulties for us. That is why we proceed to the data preprocessing stage, where we apply a thresholding technique to segment signal data into RF packets. Since background noise packets lack any radio frequency information that is related to drone activity, thresholding is not applied to them specifically. Furthermore, the resulting packets are then subsequently split into equally sized chunks that contain 4,000 samples each to speed up the training process in the future. Finally, the resulting dataset is then balanced using an undersampling technique by generating centroids based on k-means clustering. And it is mostly applied to the background noise since the resulting dataset contains this class the most, and other classes are somewhat balanced. After that, the next several slides will display the algorithms used to extract features. Basically, the radio frequency fingerprint mentioned before. The first of which is the power spectral density, shortly PSD. It describes how the power of a signal or process is distributed across different frequency components. To calculate it, we must obtain first a frequency domain representation using the discrete Fourier transform. And since I've mentioned that every signal is captured using two receivers.
Просто штука така, що це, знаєш, ти кажеш там за знижку, за ще щось, чи це, там почекати у далекі місці. Я тобі скажу, от як ми шукали офіс.
One moment.
Excuse me for a second, yes.
Ми теж, от як тільки заїжджали, ми там дивилися.
Thank you. I hope that wasn't a problem for anyone. Let's continue. As I was saying, because every signal packet is represented by two parts of the signal, a low band and high band from lower and higher frequencies, both of these components should be used for computing this PSD. They are computed separately and then concatenated with a normalization factor calculated to ensure the spectral continuity between these two parts of the spectrum. The next feature vector that was computed used short-time Fourier transforms. It splits the signal information into smaller overlapping segments and applies the DFT, meaning discrete Fourier transform, to each of the segments. And the resulting output is this spectrogram, meaning a two-dimensional array that describes the frequency content of a signal over time. However, instead of using the raw spectrogram itself for the training process, several other features have been inferred from this representation, which are then concatenated themselves in a single feature vector for further use. These key features which were derived are spectral centroid, spectral flux, and spectral entropy. A spectral centroid basically means a measure of the center of mass of a spectrum and is often used in signal processing, particularly in the analysis of audio signals. Spectral flux, on the other hand, is a measure of how much the spectral content of a signal changes between consecutive frames of time windows. Changes between every frame computed with the spectrogram. And finally, spectral entropy is a measure of the disorder or unpredictability in a signal's frequency content. The three of these features were then concatenated into a single vector and then used in the following steps. Finally, the last feature vector that was computed used wavelets, namely wavelet packet decomposition in our case. Wavelet transforms are a mathematical tool used in signal processing to analyze data at multiple scales or resolutions. And in this work, we used wavelet packet decomposition to generate a flexible and detailed multi-resolution analysis of a signal. In our work, we use 6 layers of decomposition. And this resulted in 64 sets of coefficients, which we applied the Mayer wavelet to. The resulting sets of coefficients were then used to be characterized with 2 key features, the root mean squared error and the standard deviation, which were then used as a feature vector, meaning that every single sample had 64 times 2, 128 unique features. The next steps outline the model architectures used in our proposed approach, the first of which is the convolutional neural network. In our case, we used a CNN architecture that was heavily inspired by the LeNet architecture. It consists of 3 convolution modules and 4 dense modules. 3 convolution modules each consist of a 1D convolution layer, batch normalization, activation function using a rectified linear unit, and a max pooling layer. Every subsequent convolution module decreased the dimension sizes for filters and kernels from 64 to 16 for filters and from 11 to 3 for kernels. After that, the inputs are flattened and used for the fully connected layers, which consist of, well, fully connected modules, which consist of a dense layer, a batch normalization, a parametric rectified linear unit, and a softmax function at the end. We use 0.25 as a default value for pre-loose learnable parameter alpha, and the fully connected layers incorporate 512 to 56, 128, and 4 neurons respectively. Let's compare it to the architecture of the residual neural network used in this research. As we can see, the dense modules remain are nearly identical to the CNN, I would say fully identical. Instead, the convolution modules are replaced by 2 long short-term memory modules, each of which incorporate 64 units, meaning a number of neurons in the hidden state of the layer. Other parameters for the dense modules stay roughly the same, from 512 to 4 neurons as we downgrade, and 0.25 as a default value for prelude. The next slide outlines the training parameter used for our process of training. And we have chosen such features like an adaptive moment estimation as our optimizer, a categorical cross entropy, a classic loss function for multi-class classification. Our training was carried out using a batch size of 32 over 50 epochs with a learning rate of 0.01. And finally, we've used a performance metric of accuracy. It is worth mentioning that the training process was carried out using a 5-fold stratified cross-validation to achieve class balance on every step. After carrying out the training processes for each of the module architectures using our resulting feature vectors, we are left with 6 resulting models. And the results of training are displayed in several slides after that. First of all, here you can see the confusion matrices for the CNN models that use power spectral density, short-time Fourier transform, and wavelets, as well as RNNs on the next slide. The shown confusion matrices were then aggregated into a comprehensible table that displays the performance metrics for each of them, as well using the accuracy and the F1 score. As we can see, in our case, the combination of the convolutional neural network and the wavelet-based feature vectors achieve the highest classification metrics. In comparison, the PSD dataset shows the worst results the CNN is unable to correctly determine the background noise packets, while the RNN overfits on them. In turn, the STFT-based dataset exhibits slightly better results. However, in this case, it still underfits a bit on the background noise, while the STFT-based RNN fails to ascertain enough features to distinguish different drone types from one another. We can draw conclusions from this research. The results demonstrate the effectiveness of convolutional neural networks for RF-based machine learning using wavelet-based feature extraction. We have achieved a high classification accuracy of 97%, with effectively determining the drone type. These findings highlight the potential of deep learning models, particularly CNNs, in enhancing the accuracy and reliability of drone identification through RF fingerprinting, and the use of wavelet-based feature extraction proves to be a significant factor in improving classification performance. We can note that the future work could explore real-time deployment, fusion with other modalities, for example, using these datasets with audio or image-based data. We can also research the improved RNN architectures or hybrid models, or try to further optimize them, or even try to expand datasets with more UAV types. I would like to thank you all for your attention. Any questions are welcome. Thanks again.
Thank you very much for your interesting presentation, and very important in our conditions. Maybe somebody have questions to reporter. To Ivan Sova. Please tell me what ratio signal to noise should be provided to recognize anything.
Well, usually these data sets show relatively high classification accuracies with a positive SNR, at least 15 plus decibels. It still proves difficult to ascertain different types of drones with either the zero SNR or even negative. It is almost impossible still. I've seen several papers and researches that try to remedy this issue. For example, I've mentioned audio-based and data fusion systems. And one of the papers explored how one would combine radio frequency signals with audio-based datasets, and they, how would I say it? From their research, they're trying to prove that combining audio data with radio frequency data, while audio datasets are not necessarily the main source for classification, they may prove useful to improve stability against noise.
Mm-hmm. Okay, another question. If you should use 2 points of measurement, 2 different points, and some part of noise will be could be decreased, use a difference between signals from 2 different points of measurement of radio frequency, 2 roznesení, separated dimension, spatially separated antennas, different, and combine measurement of a few different points to decrease noise. Maybe it will increase it reliability of result.
I haven't thought of it that way. Are you proposing using several models that each pick up data and say combine them in a sort of transfer learning?
No. No, how it will be pre-processing before the same model, but data taken from 2 different places for the same object measurement to decrease noise level.
It may prove useful, however, in my opinion, there should be quite, let's say, quite a huge data set has to be extracted since on several levels of distances.
This could be the same.
But this is an interesting, let's say, an interesting approach that I have not yet considered.
Yeah, I understand. Then when you know what kind of binary sequences this UAV use it to exchange data with operator or with another UAV, if you can predict sequences of signals, maybe it will be also useful to recognize signal from UAV.
That may definitely be the case. And there are several sources of communications between the operator and the drone, which may be all incorporated for the purpose of detection.
Mm-hmm. Okay, maybe we will talk another seminar, but it's interesting task, and your report is also very interesting. Thank you.
Thanks a lot as well. I will stop sharing the screen and will pass over to another report.
Thank you, and we are going to next report. Julian Kurelyak and Michael Emmerich.
Hello.
Are you ready? Please
Yes.
share your screen.
Can you see my screen?
Yeah, but oh, okay, full screen.
Nice. So my name is Julian Kurelyak. I am from Lviv Polytechnic, and the topic of my presentation is toward complexity reduction of large-scale epidemic simulation in two-scale networks. The work was supervised by Professor of University of Uvascular, Michael Emmerich. Here is the roadmap. I will start with principle of epidemiological modeling and its complexity problems. Then I will move to the idea of divide and modeling to two layers and describe the details of each layer. The basic epidemiological model is SIR, as you can see here. That means that a node can be in a susceptible, infected, or recovered state. The process is usually simulated with continuous time Markov chains. As you can see in the picture, a node 3 is infected, and the node may infect some neighbors or recover itself. The method is very accurate. It can predict the exit time to a next event, but in the same time, such exact timing require huge computational resources, and such the method was described in details in our previous paper, and here you can see the reference. Also, you can see the reference in the end of the presentation. Here is the bottleneck. The complexity grows with number of nodes and edges quadratically, and in the picture you can see the time comparison for different implementations of pure Gillespie algorithm that take way more time on real simulation process. In this case, to simulate a city of 10,000 individuals, it requires about a few minutes. But if you simulate a country of 40 millions, it requires a few weeks. But in real cases, when we trying to analyze some policies, it requires a few thousand of runs. So this is why we have to optimize it, and the pure Gillespie algorithm will know a lot us to do this. So we present the two-scale idea. As you can see in the picture, there are some parts of networks with highly connected nodes. We can call the parts as communities, and as you can see here, there are some edges between such communities. So we propose to identify the communities as a one meta node and cut the edge between communities and replace it by only one weighted edge like this one. This allows us to divide the simulation to two different layers. Here you can see the Sankey diagram that will visualize the infection flow between communities. On the left side, you can see inter-community infections. That means infections between different communities. And on the right side, there are intra-community infections that were occurred in a single community. I mean, in only one community. So if infection occurred in community one, and the infector was also in community one, the infection will be taken into account here. The Sankey diagram was originally built for logistic and is not typically used for epidemiology, but it's an interesting diagram that may say a lot about the flow between communities. Even in very highly centralized network like Barabashi-Albert, that it is that was used to build the diagram, we can see that half of infections were on the macro level and half on the micro level. So we can divide the simulations and benefit a lot from it. We propose to identify micro layer and macro layer. At micro layer, we simulate each community separately, and there are two values that characterize the community. This is contagiousness in the point of time and susceptibility in the point. And the values are used on the macro layer, where every community is considered as a macro node that seeds infection into other communities. On the micro layer, we take into account only one particular community that is simulated with Gillespie-based algorithm that was nicely described in our previous work. The complexity is that some random nodes gets infected from outside, I mean from other communities. And there is a challenge to model the waiting time between events after such random infections from the outside. Here you can observe how such random infections speed up the dynamics and how it shortifies the time when the peak occurs. Here is the formulas. How do we propose to simulate it? We have the total hazard level of the system. We generate exponential time to next infection. Then if some additional infection occurs, we just take a ratio of the random infection, and take the rest of the hazard level, we recalculate it, and recompute the time to the next infection. On the macro layer, community is a macro node that is characterized by levels of contagiousness and susceptibility that change over the time, and the values are updated from micro layer at each possible discrete step. So we generate time to the next infection by computing the integral of hazard level. This is cumulative distribution function, and we iteratively add the hazard level until we reach the time when an event is possible to start. To sum up, we model each community independently and aggregate the result on the macro layer, and it allows us to reduce the complexity from n squared to n squared divided by m, where m is number of communities. In the future, we are planning to replace agent-based simulator by approximated car of infected. This will make the simulator even more efficient. Also, the two-level model allows us to simulate interventions easily by modifying parameters of a particular community or modifying edges between the communities. And the third point that we would like to involve is to apply the data on real-world mobility as weights between the communities. Thank you for attention. Here you can observe the contact info and references of papers that were used in the presentation. If you have any questions, please ask.
Thank you very much. Maybe somebody have questions or comments. I'm afraid nobody. If not, let me thank you again. Going to next report.
Thank you.
Thank you. Please stop sharing your screen. And we are asking somebody from report Иваницкий, Аверьянова, Сауляк, Знаковська, Молчанова, who will present report number 25.
Yes, I have.
Okay.
I share the screen. See this my screen?
Yes.
Okay, thank you. Dear colleagues, to thank you for the opportunity to speak at this conference. It's your pleasure to present your paper development and National Aviation University is machine learning driven UAS mapping for automated detection of nutritional definitions and design in beds. This report focuses on the development and the implementation of machine learning-based algorithm for plant condition classification using UAS captured images. It explored the source of visual data obtained during drone flights and methods for processing this data to diagnose plant health. Additionally, the report highlights best practices in applying artificial
intelligence and the UA's technologies to support decision making in agricultures, particularly in detecting nutrient deficiencies and disease-related damage for timely and effective treatment. The increasing demand among farmers for timely and accurate information regarding crop health initiative, the development of reliable, scalable, and cost-effective solution for continuous plant condition monitoring. Traditional methods are often time-consuming and labor-intensive, which limits their effectiveness in large-scale agriculture every moment. And unnamed aircraft system do their mobility, flexibility, and ability to cover the wide areas rapidly have emerged as promising tools. Motivated by these adventures, the study explores the integration for UAS technology with modern machine learning process to enable automated plant condition analysis. We propose a novel algorithm that processes early emergency captures by UAs to assess the state of vegetation, identify critical zone affected by nutrient deficiency, or design support real-time decision making for prompt information. Modern agriculture faces growing challenges such as climate changes, increasing population, and the need for sustained food production. Ukraine, being one of the leading grain producers, places particular focus in winter breed hills, which covers up for 14% of total crop area. However, the aid this key crop is often limited by plant disease. Mm, limited by plant diseases, nutrients deficiencies, and unfavorable remote condition, which can lead to loss of up to 17% depending on the severity of stressors. To address the need that timely and accurate diagnostics is proper and releases to use the unnamed air vehicles requires this imaging sensor integrated with artificial intelligence and machine learning technologies. UAS offer multiple benefits, lost cost, rapid deployment, access to hard to reach areas, and compatibility with various sensors. Combined with artificial intelligence machine learning, the system will enable effectiveness monitoring, classification of plant condition, and support decision making for timely imitation. To ensure timely accurate monitoring of crop condition, we development and intelligence data processing pipeline based on UAS imaging and machine learning technologies. This process begins with continuous capture with high resolution RGB images using a camera mounted on an enemy aircraft vehicle. At the final stage, a detailed condition map is generated along with flight route of the judging application of verticalities of or protective treatment. All capture measures are automatically standardized with uniform color space and realizes 50 to 50 pixels. Each resized image is flattened into a flavor vector of 7,500 elements, which serve as input the random forest classification. This classifier is trained iteratively with model correct relation on control sample after each train loop. This is block diagram algorithm is workflow with automatic route monitoring and route planning with demonstration in this figure. Firstly, we start this process. Secondly, formattation of training dataset. Its collection of flight image is deployed, including samples of planned condition related to typical disease symptoms and signs of nutrients deficiency. Next is processing. Its images undergo normalization and resizing to prepare this analysis. Next is UAS flight and data collection. Pre-programmed UAS route is used to capture flight image and coordinate data. Image processing the raw images from UAS and transformed into vectors for machine learning. Model training is random forest model. This training is processed image data. And nice condition mapping, data export, and accuracy evaluation. As visual data generated where plan condition, key data point, and finally accuracy diagram is created to assess the performance in training model. And this algorithm allows for scalable, cost-effective, and timely planned health assessment, making it a valuable tool for precision agriculture and rapid decision making in the field. As the primary stage, the randomly single class label to test pipeline performance. The labels include 0 for healthy plant, 1 for the plant need fertilizer, and 2 for plants that need chemical treatment. This can be seen in detail in this figure. In the future, we plan to replace this conditional makeup with expert or semi-automatic makeup. The data is split into training 18% and test 20% samples one before of training cycle. In this figure, the 10 to 10 square that presents the fields in show. Horizontal and vertical planes is normalization field dimension. On the right side, the color scale show represents the color indication of the plane state. This number 3 or red color shows the plant is damaged by the disease. In this case, chemical treatment is required. In this show diagram, this technical training of the random forest classification and have 3 case explanation. This is 10, 100, 1000 apple. This allowed by elevated classification ability to generalize the plan condition over various during this learning. This firstly is 10 epoch. During the initial phase 1-3 model accuracy fluctuates between 40 and 65%. However, as highly attained by the 5 epoch, performance leveled of around 40%, demonstrating that such a small number of iteration and discrimination future from input vector. Scenario 2 is this 100 epoch. In this scenario with 100 training epoch, and during the first 10 15 epoch, classification accuracy fluctuated between 45 and 60%.
By the 30 epoch, this model stabilities reaching a coverage accuracy around 53%, and this Latino indicates the classification CAD reaches its generalization limit under the training configuration, and fuse learning only marginal upper movement. And three scenarios is 1000 epoch. We can training this three discrete learning phases. Epoch 120, the security increase from 40 to 45 with significant fluctuation. Epoch 20, 200 rapid liners crowns in security was observed, peaking at 65% with decreased variance. And epoch 200, 1000, the accuracy plateau at 62% with minimal fluctuation, suggesting that the model has fully learning all meaningful pattern present in data set. To train this model, we use a real picture of the field the tritium irisum. The visual diagnostic was made using the UAS with camera mounted ETS. The picture is tritium area that contain characteristic presence of the symptoms or damage by disease or suffering from last control were used as well. The result of the research also demonstration the potential of integration of modern technology, including UA's artificial intelligence and machine learning, into the agricultural fleet for people activity, allowing the advantages of considered technologies for automatic monitoring and diagnostic of the plant and quick response to this action. Thank you for the attention.
Thank you very much. Please, questions to reporter. No questions? Again, I have question about slide number 8. Can you turn back your slides?
Yes, I share this. Number 8, yes? Or this
This.
diagram?
This very strange learning results.
This machine learning training, this firstly...
No any improvement. 1000 book, but result the same. It's not training, it's something.
Yes, it's not training. I think this training, machine learning, 1 month, 1 year needs for this. And machine learning need additional photo without functions plants, and this growing this process.
Maybe it's similar. Maybe you training very small set of data because it looks quite strange. Because no improvement.
Yes, it's not improve this start this using machine learning, using agricultural machine imaging, but it's very interesting in agricultural and farmers using this model and training and that's very nice for us.
What software was used for modeling?
I using Python.
Python, yeah.
Yes, Python is very easy. Machine learning is highly qualification, and it's nice for working.
And what you predict, it will be system oriented to be placed in UAV, or it will be somewhere in cloud, or how it should be powerful for
This
processing performance, how high it performance for recognition, what complexity of processes such.
with complex processing with drone, name it aircraft system, drone flight in a plane, and collects information from make photos
The
in plane.
process inside some plane or transmit data somewhere to
Transmit cloud.
to cloud.
Yes.
Then should it recognize data in real time during flying? Because it's maybe quite long process to process.
Yes, it's a long time processing. Yes, but machine learning will growing, will results. This growing and learning this in training on photos, training on video, training на всему.
On everything. Okay.
Yes, everything.
Thank you. Це та розмова сліпого з глухим. Let be no any questions, and we are going to next reporter. Who will be the next? Mazoret Subko. Who is present? Subko,
Yes, I'm here.
please. Augmented
Good
reality.
day.
Interesting.
Good day, dear colleagues. I'm pleasure to present to you the work named Augmented Reality Audio Stream Creation using CNN, boosting inclusion and safety for visual impaired people. According to the World Health Organization, there are about 2.2 billion people with visual impairments in the world. The main problems are difficulties with mobility, influences accessibility of the urban environment, limitation in the perception of information, and difficulties in social interaction. The development of new technologies will contribute to increasing inclusion and safety for people with visual impairments, and creation an environment that takes into account the needs of people with disabilities, and the create software will contribute to the achievement of sustainable development goals, in particular number 3, 10, and 11. Research goal is boost the inclusion and safety of visual impaired people by creating an audio stream of object and named persons, indefinite and classified from a video stream using a deep convolutional neural network. The main paper contribution is the proposed method of augmented reality audio stream creation using CNN, which differs from existing ones in the one classifying objects in a video stream. It is able to recognize named persons among them, which contributes to increasing the level of inclusion. In this slide, proposed a general approach to converting input information in the form of a video stream and a prioritized list of dangerous objects for people with visual impairments into output information in the form of an audio stream. In accordance with the presented approach in previous slide, a diagram of the method is shown in this slide. As part of the conducted research, the use of YOLO neural network models for identification and classification of objects from the video stream and CNN for classification of named persons is proposed. The method processes the video stream using neural network models to identify objects and classify named persons. The process begins with processing with the video stream to prepare it for object detection. The identified objects are classified, filtered based on a confidence threshold, and if a person is detected, processed to face recognition. Named persons are classified by detection of facial boundaries and calculation confidence scores. The system then generates audio output for a reason dangerous object for voiceover. To classify a named person detection in a frame from a video stream, a cascade hard-based classifier detects the face boundaries within the bounding box provided by YOLO. If no face is detected, the classification of named person is skipped and only the word person is announced in the audio output. If a face is detected, a CNN model classifies the person and the outputs the name of the person. To test the presented method, it is necessary to study the existing pre-trained YOLO neural network models, as well as to investigate the influence of the batch size and the number of epochs when training the CNN model on the accuracy of the classification of named persons. In the process of experimental research, tests of wearables creation for creation an augmented reality audio stream to study the models, the COCO dataset was used. To study of object classification on stage 2 of development method, the YOLO versions were compared, which are pre-trained to classify 80 environment objects. The models were compared using the matrix accuracy, precision, recall, etc. This slide shows the result of calculated macrometrics. As can be seen from this slide, the YOLO 11X model demonstrates above average prediction accuracy for each class, but for some classes, such as bicycle and traffic light, it's demonstrated lower values than for other classes, which is associated with the complexity of their detection. As part of the study, FPS was calculated for models, which allows us to assess their stability for real-time application. The models were tested on the same video contained scenes with people and cars. The result of FPS calculation are presented in the slide. The best results are shown by YOLO 11X. For the classification of named persons, the CNN model was trained to identify 90 named persons, and a separate class was other persons, in which photos of different persons were mixed, which we taken in the amount of 50 photos from the open source dataset. According to the result presented in table, the optimal values of batch size are 32 and the number of epochs is 16. Science with these parameters, the highest classification accuracy of 97% is achieved. The result of CNN model for the classification of named person demonstrate high accuracy. In particular, the micrometrics indicate sufficient accuracy and completeness of recognition for each class. The CNN model's limitation include reduced confidence in classifying named person when the face is at 3/4 angle or in profile due to insufficient recognition features. Glasses and masks lower classification accuracy, while head BR doesn't. Another limitation is the lack of distance measuring algorithm, leading to difficulties in correctly identifying objects that are too close or far. Perspective distortion can cause mystification or omission, especially for distance objects like cars. For named person classification, accuracy heavily depends on face quality and size in the frame. Approach for boost the inclusion and safety of visual impaired people by creation method of augmented reality audio stream is proposed, which creation which contains object and name a person identified and classified from a video stream using CNN. Development method different from existing ones by two advantages: ability for classifying named persons in the video stream for boosting the inclusion of visual impaired people, and ability to consider of preterist dangerous object one generation audio stream for boosting the safety of visual impaired people. By this method is contribute to achieving SDGs number 3, 10, and 11, obtaining the applied comparison results of neural network models revelate that YOLO 11X model is better suited for object identification and classification in environment. Obtained the applied results from CNN model macrometrics indicate high quality classification of named person. Thank you for your attention.
Thank you. Interesting. And how such impaired person will use such system? Taking camera with him, or it will be on some phone, smartphone, and so how do you imagine such using system?
Thank you for your question. People can use our approach by implements in smart glasses or smart sticks or maybe in a mobile phone.
Mm-hmm. Okay.
With AI.
Then person will recognize only people who he knows or she knows already, and the system already learned that person.
Thank you for question. Person with visual impairments can add people who
knows already.
which they want to recognize, or we can also add some people, some popular people to our system for recognize by our approach.
Maybe it can be used to recognize also situations, some table in front of me, chair in front of me, some refrigerator in front of me, and so on.
Yes, it's a good idea. We can add this functionality by our future work on this method.
But you presented table with different data for YOLO of different versions, but it seems to me such data already exists somewhere in the internet.
Yes.
Different objects and different version of YOLO.
Yes, we use version YOLO. We don't train it for another object, but in future work we can pre-train it for some object which doesn't include in existing models.
Okay. Do it could be very useful for such kind of people. Thank you very much. Maybe somebody else Want to comment or ask? No. Then thank you again.
Thank you very much.
And we are going to next reporter. It should be Hovorushenko, Pavlova, or somebody from that group. Other, it seems to me, is absent. Therefore, let we go already to next reporter, Veres. Olha Koch, I see is present. Please.
Yes, I'm here. Nice to hear you today. Nice to visit such a great conference. So let me to present the results of our research. If you don't mind, I will be without camera share. Okay, hope that you see my presentation.
Yes, we see.
Okay. So today our topic is choosing the best location for a trip based on the TOPSIS method. All of us wants to have a rest, wants to travel, and has some problems to manage it, to organize the trip, and we decided to form such propositions how to optimize this process. So traditional selection methods often reliant on recommendations or superficial assessment frequently overlook significant factors that can impact the quality of the travel experience. This oversight increases the risk of traveler dissatisfaction and inefficient resource allocation. This study focuses on the decision-making process involved in selecting the optimal travel location through a multi-criteria assessment. This process entails analyzing and evaluating various tourist destinations based on an array of criteria, including cost, safety, climate, and cultural or historical attractions. So, tourism, as one of the most dynamic sector of the global economy, continues to grow rapidly, stimulating social and economic development. And an important factor contributing to this growth is the development of information technologies. On the slide, you can see a few statistical data. Most of them are calculated before the COVID crisis, so a little bit late. But nowadays difficult to compare because of the war in Ukraine and not enough statistic in this way. So it's in general what we have found that a lot of people use information technologies to manage the trip, to organize it, and to find some information. Here you can see the results of analysis of existing tools and solutions, which are mostly used by tourists when they manage their trip. So they often use Booking, TripAdvisor, Airbnb, Kayak, also other services, because when they select, they try to find the best results and the best feedback from these services when they try to compare, try to choose, try to find where to travel and how to travel. Multi-criteria decision-making offers a structured and objective approach to evaluating alternatives based on multiple criteria simultaneously. And this methodology enhances the decision-making process by fostering informed and transparent outcomes, thereby minimizing subjectivity and potential errors. Among the widely recognized methods of multi-criteria analysis are the analytic hierarchy process, the elimination and choice expressing reality method, the preference ranking organization method for enrichment evaluations, and the technique for order preference by similarity of ideal solutions, or this TOPSIS method, which we will talk about today. The TOPSIS method is conjunction with contemporary data analysis technologies can greatly enhance the quality of service within the tourist industry. This highlights the importance and practicality of for the research and development of decision support system aimed at selecting travel locations using the TOPSIS method. So there is a need to develop a system that simplifies the process of identifying and choosing the optimal travel destination, aiding individuals in making informed decisions through an objective assessment of various tourist locations. The primary goals include creating a tool that accommodates the needs and preferences of travelers while offering a thorough and efficient evaluation of alternative destinations. The proposed application enables travelers to easily and effectively select the best location for their journey by allowing them to customize personal preferences and criteria, receive tailored recommendations, and explore detailed options. To successfully implement this system, it is critical to define its key components and their interactions, and all about input data, output data, system features, database, functional and non-functional requirements. You can find in our research, so there are a lot details about these components of model. To identify the optimal approach for developing a decision support system aimed at selecting a trip location, it is essential to explore various alternatives and assess them through morphological analysis. And we created various logical and practical combinations of parameters that represent different system options. You can see it on the slide. And to select the best alternative, it is essential to establish evaluation criteria that reflect the system key requirements, such as user convenience, data accuracy and relevance, personalization options, development and support costs, monetization opportunities, prospects for development, and scalability. We assessed each option based on defined criteria, assigned points on a scale that enables us to compare alternatives according to the adherence to established requirements. And the best option is alternative 1, which involves developing a web application with a graphical interface that utilizes its own database for obtaining up-to-date locations data. Also, we formed a use case diagram which helps identify and describe the primary scenarios in which the system will be used, which is vital for defining its functional requirements. And to gain a clearer insight into user interaction scenarios, we have created simple use cases for our application. Also, we formed activity diagram, which illustrates the sequence of actions, conditional transactions, and parallel processes, showcasing how different activities interact to achieve a specific objectives. Also have to say that multi-criteria decision analysis methods are utilized to choose the best option while considering various conflicting criteria. So we have analyzed method without weighting factors such as Pareto method and lexicographic order method. We analyzed methods with weight factors such as weighted sum method, weighted product model, multi-objective optimization based on ratio analysis, graph theory, and matrix approach. We have analyzed methods of distances to the reference solutions, such as technique for order or preference by similarity to ideal solutions, our TOPSIS, wise criterion optimization And next group was methods based on pairwise comparison, such as analytic hierarchy process, elimination, and choice translating reality. And the last group was methods of physiologic and artificial intelligence, so such as physioanalytical hierarchy process, physiotopsis. A comparative analysis of various multi-criteria decision-making methods you can see on the slide. So to conduct an objective assessment and effective ranking of tourist destinations, we choose the TOPSIS multi-criteria decision-making method. Details of it and example of implementation you also can find in full text of our research. So now we can illustrate how we integrated the selected method and tools to develop a functional application that meets user requirements and effectively operates the TOPSIS algorithm in a real-world environment. Supabase was utilized for backend and database management. It is an open source backend as a service platform that provides instant APIs and real-time functionalities built on PostgreSQL. Supabase simplifies database management by offering an intuitive interface that seamlessly integrates with front-end application. It was selected for its ability to deliver a scalable and secure database solution without requiring extensive infrastructure management. The TOPSIS algorithm was implemented using the Python programming language, which offers flexibility and easy of integration with other web application components. The implementation is organized within the TOPSIS class that includes methods corresponding to various stages of the algorithm. And to ensure high availability and scalability, the TOPSIS algorithm was deployed separately on a server hosted in the Amazon Web Services cloud infrastructure. So this approach has several significant advantages. First, AWS Cloud Service makes it easy to scale computing resources depending on the load, which ensures stable operation of the application as the number of users increases. Secondly, the use of cloud infrastructure guarantees high service availability and minimal downtime due to the distributed architecture and automatic disaster recovery. And in addition, AWS offers a wide range of tools to ensure data security, including encryption, access control, and security monitoring. Placing the algorithm on a separate server also makes it easy to integrate it with other components of the web application via APIs, which simplifies system development and maintenance. Finally, the use of cloud services allows you to optimize the cost of maintaining and updating server hardware, as AWS takes care of most operation tasks. The web application plays a key role in ensuring that the decision support system is accessible and easy to use for a wide range of users. And intuitive and efficient user interface makes it easy to interact with the application, customize selection criteria, receive recommendation, and view details, location information. The web application was developed using the React front-end framework and the TypeScript programming language with Supabase and AWS integration to provide backend functionality. Also on the slide, you can see main libraries which were used to implement the application functionality. And the application's functionality includes the ability to log in using user interface, user can customize and save its criteria for selecting locations with an interactive slide that features multiple components. So a lot of possibility what to do in the systems, and you can see the main list on the slide. The screenshot of the criteria setting screen shows an interactive slider and a pie chart that allows users to set and visualize the weight of different location selection criteria. It's about screenshot A. A screenshot of the results shows a list of recommended location organized by a degree of compliance with the established criteria. It's a screenshot B. And finally, screenshot of the individual location shows details information about selected location, including a description, photos, and ratings. Yes, it's screenshot C. If to conclude, we can say that the research presents a decision support system for choosing the optimal location for travel based on the TOPS method. An important component of the development process was the use of system analysis tools. The developed system allows users to customize the criteria for selecting tourist locations, set weighting factors, and receive personalized recommendations based on multi-criteria analysis. The integration of the TOPSIS algorithm ensures the objectivity and accuracy of the assessment of alternative, which is confirmed by a benchmark example of the application. Users can quickly and conveniently receive relevant recommendations, which increases the efficiency of travel planning. The use of modern technologies such as React and TypeScript for front-end development and Supabase for database management contributes to the creation of a productive and scalable application. And the results of using the system demonstrates its effectiveness in providing users with relevant and informed recommendation on choosing a travel destination. The system is only an initial and basic implementation. Prospects for further development of the application include expanding the database of tourist location and criteria and integration with external services to obtain up-to-date information such as weather, ticket prices, user reviews, and so on and so on. So there are enough ways how to develop the system and how to develop the way how to choose your location and your way how to travel. So it was the main results of our research. Thank you for your attention. Maybe you have some questions.
Thank you. Thank you. Please, questions to Dr. Olga Kots.
Everybody's tired.
Yeah. What the perspective of your system? Maybe what
Yeah.
you already.
Yes, I understand. As I see, the main perspective is in integration with other systems. For example, not looking just for hotels, but also adding the possibility to find the traveling data, yes, how to get to the hotel. Not only finding hotel plus train or something else, but some possibilities to visit interesting places, to visit places for having dinner, because when you travel there where you have never been, you don't know the place, you don't know where to go, you don't know how to spend your time. So if it will be integrated together, where to live, how to get there, where to spend your time, how to relax, to meet with somebody else or something like this, especially historical places, it would be really good for not only for Ukrainians but for all people which like to travel.
Okay, but you're not afraid that data time to time will be not actual. Every time prices changes, new places appears, but you have database must be somebody.
I think that nowadays, when information technologies are developing so rapidly, it's possible to combine and to live in up-to-date data and to manage it and to add new possibilities, locations, managing the system. Because in other way, it's not no future for the system. Because everybody wants to see new locations, new possibilities, up to date. As we see it in Google Maps, as we see it in booking website or somewhere else. So I think it's possible, and it must be possible.
Okay.
Thank you.
Thank you. Anybody else have questions? No. Now, if Hovrushchenko and Pavlova are absent still, we already end our list of reporters. And let me thank you, all of you, for your reports. And we meet again. We have some break and meet again at 5 o'clock to end the workshop. Yeah. 5 o'clock round table and closing ceremony. Okay. See you later at 5 o'clock. Break. Thank you. Dear colleagues, let me continue our workshop. Now we have a few minutes for round table, so-called, and some closing ceremony. I want to thank to all connected to our workshop. It's already 7th workshop, as you know. And I'm afraid it's almost last one. Of course, conditions are very complicated to organizing. For example, one of the conditions is only 25% could be represented from any organization. Therefore, it's quite complicated to build composition of participants to fulfill such condition. We cannot include many participants from our native organization. And I'm not sure it's effective to work and problem also with publication of results. I'm not sure that everybody listen me. Vasil Litvin is present or absent? I see he's present, but is it listen me? No, maybe. Okay. Thank you very much, Professor Mikhail Emmerich, because he's ideologue, leader of our workshop, and without his participation, the workshop is impossible, first of all. Secondly, I want to express my gratitude to absent here now Michael Luchkevich, head of organizing committee. He connects all of you and collects all your works and coordinates the whole materials. And now a stage of additional review of materials before we will prepare material for CEUR VS. I must say that additional review process will be organized now, more rigorous, because such demands from CEUR editorial board. And maybe not every work will be included in proceedings. Okay, somebody listen me, somebody not, but so reality. Maybe you have any suggestions or comments, please. You have possibility to express. We record our meeting, and who absent now will listen later, I hope.
Excuse me.
Please.
Just had a quick question. Are there any estimations or exact dates when the proceedings material would be available, if you know? If you don't, that is
Yeah,
perfectly
of
understandable.
course, you will be we will have possibility to correct something if you want. Even we should some corrections connected with new template should be done maybe, because we expected that not all. Я перейду на українську мову, тут, по-моєму, нема нікого з-за кордону. І Михайль нас не чує. Значить, в зв'язку з тим, що не всі вимоги шаблону дотримані, можливо, будуть прохання редагувати знову статтю. Зокрема, чи всі поправили, додавши останній розділ щодо використання цього генеративного штучного інтелекту. У ваших працях має бути вказано ступінь використання генеративного штучного інтелекту. Це обов'язкова умова. Якщо цього ще не зроблено, вона має бути додано у вашій праці.
Супер, дякую.
Я не знаю, як там з відсотком прийнятих відхилених, бо там теж є якісь умови. Але, в принципі, ми дотримались пропорції такої, щоб не було більше як 25% з однієї організації. Тому ми розділили воркшоп на дві частини. Оцей воркшоп з 28 доповідей, і завтра відбудеться ще 9 доповідей, які є аспірантською конференцією, яка може бути, допускається ЦЕУРом як окремий захід при конференції. Тобто участі докторантів і аспірантів. Це окрема частина, яка відбудеться завтра. Можливо, матеріали теж будуть друковані окремо. Але окремо ще ми маємо пройти рецензування. У нас є час на те, щоб праці публікувати. Там ЦЕУР вимагає не більше як 2 роки від самої конференції до подачі в ЦЕУР. Ну, ми не будемо 2 роки тягнути, але не виключено, що цей борт ЦУРа піде у відпустку, так мене попереджали. І якийсь час вони будуть відсутні і не зможуть розглядати наші матеріали. За той час ми підготуємося. Ось такі справи.
Дякую за інформацію. Це дуже цікаво і важка робота загалом.
Так, так. Ми, як ви бачите, змушені були переключитися від EasyChair до Microsoft CMT, так? Content Management, не Content, а Conference Management, що там, CMT. Систему збору даних і так далі, координації конференції, бо вона безкоштовна. Минулого разу нам довелось заплатити порядка там, я точно не пам'ятаю, від 400 до 800 євро за просто користування і за користування EasyChair. При тому, що ми не збираємо членських, ну чи як то, за участь реєстраційних внесків. І фактично витрати покрив Михайло Емеріх, якому ми далі винні хоча б частину грошей повернути. Але з України ми не можемо перерахувати гроші, тому поки що є затримка. І ми в боргу перед нашим головою. Ось. Ще раз дякую учасникам за вашу участь. Перепрошуємо, можливо, за якісь незручності і за таку невпевненість в результатах, але ну, така ситуація. Зараз я маю відеозапис цей зберегти, і я надіюсь, що він нормально запишеться, тому що ще обов'язкова умова оці відеозапис нашого воркшопа представити, якщо буде потреба на перевірку. І ще він підлягає обробці. Ці процедури ще потривають. Будемо розмічати сам відеозапис і розміщувати його онлайн, наскільки я розумію. Отже, чи є до мене ще питання, якщо, чи взагалі для програмного комітету, оргкомітету і так далі? Немає. Я дуже вам дякую. Надіюсь, що ми ще зустрінемося, можливо, в іншому форматі. Можливо, нам вдасться знайти інший спосіб публікувати матеріали, які би індексувалися в Scopus, але поки що ми орієнтуємося на ЦУР. Дякую. До наступних зустрічей.
Дякую.
Дякуємо.
До побачення.
До побачення.